Hello friends, hope you are having a fantastic day today. So now we are going to learn an entire full course on array as a data structure. By the end of this course, you should be an expert in all the questions related to arrays, and we are also going to solve 25 most tasks, most popular, most like LeetCode problems by the end of this course. These questions are asked at tons of FAANG and non-FAANG companies, like thousands of times. So now without any delays, let's get started. First, let's try to understand that what an array is. Array is nothing but a continuous block of memory that is currently stored inside your computer. Now, inside this continuous block of memory, you can store integer data type or boolean data type or string, character, whatever you want to put. You can store these values, but arrays have some restrictions and some properties. Number one restriction in an array is that it is a fixed type of data structure. So whenever you are storing the information, you need to define that what is going to be the size of this array. So currently this array that I have provisioned can only hold up to 5 distinct values. Second thing is, everything inside the array is defined by its index positions. So in this case, for this array, the index values would be defined as 0, 1, 2, 3 and 4. On top of it, because this is a fixed size and also all the values are continuous in nature, I can fetch any particular index position values in constant time. One of the other thing is computer knows that what is going to be the memory size for each of these blocks. So let's say that this block cost 8 bytes of memory to be stored inside the computer. Also, computer knows the starting position of this particular memory location. So let's say that inside the memory of computer, this one is defined by 1600. So logically, if we have to access this value, the position is going to start from 1608. Same way, position for this is going to start from 1616 and so on and so forth. So that's why this makes array unique and fast in terms of nature. Let's understand the categorization of different data structures and where does array falls into it. Well, data structures can be divided into two major categories: primitive and non-primitive data structures. Primitive are your typical integer, float, character and boolean values. For non-primitive data structures, we have linear and non-linear data structures, and amongst linear data structures, we have our very popular superstar array sitting right here. We have stack, queue and linked list as well. But the thing is, array is unique in terms of, because this is a fixed in terms of size. All of these other data structures, they are dynamic in nature. Now let's learn that what are the different array operations that we can perform and also what are going to be its time complexities. So first operation that we would like to see is access. That let's say that if there is some element that resides at position number 2 or position number 3, how quickly can we access? We just explained that this can be done in big O of one time and fetch the value that we are looking for. For the insertion, typically in normal scenario this works in big O of one time, but worst case time complexity can be big O of n, because we are trying to find a space where we need to insert the value. So if it is a random insert that we don't know that whether we have an empty space or not, or if we are trying to make frequent modifications, we might have to shift values inside the arrays as well. Same goes for the deletion, that because we are deleting some elements from the array, we will have to shift the cells here and there. So in that case, worst case scenario, it can be big O of n, but typically most of the languages handle these scenarios in relatively simple fashion, and average scenario is going to be big O of 1 for both of them. Now, traversing an array is very straightforward. You simply start from the starting pointer and keep going in one direction until you reach to the very end of the size of the array, and this can typically be done in big O of n time, where n is the total number of elements present, because you will have to iterate over every single element in order to access them. Searching is also quite an interesting one. Let's say that currently this array contains 5 different elements, and you're trying to search that whether any particular element resides inside this one or not. Let's say that you are trying to see that whether element number z is present or not. So in this case, if these values are not sorted and these are random values, then you must do a linear search, and a linear search is only going to yield big O of n result, because you will have to reach or search every single value. Or you can do something called a binary search if the given values are sorted. So you can see in this case the given values are sorted lexicographically. So we can actually apply binary search in this case, and we can solve this problem in big of log n time. And don't worry about these things, you are going to see tons of examples of these things in action, so it would become a second nature to you. And last one is an update. So if you have to update any particular element, let's say that instead of this x, I want to update this value to be m. So I can do this instantly because I can reach or fetch that element. So number one benefit of an array is that we are dealing with random access time complexity of big O of 1. So if we have to access multiple values from the array, we can do it in big O of 1 fashion. That this is going to be really helpful in certain scenarios. Next thing is, array is a wonderful cache friendly data structure, which means you can see lot of different operations where array becomes a supporting data structure for the main problem we are trying to solve. We can use array very heavily in dynamic programming problems. We can use array with graphs, trees, and all the other data structures to in order to store some valuable information that we are trying to memorize, or using it by tabulation. Next thing is, we can very easily sort values inside the array. And next thing is, array is very popular in implementing other data structure. You can implement heap, you can implement tree, you can implement linked list, you can implement stack, queue, all of these things using different ways to modify and manipulate arrays. So arrays are overall very diverse data structure. Now let's see some limitations. Number one is, because arrays are fixed size, there is only so much you can do. If you are dealing with some dynamic problem where the value are continuously increasing, and if you are trying to use array, then it becomes obsolete, because every time you are going to be facing an issue where array runs out of the size. So you can only use array until you know for sure that the size is going to be fixed. If you have to deal with dynamic scenarios, you can use something called array list, where inside the array list it helps with like dynamic nature, but there is a whole separate discussion on its own. Next thing is, for typical insertion and deletion, worst case scenario, it can go into big of n if you don't know where you are trying to insert those elements or delete those elements from. And next thing is that it is very inefficient in terms of frequent modifications. Now let's see that what are some of the common use cases where you should start think about using array for various different purposes. Number one use cases that I just explained is to implement other data structures, because array is simple and can be modified in many different ways. Next thing is, whenever you see any kind of caching or tabulation or memoization item that you need to perform, you must start to think about using an array. Third thing is, whenever you are dealing with graph problem or tree problem and you need to keep track of visited nodes, then you can also think about using an array. Then whenever you need to do some sort of mathematical computation, you can also use an array. And one good thing about array is that it has lot of popular coding patterns. So coding patterns such as two pointers, sliding window technique, then a fast and slow pointer, and all of these things can be used in many different ways that can become really helpful. And we are going to see all of these in action when we do our 25 most popular most asked questions. Now, arrays also comes in multiple dimensions, not only one dimension. So far we have seen all the arrays that typically looks like this, where we can define this as one dimensional array, where you can notice that every single cell only is being defined by one particular index position. Now there can be scenarios where we need multiple categorizations to define any particular cell value, and for that we can actually use multi-dimensional array, where this would be an example of 2D array. Same way we can have a 3D array, we can have a 4D array. So let me give you a common scenario. Let's say that I just want to say that whether any particular student is present or not. So I can create an array like this, where I'm storing a boolean information, and in each of the scenario I am marking all of these values based on the student roll numbers or ID numbers. So this becomes a one-dimensional array problem that I can solve easily. But now I want to create a matrix of information such as grades for every single student on top of it their roll number. So I want to define each of the cell based on their grade and roll number. So I can create one entire section of grades starting from A to F, and same way I can have another section for a roll number starting from 1 to 3 all the way up to n students. Now any particular cell in this position is going to define that this cell defines that for roll number 3 whether that student got B grade or not. So this can be another way of categorizing values, and this also contains the same property of fast access and all of the good stuff that array has to offer. So typically for any DSA problem and technical interviews, we are only going to be dealing with 2D arrays, but in theory and also in practice we see all the time 3D and 4D arrays as well. 5D arrays very rarely, but this is something to just understand. And now we are going to go to the most awaited and most important section of this entire course, and that is going to be the 25 most asked, most popular and most common LeetCode problems. And trust me, these are the most popular problems of all times. So if you can complete these 25 problems, I can guarantee you that you will never fail any particular question from array domain. So without any delay, let's get started. Today we are going to do the number one problem inside the LeetCode, which is two-sum problem. And this question has been literally asked by hundreds of companies, hundreds of times. Any company that you want to get a job of at least have asked this question at some point in their history. If we see the list of companies, it's like Amazon, Adobe, Google, Apple, Microsoft, Facebook, Bloomberg, Uber, Expedia, Spotify, Goldman Sachs, and then also companies like TCS, SAP, Square, Snapchat, ByteDance, Twitter, ServiceNow, and these are just some of the companies that are my dream companies that have already asked this problem, and that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode easy problem and probably the most liked problem on LeetCode. Basically we are given an integer array of numbers, and we are also given an integer value target, and we need to return the indices of two numbers such that they sum up to this target value that we are given. So if we try to understand this with an example, suppose we are given the values like 2, 7, 11 and 15, and we are also given a target value is 9. So in this case, we can clearly see that this 2 and 7, if we sum that up, it becomes 9. And that's why in this case, we need to return the index values of this one. So index values would be 0 and 1, and this would be the answer we need to return. Also, in the another example, we are given the values as 3, 2 and 4, and we are given the target value to be 6. Now because the target value is 6, we can actually do 3 plus 3 equals to 6 as well in this case, but this is not the correct approach because we only have 1 3 and we don't have the other 3. So this would not be the correct solution. The correct solution would actually be 2 plus 4. So if we do 2 plus 4, it would become the 6. So that's why in this case we will need to return the index value as 1 and 2, and this would be the answer. It's really easy to understand the problem statement. Let's see that what could be the different approaches to solve this problem. Okay, so first of all, we are going to solve this in brute force way, and the idea is that at any point we are iterating over, we need to find that what is the remaining value from this target number. So suppose we are checking that whether 1 exists in a pair that sums up to this value number 13. What we are going to do is we are going to do 13 minus 1, so we will get the remaining value as 12. Now we need to check that whether inside the remaining portion of the array whether this 12 exists or not. So if 12 exists, we can actually return the index values, but in this case 12 does not exist. If we iterate over all the values, so we can simply return simply ignore this first case, saying that there exists no pair where 1 is part of it which sums up to 13. Now we will start repeating the same process for the remaining values. So now we are at this value number 8. Again we will do 13 minus 8, so the value becomes 5. Now we will check that whether this 5 exists inside the remaining array. So we will check the remaining values, and we can see that 5 already exists over here. So because 5 exists over here and 8 also exists over here, we can return the index values. So in this case, the index value for 8 is going to be 1, and index value for this 5 is going to be 4, and this would be our answer. So this solution would work perfectly fine, but what is the issue with this solution is actually the time complexity is going to be big O of n square. Why n square? Because notice that for every single element we will have to check all the other elements that whether a certain remaining value exists or not, and we could repeating the same process for all the elements. So that's why this is the big O of n square time complexity. The question is, can we do something better? And the answer is yes. Let me quickly show you how. Okay, so we will use the same example. Now, previously, we know that in the brute force, we were doing big O of n square time complexity. Why? Because at every single element, if we wanted to find that, okay, for the remaining value, this is going to be 13 minus 1, the remaining value is going to be 12. So in order for us to find this remaining value, we had to iterate over all the places inside the given input array. But what if we can shorten that time? And one way to do is that whatever this given input is, currently it is unsorted. If we sort this given input, so the sorted value or the sorted array would become something like this: 1, 2, 5, 8 and 15. Now this is the sorted array. Now what we are going to do is our target is still going to be this value number 13, but rather than checking those remaining values inside this given original input, we are actually going to do it inside the sorted input. And let me quickly show you how. So first of all, we are going to do, okay, this value is 1, so we are going to do 13 minus 1, so the remaining value is 12. Now we need to find that whether 12 exists inside the sorted array, and this can be done actually in log n time. Why? Because we are going to do binary search, because this array is sorted, and we know that binary search actually takes log n time, which we can do it pretty quickly. So immediately we identify that, okay, 12 does not exist inside this given array, so we will ignore this and we will move with the next element. So now this 1 does not need it to be tested. We will check for this value number 2. So we will do 13 minus 2. So 13 minus 2 is actually going to be 11. So 11 also does not exist, and because 11 does not exist, we can ignore this value number 2 as well. Now again we will check for this value number 5. So when we do 13 minus this value number 5, the remaining value becomes 8, and we can clearly see that, okay, 8 exists inside this given sorted array, and because 8 and 5 exist, all we need to do is we need to return the index values. So then we will iterate over this given input, and we will try to find the index values of this 8 and 5, which we can actually do it in big O of n time, and that we can simply return whatever the index value is, and that would be our solution. So this approach is actually much better improvement than whatever our brute force approach was, which had big O of n square time. But what are the issues with this approach? So if we see the time complexity, in this case, the time complexity is actually going to be big O of n log n to convert this original input from its original form to the sorted form. And then it takes log n time to perform binary search, and then it takes big O of n time to find the index values. But all of that can be generalized to say that, okay, we need to complete this in big O of n log n time. Now the question is, can we do something better, and can we do it in a linear time? And the answer is yes. Let me quickly show you to you how. Okay, so again we are going to use the same example, and what we are going to do is we are going to use a hash map. Now inside the hash map, we are actually going to store two items as key value pair. So as the key, we are going to store the numbers inside this given array. So we are going to store numbers as a key, and we are going to store the index values as the values for those particular numbers. And what we are going to do is, first of all, we are going to do, okay, at any position we are going to find the remaining value. So we are going to do 13 minus 1, so the remaining value in this case is going to be 12. And now we will try to see whether this 12 exists inside this given hash map, and that can be done in constant time, because that is the property of hash map, that is the beauty of hash map. So we will try to see, okay, so 12 does not exist in this case. So because 12 does not exist, we will add this value and its index position to this hash map to see that whether in future we can use it or not. So we will add the value as 1, and we will add the index value as 0. Again we will repeat the same process. So now we will move on to the next value. So the next value in this case is going to be value number 8. So 13 minus 8, the remaining value is 5, but 5 does not exist inside the hash map yet. So we will add an entry for this value number 8 and its index position as 1. Again we will move on to the next value. The next value is 15, so we'll do 13 minus 15. So 13 minus 15 is actually minus 2, and minus 2 does not exist over here. So again we will add the value number 15 to our hash map. So we will add an entry called 15, and the index value is 2. Again for this 2, the 11 does not exist, so we'll add an entry for this 2, and the index value is 3. Now when we are at this value number 5, we will do 13 minus 5. So 13 minus 5 gives us the value as 8. Now in the hash map, we can clearly see that 8 exists over here, and its index position is this one, and we are iterating this 5, so we know that what is the index value of this 5. So we can clearly return the value of this pair as 1 and 4, which is the corresponding index values of this 8 and 5, and that would be our solution, and this answer would be the perfect solution. If we see the time and space complexity, in this case the time complexity is actually going to be big O of n. Why? Because we are iterating over this given input just once, we don't have to do anything else. If we see the space complexity, in this case the space complexity is also going to be big O of n, because we have to create this additional hash map and we have to enter all the numbers that are present inside this given hash map, inside this given array, and this would be the most optimal solution. Let's move on to coding now. So first of all, we will create a hash map to store the integer values. Once that is done, we will create a for loop and we will iterate over the given input. And first of all, we will calculate a variable called difference, and for this difference variable we will do target minus whatever the current value from the array we are at. And then we have to check that if the value exists inside the hash map that we have created. If it does exist, we can actually return, and if the value does not exist, we can actually add that entry to our hash map. And now out of the loop we will simply return null, because then otherwise it will give us an error. Let's try to run this code. Okay, seems like our solution is working. Let's try to submit the code. And our solution is actually pretty efficient. It's almost like 99% faster than all the other solutions, and I would be posting this in the comments so you can check it out from there. Today we are going to do best time to buy and sell stocks LeetCode problem. This question has a very real life practical application. That is why it is very famous amongst IT companies as an interview question. If we see some of the companies where I want to work at who have already asked this question, there are companies like Amazon, Microsoft, Facebook, Bloomberg, Google, Goldman Sachs, Apple, Uber, Snapchat, Yahoo, ByteDance, DoorDash, eBay, Netflix, and Reddit. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is the LeetCode easy problem, and you can see that it has been one of the most liked problems on LeetCode. If we try to understand the problem statement, basically we are given an array called prices, where any single value inside this given array indicates the price of that particular stock and on that particular day. Now we want to maximize our profit by choosing a single day to buy the stock and choosing a different day to sell the stock sometime in the future, and our aim is to maximize our profit. So if we try to see it with an example, suppose this is the example that we are given, where we are given 6 different prices for a stock and we are told that we need to maximize the profit. So I have drawn it on a graph over here so it makes things more easy to understand, and we know that at any given position it shows that what is the price of that particular stock. So initially the stock price on first day was price 7. Now on the second day the price fell down to price 1. So we are not making any profit, we are actually going down and we are losing the money. But if we see over here, so this day it's 1 and this day the price is 5. So if we see over here, between these 2 days we actually made a profit of $4. Again price fell next day to $3, and then again price rise to $6. So over here we lost $2, over here we again made some gain of $3, and at the end the price was 4. So over here again we lost $2. So the thing is, if we just do it like this, we don't get the maximized profits. Why? Because we are only seeing that what is the difference between every single day. But if we see that if we do something, if we buy the stock on this particular day, which means that we are buying the stock when the stock price is at 1, and if we sell the price when the stock price is at 6, so which means if we sell when the stock price is at 6, we can actually make a profit of $5. This is the answer we need to return, that this is the maximum profit we can make based on these stock prices. So let me show you that what would be the brute force approach, and then I will show you that what would be the optimal approach. So for the brute force approach, one thing we can do is that we take every single position of a buy and sell price for these given stocks, which means that we make every single pair. So first of all, we see that if we buy the stock at price 7 and we sell at price 1, again we sell at price 5, again we sell at price 3, and so on and so forth, what is the maximum profit we are getting, and we will create a variable called profit, and we will keep track that what is the maximum number we have found so far. Once we are done with this value number 7, we would ignore this case, and then again again we will repeat the same thing with value number 5. So we start buying, so we start that our buy price is at value number 1, and again we start checking all of the comparisons that what would be the profit, and eventually we would find a pair where buy value is 1 and sell value is actually 6, which means that we would gain profit of $5, and then we will return this as our answer. Like, this solution would work as expected, we will get the desired result. But the thing is, this is not the most optimal approach. Why this is not the most optimal approach? Because if we see the time complexity in this case is actually going to be big O of n square. Why n square? Because for any single entry we will have to take a look at every single entry in the remaining array, and we will iterate this process. So that is why it is a very time consuming process, and we need to find a way to do something better. And let me quickly show you that what would be the optimal solution in this case. So for the optimal approach, what we are going to do is we are actually going to see that when do we get the maximized profit. We only get the maximized profit when we buy at the lowest value and we sell at the highest value. So this is the logic we are going to apply over here, that we are going to buy the stock at the lowest value and we are going to sell the stock at the highest value. But the thing is, it is not as easy as finding like the maximum value and the minimum value, because in this case maximum value is actually 7 and minimum value is actually 1. We don't need to get the difference of these two values, because if we do that we will get an answer of 6. But the thing is, we are actually dealing with stocks, so we can only buy stocks in the past, which means that if we decide to buy a stock over here, we can only sell it afterwards. We can't sell it to some value in the before. So that's why that is one thing we need to keep track of, that we have to make sure that this linear property of buying and selling is maintained in this case. So what we are going to do is we are going to have a variable called buy, and that is going to keep track of what is the minimum value we have stored so far, and we are going to see that at any given moment whatever the minimum buy value is, if on that particular day we try to sell a stock, what is the profit we are getting. So let me quickly draw 3 variables over here. So we are going to have 3 variables called buy, sell and profit. Now first of all, we are at this position number 7, which means that we are buying the stock at 7 and we can't do anything about it because we don't have any way to sell it. So we will start with the second position. So now on the second day the stock price fell down to 1, which means that if we have already bought this stock at value number 7. If we try to sell it at value number 1, it really does not give much progress. But one thing we can do over here is that because today the stock price is actually low, we can reduce that whatever the buying price is from 7 to 1. So we will do that. So now the buy price is actually 1, and we are not selling anything, or we are not doing anything again. Now the next day the price of the stock is 5. So we'll try to do that. Okay, what is the 5 minus 1, which is the minimum price we have bought stock so far, and 5 minus 1 is actually 4, which is the maximum profit we have made so far. And we don't need to update this buy value because we have already bought it at a lower price than whatever the current price of the stock is. Now we will move on to the next value. So next value, the stock price is actually 3, which means 3 is still greater than value number 1, which means we don't need to update this value number 3, but we will have to check that whether we are making any greater profit or not. So again we will do 3 minus whatever this buy value is. The buy value is 1, so 3 minus 1, so the current profit we make is actually 2. But the thing is 2 is actually less than 4, which means we don't need to update the profit we have made so far. Now again we will ignore this case, we will move on to the next value. So the next value, the stock price is actually at 6, so stock price is now at 6, and now again we will do 6 minus 1. So 6 minus 1, selling price would be actually 5, and because this is 5 and this profit is actually greater than whatever profit we have achieved so far, so the current maximum profit we have made so far is 5. Now again the stock price is at 4, so again the selling price on this day would be 4, and we don't need to update the buying price because the buying price is already at 1, which is lower than 4. And now we will do 4 minus 1. So 4 minus 1, if we do, we still make profit, but this profit is only $3, and $3 is actually less than whatever the maximum profit we have made so far. Now we are at the end of our loop, and now we don't have any more values to iterate over inside the given array, which means whatever the result we have stored inside the maximum profit variable variable, we will just return that, and in this case we will return answer as 5, and this answer would work perfectly fine. This is like the most desired answer we need. If we see the time and space complexity, in this case the time complexity is actually big O of n. Why big O of n? Because notice that we are completing everything in a single iteration. And in terms of space complexity, for the space complexity we are not actually using any additional space apart from storing couple of variables, so that's why space is also constant. So that's why this is a very good approach. We are solving this in big O of n and big O of n time and big O of 1 space complexity. So first of all, we are going to initialize a variable called min, and we are going to give it the first value of the given price. We are going to create a variable called profit to note down the maximum profit we can achieve, and initially we are going to mark it as 0, and then we will update the value inside our loop. So now we are going to run a for loop across the given array. Now inside the given loop, first of all we will check that whether we need to update the value of min or not. So we will check that if the current min value is less than whatever the value of I is, then we will update the value of min. And also we will check that whether the current profit we can make by selling the stock on that particular day comparing with the min value, we will choose the maximum profit we can. And once this loop ends, we simply need to return the whatever value we have stored in the profit variable. Let's try to run this code. Okay, seems like our code is working as expected. Let's submit it. And our code is actually pretty efficient. It runs faster than a lot of other solutions, and I would be posting this code in the comments so you can check it out from there. Thank you. Today we are going to do contains duplicate LeetCode problem, and if we see some of the companies where I want to work at who have already asked this question, there are companies like Amazon, Adobe, Apple, Google, Microsoft, Facebook, Bloomberg, Uber, Yahoo and Airbnb have already asked this question, so that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode easy problem, and basically we are given an integer array called nums, and we need to check that whether this nums contains any duplicate values or not. If it contains the duplicate values, we need to return true. If it does not contain a duplicate value, we need to return false. So let's try to understand this with a couple of examples. So in the first example over here, we are given 4 values inside this array, 1, 2, 3 and 1. We can see that this number 1 actually appears twice, which means that there contains a duplicate. So in this case we will return true. If we take another example, in the second input we are given 4 distinct value, 1, 2, 3, 4, and all the values are distinct, so that's why there are no duplicate entries. So in this case we can return false. Let's see that what would be the different approaches to solve this problem. Suppose we are given an example that looks like this. Now in the brute force, what we are going to do is we are going to compare every single value with all the other values that are present inside this given array. So first of all, we will take this value number 1, and we will see that in the rest of the remaining array, does 1 appear again or not. If it does not appear, then we will move on to the next value, and again we will repeat the same process. So first of all, we will take this value number 1. Now this all these 4 values, they are not 1, which means we can define that 1 does not appear anytime in this given array. Now we check for this value number 2. For the value number 2, if we check over here, these two are not 2, but this is actually a true. So the moment we identify that there exists a value that we are already searching for, if that is present inside this given array, we can return true immediately, that yes, this input contains duplicates, and this would be the answer in this case. This brute force solution works as expected, but if we see the time and space complexity, in this case the time complexity is actually going to be big O of n square. Why n square? Because for every single element we will have to compare all the other remaining elements, and then again we will repeat the same process for all the remaining characters, which means that the time complexity becomes big O of n square. So let's see that how can we improve upon that. Now one way to improve our brute force solution is by using sorting. Let's try to understand this with an example. Suppose we take this input and we create a sorted input. We will get a sorted array that looks like this. Now inside the sorted array, all we will have to do is just compare any two adjacent values. So first of all, we compare this 1 with this value number 2. They are both not same, which means we can ignore this case. Now we compare this 2 with this next value, which is also 2, which means because these two are same, we can determine that there exists a duplicate in this case, and we can return true immediately. So if we see the time complexity in this case, the time complexity is actually going to be big O of n log n. Why n log n? Because we will have to convert this nums to this sorted array, and that takes n log n time. After doing this, checking that whether it contains the duplicate or not only takes big O of n time, but the thing is generically we can write this as big O of n log n. And if we see this time complexity, this is a much bigger improvement than our brute force approach, which had the time complexity of big O of n square. But let's see that whether we can do anything better with this and whether we can find an optimal solution for this one as well. Now for the optimal solution, what we are going to do is we are actually going to use an additional data structure, and in terms of additional data structure we are going to use a hash set. Now the idea is that first of all we will check that any value we are iterating over in this given input, if that is already present inside this hash set or not. If it is present, we can return true immediately. If it is not present, we will add that entry to the hash set and then we will start iterating over the next element with the same procedure. So let's see that in action. First of all, we will check for this value number 1. So 1 is not present inside the hash set, so we will add an entry called 1 over here. Now we are at this position number 2. 2 is again not present inside this hash set, so we will add an entry called 2 over here. 3 and 4 both are not present, so again we will add entry for 3 and 4 over here. Now again we are at this value number 2. Now when we check that whether it contains inside the hash set or not, we can immediately say that it exists inside the hash set because we already have an entry over here, and we can do this in constant time because hash set, the finding operation takes big O of 1 time or constant time, so that's why it becomes really efficient for us. So in this case we can return true immediately that hey, we are at the position where this array contains the duplicator values. And somehow if we reach to the end of this array and we don't find any duplicate entries inside this our hash set, then we can return false in that case as well. So if we see the time and space complexity, in this case the time complexity is actually going to be big O of n only, because we have to iterate this given input once, nothing more than that. If we see the space complexity, in this case the space complexity is actually going to be big O of n as well, because we have to create an additional data structure hash set where we will store all the elements that are present inside this given input. First of all, we are going to create a hash set called visited. Now we are going to iterate over this given input nums. So inside our for loop, first of all we are going to check that the value we are visiting, if that is present inside our visited hash set or not. If it is present, which means we can return true immediately that there exists a duplicate. If it is not present, we will add an entry to our hash set. In any case, if we get out of the loop, we can determine that we did not find any duplicate entries and we can return false in this case. Now let's try to run this code. Okay, seems like our code is working as expected. Let's submit this code. And our code runs pretty efficiently compared to a lot of other solutions. I would be posting this in the comments so you can check it out from there. Thank you. Okay, so as an example, we are trying to solve the contains duplicate to problem. Now this is a very popular LeetCode problem that has been asked in some of the popular companies like Amazon, Facebook, Adobe, Microsoft, Uber, Google, Bloomberg, Airbnb, and Plenty. So these are all tech giant companies who love asking this question, so that is why I considered this one. Let's try to see the problem statement. The problem statement is actually quite simple, and this is a LeetCode easy problem and also a very well-liked problem on LeetCode. Basically, we are given an integer array called nums, or we are going to denote it as n, that contains array values. We are also given a value k, and k can be anything like 1, 2, 3, 4, any single integer value. So suppose k is equal to 3. Now we need to return true if there are two possibilities. The first possibility is there exist any two values I and j that are exactly same. So if there exist two duplicate values in the array. And the second portion is that the difference between I and j, so I and j refers to the index positions of every single value inside the given array. So the index position should be actually less than the value of k. Let's try to understand this with few examples. So suppose our given input n is equal to 1, 2, 3, 1, 5. If this is the input we are given and we are given the k value to be 4. If this is the case, does it satisfies these two properties? So first let's see. Okay, so we need to check that between the window 4 there needs to be two duplicate values. Currently we can see that there exists a duplicate value 1 and 1 over here. Let's see the index position 0 and 3. So if we do the difference 0 minus 3, so basically we need to do the absolute difference, so the answer is going to be 3. 3 is actually less than the value of 4, which means this one currently contains the duplicate value that is not far away from 4 elements from each other. So in this case, we are going to return true. Let's try to understand it with one more example. Suppose our given n is equal to 1, 2, 3, 1, 0, something like this. And our given k value is equal to 2. If this is the case, again, same scenario. We have the values located at index position 0 and index position 3 that contains the same value, but current k value is equal to 2. And if we do the difference between these two values, the current difference between indices is 3. Meanwhile, our given k is equal to 2, which means in this case, we need to return false because there does not exist any two duplicated values that are two steps away from each other or between two elements of each other. So this is the whole ask. Now let's see that what is going to be the simplest approach we can take. Okay, so suppose this is the input we are given. Now let's see the brute force way to solve this problem. That we pick any element, then we check the next k elements. So in this case, currently we are allowed to check up until this point. So between these portions, we check that whether 0 is present in any other value or not. If 0 is not present, we can define that 0 would not be a duplicated entry in any of the window, because we are strictly told that we can only check next three elements. So in this case, we can get rid of 0 because 0 is not present. Same way, we are going to check for value number 5. So currently value number 5 is located at index number 1, which means we have the ability to compare between these portions. So again, for value number 5, we are going to check this value, and this value, and bingo, we find value number 5. So we can return true in this case because element number 5 exists and the difference is less than 3. But this is like a very inefficient approach. Why inefficient approach? Say for an example, this entry does not contain any duplicated values and all the values are unique, and at the same time what we would do is, for every single element, we would compare it with the next three elements and we would keep on repeating the same process until we reach to the end of our loop. And that would be an inefficient approach because the time complexity would be big O of n. So n is the total number of elements multiplied by k. And this is not what we want. We want something more efficient. So let's see a more efficient and better approach. A better approach is that we know that for any single value, we need to check in the remaining portion whether that value is present or not. So currently we can break it down in this sequence. So currently we can create a window like this, 0 and then 5, 2, 7. Currently we are at this position number 0. Now we need to check that whether 0 exists in the remaining three entries or not. First approach is to do binary search. So for binary search, what we would need to do is we would need to sort this given input. And if we sort this input array, the sorted result is going to look like this: 0, 2, 5, and 7. And then all we need to do is check any two consecutive values. If we identify that there exists like a back-to-back entries that contains the same value, then we can return true. If it does not contain, then we can move on to the next window. And again, in the same way, we would repeat the same process for this next window that is currently comprised of the values 5, 2, 7, and 3. And again, okay, so let me fix this one. So this one should be 5, not 7, and 5, 2, 5, 3. So again, if we sort this window in this case, the answer we are going to get is 2, 3, 5, 5, and we found two back-to-back values that contains the same value. So in this case, we can return true. But the thing is, even this approach is also not very efficient because if we see time complexity in this case, the time complexity is going to be big O of n, then log of k. Why log of k? Because for any given input, we will actually have to sort this, and sorting it cost us a lot of time and energy. And this is better than the brute force approach, but still there can be improvements made. So what is one improvement we can make? And again, remember, we are using sliding window because we know that we need to do this in any subsequent values and we need to find the answer. So definitely you understand by seeing the problem that why we need to use the sliding window. But let's see that what would be the improvement we can make. First thing we need to check is that in the binary search approach, what we had to do is we need to check that whether in the remaining portion does the same element exist or not. And also at the same time, we were considering that every single time we need to create a new window, we would have to do the entire sorting calculation again. So we need a data structure that can very quickly like get rid of elements and add new elements. At the same time, very quickly search that whether the existing element exists or not. And the wonderful answer for this this type of scenario is a hash map. So we can create like a hash map or a hash set inside our input. And hash map and hash set are wonderful at doing two things, like doing the search and remove and input operations in big O of one time. So hashing is really good in that. Also at the same time, it does not allow duplicate entries, so no duplication is allowed, which means we can identify duplicate entries very quickly, very efficiently in any sort of hashing input. So we are going to use this property combined with sliding window approach to solve this problem in the most efficient manner. Let me quickly show you. So first we are given the value of k, which means we are going to create our window. So currently let's just create a window of size k. Okay, so starting from value number 0 to value number 5, and then we will have all the values 0, 5, 2, and okay, let me just put down some different value over here, and let me put 5 over here. Okay, and then this is going to be 4. Okay, so this is these are the current values at the moment. We are going to initialize a hash map. Now inside this hash map, we are going to store two items. We are going to store the value as the key, and we are going to store the indices based on its value inside the hash map. So first we are going to check, okay, this one is value number 0, and currently the index values are 0, 1, 2, 3. So 0 is not present in the hash map. We will add entry 0 over here, and its index value 0 as well. Again, 5 is also not present, so we will add entry 5 over here, and its index value 1 over here. 2 is also not present, so 2 and 2. And again 4 is not present, so 4 and the index value is 3. So we add these 4 entries in our hash map. At the same time, we can check that currently, since the value of k is equal to 3, we already added 4 elements, and still we were not able to find any duplicate entries, which means we will have to update our window. So in order to update our window, rather than getting rid of all the items, what we can do is we can just get rid of the first element, and then we can just shift our window to include one more entry inside our input, and that is going to be value number 5 for the index value position number 4. So again we add 5 over here. At the same time, since we got rid of the first index value, we are going to also get rid of that inside our hash map. So we are going to get rid of the first entry, and currently we have 3 entries. Again, we will try to check that whether 5 exists or not. So we will try to input 5 inside our hash map, but we would be able to immediately find that 5 is already present as a value inside our hash map, and immediately we can return true, saying that this contains duplicate inside a k window. And see, what we did is that initially our window was consisting of this value number 0. We got rid of the only 0th value. We kept the remaining values inside our window, and we simply added a new value inside our hash map. And then we were able to immediately identify that whether this is the correct response or not. And say for an example, if somehow this value is not value number 5, this is value number 11 or something else, this does not contain any duplicate entries, what would happen is that every single time we would get rid of the last element from our hash map, and we would keep on adding new values to our window, and eventually we would reach to the end of our input. And if we don't find any answer, we can simply return false in this case. So if we see time complexity in this scenario, the time complexity is actually going to be big O of n only. And since for this case we had to use a hash map of size k, the space complexity is going to be big O of k. But this is a very wonderful and beautiful approach to solve this problem. So that is why the sliding window technique is really powerful, because you are already building your solution upon the already calculated computed values. You are not doing everything from scratch, and that is very powerful in making your inputs more efficient. Okay, so for this problem, I'm not going to write the entire code. I'm just going to give you the explanation. So first we are going to initialize our hash set, and I mentioned that we can use hash map or hash set, anything. In this case, we are using hash set. Now we are going to iterate over the given input array using a for loop. First thing we are going to do is to check that whether our set contains the current value, current ith position of value we are at. If that is the case, we can return true immediately. If that is not the case, we would add that entry to our hash set. At the same time, we would check that if the current size of hash set, if that is greater than our given input k, if that is the case, then we need to remove the earliest entry inside our hash map, and we can calculate that using the number of ith index that we are currently at minus the value k. And then if we remove that value from the hash set, our hash set is only going to contain only the k elements, and then we can keep on repeating the same process until the very end. If we haven't returned true by then, we can return false in the end, and this is going to be the whole solution. Let's try to run this code. Seems like our solution is working as expected. Let's submit this code. And our code runs decently efficiently compared to a lot of other solutions. And I would be posting this in the comments so you can check it out from there. Thank you. Today we are going to do product of an array except self LeetCode problem. If we see some of the companies where I want to get a job who have already asked this question, there are companies like Amazon, Microsoft, Facebook, Apple, Uber, Bloomberg, Lyft, Google, Goldman Sachs, IBM, Twitter, TikTok, and LinkedIn. So that's why I'm paying my utmost attention. I hope you also enjoy the video. This is a LeetCode medium problem and also very well-liked problems on LeetCode. Basically, we are given an integer array called nums, and we need to return a new array called answer array such that every single value of that particular index position inside this answer array is actually equal to the product of all the other values that are present inside this given nums array except that particular ith element. So suppose we are given an input array that looks like this. In this case, we will have to create an answer array for the answer, and that would be of the same size of whatever this input array we are given. Now in this answer array, suppose we want to enter the value at this second position or corresponding to the second index value. What we are going to do is we are actually going to take the product of this value number 1, 3 and 4, and whatever the product of these three values are, we will actually put it as the answer for this value. Same thing we are going to do for this next value, where we are going to take products of these two elements and this element, but we won't take the product of this element from this original given input array, and whatever the answer is, we will actually put it over here inside the answer array. In order to enter this first element, we will actually have to do the product of these three values. Then the product of these three values is going to be 24. Now for the second element, we will have to do the product of this first element and this last two elements, so that is going to be 12. For this third and fourth element, we will again repeat the same process, and we will get subsequent values like 8 and 6 by doing the corresponding products. And at the end, we will have to return this as the answer array, and basically this is what the problem is asking us to do. Even the name is also self-explanatory, that we need to return the product of an array except self, but we are given a very specific declaration over here that we need to use it in big O of n time without using the division operator. And why it is asking us to use solve this problem without using division operator? Because if we were allowed to use division operator, suppose we are given an input, we can just do the product of all of these value and we will get an answer called 24, and then all we have to do is for this answer array, we will take this value 24 and then we will iterate over this input array and start dividing it with this 24. So even in the answer, we will get, if we divide 24 by 1, we will get the value as 24. If we divide 24 by 2, we will get value 12. If we divide 24 by 3, we will get value 8. So on and so forth. So it would become very easy for us to solve this problem. So that is why they are explicitly asking us that we should not be using the division operator. Now the most basic brute force way to solve this problem is actually we take any single value and then we iterate over all the remaining values and do its product and put it in the answer array. So we will create an answer array that looks like this. We will first take this value, so we will iterate over this given nums array, and for all these three values we will do its product and we will get the value as 24. Now again we will repeat the same process, but this time we will be iterating over the second element. So because we are iterating over the second element, we will take this first value and we will take these two values and we will do that sum, so we will get value number 12, and again we will repeat the same process. So essentially this is bound to give us the correct answer and we would get it in this case. But the thing is, this would not be the correct way. Why? Because if we see the time complexity in this case, the time complexity is actually going to be big O of n square. Why n square? Because we will have to iterate over this array for every single character we will have to iterate once, and even for any particular character we will have to iterate over all of the other values again just to find their product number, and that takes n square time, and we are explicitly told that we will have to solve this problem in big O of n time. So let's see that what would be the way to achieve that. Okay, so now for the better approach, we will actually have to put down one intuition to use. And the intuition is, suppose this is the element we want to get the product for in the answer array. So the idea is that we are actually going to take the product value of first two elements, and we will take the product of this last element. Again, if we take this portion, this value number 2, we will take the product of all the elements that are present on the left of this value number 2, and we will take the product of all the elements that are present on the right of this product number, this value number 2. So that is the idea, that for every single location we will have to take product of all the values that are behind or pre to that particular level. So we can call it as prefix, and all the values that come after that value, and we can call it postfix. So now the idea becomes quite simple. What we are going to do is we are going to have two arrays called prefix and postfix, and we are going to iterate over this nums array once, and for every single position we are actually going to keep track of all the values that come before it and after it, and we are going to put down their values like their product values, and at the end we will just do a multiplication between this pre and post arrays, and then we should get our answer. So let's see that in action. And also one more thing, that because for this particular element that are at the edges, so for this value number 4 there is nothing on the right side, so like we can't do anything, but for the simplicity purposes we will consider that anything on the right side is actually 1, because anything multiplied by 1 remains the same. And same thing we are going to do for this left edge as well, that because for this value number 1 there is nothing in the prefix, so again by default we will treat this as value number 1 as well, so that will help us in doing some counting, right? So let's see that in action. So first of all, for this value number 1, we are calculating the prefix values. So this 1 actually has nothing on the left, but it only has 1, so we will do 1 times 1 and we will get the answer as 1. Now for this value number 2, actually all we need to do is whatever the left element is, we just need to do the product of all of them. So the left element in this case is only 1, and we will just put it over here as well. Now in this case, the value number 3, we will have to do product of all these elements. So one way to do it is to do this like 1 times 2. So do the product of all these two elements, but that is actually time consuming. One better way to do it is that if we take this particular element value number 2, this already contains the product of all the values that are present before that. So why are we doing the effort of doing the product of this value number 1 and 2? That is just costing us additional resources. The better approach is that we, for this value number 3, we are over at this position. All we have to do is we just take whatever the value we have stored over here, which is the prefix of all the values before this value number 2, multiply by whatever this value is present, and that would be the prefix sum for this value number 3. So what we are going to do in this case is we will take this value number 2. So we will take this value number 2 and we will take this value number 1 from here, from the prefix array that we have already calculated, and we will do 2 times 1. In this case we will get value as 2, so we will add 2 over here. And again for this value number 4, again we are going to repeat the same process. So now this time we are going to take the value before 4, that is 3. So we will take 3 and we will multiply it by whatever value we have already found in this prefix array, which is 2. So 3 times 2 is actually going to be 6. So now we are done with this prefix array. Again we are going to repeat the same thing for the postfix array. So this is the edge value, so we can simply do 4 times 1. So we will add the value 4 directly over here. Now this is value number 3. For this value number 3, all we will have to do is just take product of this value. So this is already 4, so we will again add 4 over here. Now for this value number 2, all we have to do is we will take the value, this whatever value that is present over here, 3, multiply by whatever value we have already calculated in the postfix over here, which is 12. So we will have a value called 12 over here for this element number 2. And now again for this element number 1, we are going to repeat the same process. So we will take this 2 and multiply it by whatever value we have calculated inside our postfix array, and this is going to be 2 times 12. Okay, now we are done with both of our arrays. Now the task is actually quite simple. Now we will create our answer array, and we are going to simply do the multiplication of every single one of these values. So this becomes 24 times 1, 24, this becomes 12, this becomes 8, and this becomes, oh, I made a mistake over here. This has to be 1, not 4, because we are actually doing the multiplication of all the elements that are present on the right side of this value. So this would become 6, and this is the solution that we are going to do. This solution actually works perfectly fine. There are no issues with that. If we see the time and space complexity in this case, the time complexity is actually going to be big O of 3 times n. Why 3 times n? Because we will have to iterate over this n to first of all create this prefix array, then we have to iterate over n times to create this postfix array, and then again we will have to iterate over both of them to create this answer array. So we are doing like 3 times n work, but in general we can write this as big O of n. And in terms of space complexity, we are actually creating a couple of arrays, so we also have to do big O of n as space complexity. So the idea is, can we do something better? And the answer is yes. There is one way to actually do this both prefix and postfix array in a single array, and that too inside the answer array that we are planning to create. Okay, so let's keep the same example, and we want to find the optimal solution for this one. Well, the idea is that rather than doing two separate prefix and postfix arrays, we are actually going to create an answer array, and we are going to add all the values, and now we are going to do prefix and postfix multiplication inside the same answer array. And let me quickly show you how. First of all, we are going to use a couple of variables called prefix and postfix. So let me add their values, and by default they are going to have value as 1. Now what we are going to do is, first of all, we are going to iterate over this given input nums, and we are going to calculate the prefix for every single element inside this answer array, and we are also going to update the value inside this pre function or pre variable. And then again we will iterate in the reverse order, and we will keep on updating the postfix values inside the answer, and by the time we are done, our answer array should have been completely filled out. Let me quickly show you that in the action. So first of all, for this value number 1, this is actually the prefix of every value that is present behind this 1, and the multiplication of all of those values. So because there is nothing over here, we can consider this to be 1 by default. So I'll not write it over here. I'll just write over here that for this first element inside this answer array, the nums actually does not have anything on the left side, so we can consider this to be 1. Now we are going to we are at this second position. For the second position, what we are going to do is, we are going to take the multiplication of whatever the value we have on the left side, right? So even on the left side we only have value 1, and even the prefix value is also 1 so far by default, so we are going to add 1 over here again. Now we are at this value number 2 or 3. So for this value number 3, what we are going to do is, we are actually going to take the value that is before that, which is 2, and we are going to multiply it with whatever the pre variable we have. So we were also doing the same thing for this value number 2 as well, but because both the values are 1, we were not getting any other result. But in this case we will actually get a result of 2, and because we are getting a result of 2, the result of pre is also being updated to value number 2, because it will help us to know further down for the next elements that what is the value of prefix. Now we are at this value number 4, so again we are going to repeat the same process. We will take this value number 3, and we will take whatever the value of this prefix we have, which is 2. So 3 times 2, the value is 6, so we'll add value 6 over here. Okay, and now we are done filling up this prefix portion, and we have taken the prefix of every single element inside this answer array. Now we are going to do the reverse order. Now inside the reverse order, again for this value number 4, actually there is nothing on the right side of this value number 4, which means there is nothing on the postfix, so we can consider it as 1. Now because this is already 1, what we are going to do is, whatever value we have calculated so far, we are going to multiply it. So if we multiply 6 by 1, the answer we get is 6. Okay, so far for this value number 4, the answer is 6. Now we are at this value number 3. For this value number 3, what we are going to do is, we will have to calculate everything on the postfix side. So this value is 4, so we are going to take value 4 multiply by whatever value of this postfix variable we have, which is 1. So 4 times 1 becomes 1. So now we have the value as 4 for this postfix. So we are going to update the value of the postfix to be 4, and we are also going to multiply this 4 with whatever the value we already calculated for this value number 3, which is 2. So 4 times 2 is going to be 8, and this is going to be answer for this value number 3, that this is the product of all the numbers for this value number 3 except itself. Now we are at this value number 2. For value number 2, we are going to take value number 3 multiplied by whatever the post variable we have. Post variable is actually 4, so 3 times 4 is actually 12. So we are going to update that value over here first of all. So now we have the value 12 over here, and we will have to take this 12 and multiply it with whatever value we have already stored over here, which is 1. So 1 times 12 is also 12, And now again we are at this last position. So again for the last position we are going to repeat the same process. We will take whatever the value that is after this value number 1, which is 2. So we'll take this 2, we will multiply it with whatever value we have stored inside this post variable, which is again 12. So 2 times 12, and this becomes actually 24. So we will do 24, and we will take 24 multiply by whatever value we have already stored inside this answer array, which is 1. So 24 times 1 becomes 24, and this is the answer. And if you look closely, this actually becomes the complete answer that we are looking for, and we have actually done everything in place without using any additional data structure or any additional array, and we don't have to use basically any extra space. So this is the best way to approach this problem, and this is the solution that any interviewer would want to see. If we see the time complexity, in this case the time complexity is actually going to be big O of 2n. Why 2n? Because first of all we are iterating over from left to right, calculating this pre variable, and then we are iterating on the reverse order, calculating this post variable and updating the values, but still, which is good. If we see the space complexity, in this case, well, space complexity is actually constant because we are not using any additional space. For this answer array, we are given inside this question statement that we have to create a new array, so that we are anyways going to create. But apart from that, we are only using couple of variables to store some data, and that's why this is a very good approach. Now let's move on to coding. First of all, we are going to create a new array called result, and by default we are going to set all the values as 1. We are going to initialize the two variable called prefix and postfix, and we are going to assign the value as 1 for both of them. Okay, now we are going to run our first for loop to iterate from left to right, and we are going to update the value of prefix inside our answer array. So first of all, we are going to update the value inside our result array, and then we are going to update the value of our prefix variable. So after this loop ends, basically we should have prefix values filled out for every single position inside our result array. Now we are going to run another loop, and we are going to come in the reverse order. And first of all, we are going to update the value inside the result array. So any single value inside the result is actually going to be multiplication of whatever the value we already had, multiply by postfix variable. We'll also have to update the value of postfix variable. We are good to go. Oh, actually I made a mistake. This should be pre only, not prefix. Okay, and after this second loop ends, essentially our result array should have been populated, so we can simply return that. Let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs pretty efficiently compared to a lot of other solutions, so that's why this is really good approach. I would be posting this solution in the comments so you can check it out from there. Thank you. Today we are going to do maximum sub-array LeetCode problem, and if we see some of the companies where I want to get a job who have already asked this question, there are companies like LinkedIn, Amazon, Apple, Microsoft, Google, Adobe, Facebook, Bloomberg, Uber, ByteDance, Yahoo, eBay, and Splunk. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode medium problem and very well liked problem on LeetCode. Basically, we are given an array called nums, and we need to find a continuous sub array which has the largest sum and then return the sum value. We are also told that a sub array is a continuous part of any array, so we are given the definition of it. Now let's try to understand this with an example. So suppose this is the example we are given. Well, I have actually drawn this example in much bigger format over here. So for this example, what we are going to do is we are going to see different sub arrays, and then we are going to see that what is the maximum sum we are able to find so far, and then in the end we will return whatever the maximum sum we have found. So first of all, this value is actually -2. So because this value is -2, even if all the remaining values they are positive, it makes no sense for us to keep this value. So we are going to ignore this value, and we are not going to keep it in our current sub array. Now this value is +1, so that is good. But again, combination of these two is actually -2. So again, we cannot keep this in the our continuous sub array. Well, now this value is actually +4, and which is good sign. Now these two values, this is again still +3, which is also a good sign, and the combination of these three is again 5, and then we add this value, so this becomes 6, and we are going to keep on updating the max value as well. So max value so far we have found so far is 6. That we can say that up until this point, the sub array there where we have found the maximum value to be is 6. Now this is again -5. So if we do 6 plus -5, we still get positive 1 value, which is again positive. So we are keeping this as a subarray. And then again this value is +4. So +4 plus 1 becomes +5. So this is also positive. The thing is, in the end, up until this point, the maximum value we were able to find is 6. So because it was 6, we are going to return 6 as the answer. This is what the problem is asking us to do. We need to find the sum of maximum subarray and then return that value. So let's see what would be different approaches to solve this problem. Basically, we need to find the maximum subarray. What we can do is we will try to find every single possible subarray, try to see the sum of all of those characters, and whichever possess the maximum sum, we simply return that sum. So let's see that in action. So first of all, what we are going to do is we are going to take some of this character, then we are going to take some of these two characters, then we are going to take some of these three characters, and so on and so forth. We are keep on repeating the process with the first element. After we are done with this, essentially we are going to get rid of this first element, and now whatever the remaining elements are, we are going to start taking some of those values. So in this case, what again we are going to do is we will take this element, then again we will take these two elements, and again we will take these three elements, and overall we will keep on making the sum, and eventually we would find the answer. And the answer in this case is going to be the sum of these three characters, and whatever the answer is, we can simply return that. So this approach would work as expected, but the issue with this brute force solution is actually that we are doing a lot of repetitive work. If we see the time complexity in this case, the time complexity is actually going to be big O of n square. So let's see that what would be the better way to solve this. Before we come up with the optimal solution, first of all, let's make a couple of things very clear. What is our aim and what is the thing that we are trying to find? Well, basically we are trying to find that what is the maximum sum subarray. At any given moment, there can be any current subarray that we are iterating over, which could be the maximum subarray or could not be the maximum subarray. We don't know. But at any given moment, we will need to have the ability to keep track of sum of all the characters that are present in that particular subarray. So which means that we are going to have a variable called current or current subarray, where we are going to keep track of the sum of all the current variables that we have iterated over and we are keeping track of. Well, second thing is that we need to find the maximum subarray, and amongst any of the subarrays, anyone could be the maximum subarray. So we are also going to keep track of another variable called maximum subarray, where we are going to keep track of maximum current sum we have found so far. So well, these two things are understandable, right? They are from programming perspective. But there is also one more thing that is actually rational, and the rational thing is that at any given moment, suppose this value is actually -3. So current sum or current subarray we have found is actually -3. So if this value is -3, because this value is negative. So if this value is negative, even though all the remaining values, they are positive and they keep on increasing the value in size, this -3 is always going to have to cause them to have a lesser value. So if that is the case, why are we even bothering to keeping this value at our bay or at our disposal? So the idea is at any given moment for our current subarray, the moment we would identify that the current value or some set of current values, they are causing it to have a negative value. If that is the case, we are going to immediately update our current subarray, and then we will keep on moving towards the next values. And based on these two logics, all we are going to do is we are going to iterate over our given array and keep on going to updating the current subarray, and then keep on updating the maximum subarray we have found so far. And in the end, we should be able to find the answer. So let's see that traversal in action. Before we start iterating over this array, we are going to define some default values for this current and maximum variable. The default value for current is going to be the 0, and for maximum it's going to be whatever the first element of this given array is, which is -3. That is to cover an edge case where we are only given one element. Now let's start iterating over. Okay, so now the sum of these two elements is actually going to be -3 plus 2. So -3 plus 2 is actually going to be -1, which is still less than 0. So because this is less than 0, we are not going to update our current max variable, and the maximum sum we are actually able to find so far is going to be 0, which is definitely greater than -3. Now again, for these three variables, again the sum is going to be negative. So we are not going to do anything, and we are going to ignore all three of these cases. Now this value is actually positive. So because this value is positive, the current sum we have is going to be 8. So which means we'll have to update the maximum sum we have found so far to be the value 8 as well. Now again, we add the sum of these two values. So 8 plus -1. So 8 plus -1 actually becomes 7. So this becomes 7, which is less than whatever the maximum value we have found so far, so we don't need to update the max variable. Now we again add this value to our current sum. So 7 plus 2, 7 plus 2 is 9. 9 is greater than whatever the maximum value we had, so this becomes 9. Okay, now again this is also a positive value, 3, so we can do 9 plus 3, which becomes 12. So we are again going to add the value 12 to our maximum sum that we have been able to find so far, and then this value is actually negative 5. So we can do 12 plus minus 5. So 12 plus minus 5 is going to be 7. And again, because this value is still positive, we are keeping this current subarray going on, because we don't know, future values might be positive values, and this can also go up pretty quickly. Now we have actually reached to the end of this array, and we don't have any more elements to go over. So the maximum sum we have found so far is 12, and this is what we need to return as the answer in this case. And so this is the most optimal approach to solve this problem. If we see time and space complexity, in this case the time complexity is actually going to be big O of n. Why big O of n? Because we will have to iterate over every single array or every single value that is present inside this given array, which takes big O of n time. If we see space complexity, in this case the space complexity is actually big O of 1 or constant space, because apart from storing these couple of variables, we are not using any additional space, so that's why space complexity is very minimal. First of all, we are going to initialize two variables called current sum and maximum sum. For current sum, we are going to initialize the value to be 0, and for maximum sum, we are going to initialize the value to be the first value inside this given nums array. We are going to create a for loop to iterate over this given array. Now we are going to check that whether the current sum, if that is less than 0 or not. If that is less than 0, we are going to update the value of current sum to 0. That is not the case. We are going to calculate the value for current sum and maximum sum. So current sum is going to be current sum plus whatever the current value inside this given nums array we have, and we will have to check that whether the current sum we have created, if that is the maximum sum or not. And after loop ends, we simply have to return maximum sum. Let's try to run this code. Seems like our solution is working as expected. Let's submit this code. And our code runs pretty efficiently. I would be posting this in the comments so you can check it out from there. Thank you. Today we are going to do maximum product subarray. This is a very popular problem on LeetCode, and if we see some of the companies where I want to get a job who have already asked this question, there are companies like Amazon, LinkedIn, Microsoft, Google, Apple, Bloomberg, Facebook, and Uber. So that's why I'm paying my utmost attention. I hope you also enjoy the video. Okay, so this is a LeetCode medium problem, and as mentioned, a very well-liked problem on LeetCode. Basically, we are given an integer array called nums, and we need to find a continuous non-empty subarray that has the largest product, and we need to return the product. We are also given the definition that what a subarray is. That is basically a continuous sequence inside the any given array. And let's try to understand this problem with an example. So I have broadened this example over here, and basically we are trying to find the maximum product subarray. So a subarray that contains the maximum product. In this case, this is a negative value, and that changes the dynamic equation. So in this case, the product of these two elements, that is a subarray, is actually going to be 6. And all the other subarrays, they are always going to have lesser values than 6. So in this case, as the answer, we need to return 6, that is the maximum product subarray we can make for this given input array. And this is what the problem is asking us to do. So first, let's see that what is going to be the brute force way to solve this problem. Well, the brute force way to solve this problem is that we are asked to find the maximum product subarray, right? So if we are asked to find something of a subarray, why don't we check every single subarray, see that what is the product we can make, and find the maximum amongst that? So like do the baby steps. So what we are going to do is we are going to keep on iterating over every single subarray that we can make. We are going to see that we are going to have a variable called answer, and in the answer we are only going to store the maximum value we have found so far, and then we will keep on repeating the same process for all the remaining subarrays, and eventually we would find a pair that contains the maximum product subarray. And in this case, the answer is actually going to be this 6 times 7, that is 42, and we will have 42 populated as the answer eventually. So the brute force way is a very trivial way, but it leads to the correct solution. So if you are only looking for a solution, you will get it using brute force. But what are the issues with this one? Well, the issues clearly we can see over here, that we will have to iterate over every single subarray that is there, and that would lead us to have a time complexity of big O of n square. So which is very bad, because for every single element we will have to iterate over every other elements and then keep on repeating the same process. So the idea is to see that can we find something of a better time complexity. We can actually achieve that using the most important concept inside our computer programming, and that is called dynamic programming. Using the dynamic programming, we are basically going to have two pointers to store some critical important results, and that is going to lead us to find the maximum product subarray. So first, let's understand one thing regarding what is being asked. We are trying to find the product. Now we know that for the product, suppose if all the integers are just positive integers, then basically it is the product of all the integers that we need to return, right? But the thing is, that is not always the case. We could encounter negative integers, and the negative integers leads to very interesting results. The interesting results are that, first of all, we suppose in this case, these three values, if we do product of them, okay, the product of these two is 6, and the 6 times minus 3 leads us to minus 18 to be the product over here, right? The thing is, now this value seems very low value because of the negative value. But imagine that over here, rather than this 4 being positive, if we had a negative 4, then that is actually going to lead us to have a very beautiful results, that if we do minus 18 times minus 4, the answer is going to be plus 72, and that is going to be the maximum product subarray. So you see what I'm trying to say? The moment we encountered a negative value, immediately we found it to have the minimum value, but that negative value lead us to have some better consequential results in the future. So we don't know that whenever we encounter a negative value, we don't know whether we should keep it or not. So that is a tricky part. That is why we are going to use dynamic programming, and we are actually going to use two pointers. And these two pointers are going to be that at any given position we are at inside our array, we are going to see that up until this point, what is the minimum value we have been able to achieve and what is the maximum value we have been able to achieve. Or basically what I'm trying to say is, what is the minimum product we have been able to achieve and what is the maximum product we have been able to achieve. And every single value, we could have three possibilities. So let me clean this up a bit. At every single value we are at, there could be three possibilities. Either this value could be part of a subarray that leads us to have the maximum product, or it could have been a part of a subarray that leads us to have the least value up until this point, or this could be the start of a new subarray that leads us to have a maximum product in the future. The idea is, at any given position, we are going to check three things. And the three things we are going to check is that up until this point, whatever the minimum value we had, which we have stored so far, we are going to multiply this value with this minimum value. We are also going to multiply this value with whatever the maximum value we have been able to store so far. And we are also going to compare this value by itself. So we have basically three values at any given position: the value with the previous minimum value, the value with the previous maximum value, and the value by itself. And for all of these three values, we are going to see that what is the minimum value we are able to make, we will store that. What is the maximum value we are able to make amongst these three values, we will store that as well. And eventually we would reach to the end of our loop with the maximum value we have been able to generate, and we will have a parameter called answer, and in the answer parameter, whenever we identify a better maximum value, we would populate that. So this is the approach I'm suggesting. Now let me try to go over an example. Okay, so suppose this is the example we have, and now let's try to use dynamic programming in this case with two pointers. So we are going to create two pointers called min and max, and for every single value we are going to compare it with three values that we are going to compare it with, and we are going to populate these results. We are also going to have a variable called answer. We will update it based on the maximum value we have found so far. Okay, so first value is 5. So we for all the three values we only have 5. We can't compare with anything. Okay, so the minimum value we have found so far is going to be 5. Maximum is also going to be 5, and that's it. Now this next value is 3. Okay, So now let's see that what are three values that we have to compare. So first value is 3 by itself, next value is 3 times the minimum value, so 3 times 5, next value is 3 times maximum value, so again 3 times 5. So the three values we have is 3, 15 and 15. Okay, so now the minimum value amongst these three is going to be 3, so we are going to populate that, and the maximum value is going to be 15, so we are again going to populate that. The answer so far that the best we have received is 15, so we are going to populate that. Okay, now let's get rid of this one. Now again we are at the next element, that is 1. So now the three values we have is 1 times whatever the minimum value, so that is 3, so the value is going to be 3, and the 1 times the maximum value, that is 15. Okay, now amongst these three values the minimum value we can able to make is going to be 1. Okay, so let's populate that, and the maximum value is going to be 15. The answer is going to remain the same. Now let's clean this up. Okay, now things become interesting when we reach to this value 9 minus 2. Okay, now the three values we have is going to be minus 2 by itself, then minus 2 times the previous minimum value. So previous minimum value in this case is 1. So minus 2 times 1 is going to be minus 2, and the previous maximum value. So previous maximum value in this case is 15. So minus 2 times 15 is going to be minus 30. Okay, now these are the three values we have, and now we are going to see that what is the minimum and maximum value we are able to generate, right? So currently the minimum value we are able to generate is going to be minus 30. So we are going to store that over here. Okay, and the maximum value we are able to generate in this case is going to be minus 2, so we are going to store that over here. Okay, now we are good up until this point. Now this value is 0, so the three values that we have to compare is going to be 0, 0 times the minimum value, so that is again going to be the 0, and 0 times maximum value, that is again going to be the 0. So all three values are 0, so let's put zeros over here. Now again we are at this value number -5. So now the three values that we have to compare is going to be -5, and then both of these are 0, so it's going to be 0, 0 again. So currently the maximum value we are able to generate is going to be the 0. So we are again going to populate the value with 0, and the minimum value we are able to generate is -5. So we are going to populate the value with -5. Now the next value is 8. Okay, so now the three values we have to compare is 8. 8 times -5 is going to be -40, and 8 times the 0 is going to be 0. Okay, now the three values that we have, let's compare them and let's find the minimum value. So minimum value in this case is going to be -40, so we are going to put it over here. The maximum value we are going to have is 8, so let's populate that over here. Okay, now we are at this value number -3. So with this -3, we have three options. So -3, and then -3 times this -40, that leads us to positive 120, and -3 times 8, that leads us to -24. Okay, so now in this case the minimum value we have so far is going to be -24, which is this one, and the maximum value we are going to have is going to be 120, and this 120 is greater than this value number 15, so we are also going to update that in our answer. And now we have reached to the end of our array, so end of our dynamic programming journey. So we'll stop here, and whatever value we have found in the answer, we are going to return this as the answer. So in this case answer is 120, that is the correct answer. If we see and if we compare this to our brute force, well, essentially because we are using the beautiful concept of dynamic programming, we are completely everything in just one single iteration, and all we are doing is just storing couple of variables to store the previously calculated results and comparing different values. That leads us to have the correct answer and find the maximum product subarray in a single iteration, which is wonderful. If we see time complexity, in this case the time complexity is actually going to be big O of n, and the space complexity is actually going to be big O of constant space complexity, because apart from storing couple of variables, we are not storing any other data. So this is a very good time and space complexity to have compared to our brute force approach that had the time complexity of big O of n square, which was very bad. So first let's take care of some edge cases, that if the given number is empty, we can simply return 0. So now we will initialize a min variable, a max variable, and a result variable. Okay, so now let's run a for loop to iterate over our given nums array. Let's initialize a variable called current to keep track of the current variable we are at. Okay, now we will have to calculate max and min value. So first let's calculate max value. So this takes care of comparing three values for our max variable, and we are using math.max function 2 times because that is the way to do it. I think in Python you can do it just without using like two math.max functions. Now let's calculate our min value as well. The thing is, for our min value we will also have to use the max value, but since previously we have already calculated our max value, it makes no sense for us to use that over here. So what I'm going to do is I'm going to create a temporary variable, and this temporary variable I'm going to calculate the max value. Then for the calculation of min value, basically I'm going to use the previous max variable. Now because this is the temporary variable, we will assign this value to max. We will also have to keep on updating our result variable as well. That's it. Basically when the loop ends, we should have our answer populated in the result variable. So let's return that. Now let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs pretty efficiently compared to a lot of other solutions, and I will be posting this solution in the comments so you can check it out from there. Today we are going to do find minimum in a rotated sorted array, and if we see some of the companies where I want to get a job who already asked this question, there are companies like Microsoft, Amazon, Uber, Facebook, Apple, Bloomberg, Google and TikTok. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode medium problem, and basically we need to find the minimum inside a rotated sorted array. Now you will ask that what does a rotated sorted array means? We are actually given some definition of what a rotated sorted array is. If you want, you can iterate over this definition. The thing is, let me quickly show it to you by an example. Basically, we are originally given a sorted array. Now for this sorted array, if we take the rightmost element and put it on the leftmost position and all the other subsequent elements, we flip it one side on the right side, we can determine this to be rotated one time. So if I take this original sorted array and if I rotate one time, so one time rotated array is going to look like this. You can see that this 5 that was originally at the rightmost position has been flipped to the leftmost position, and all the other values we shifted them one position on the right. Now if I rotate this one more time, so eventually I would have rotated this array to 2 times. Basically the result I would get is going to look like this, there where the first two values are 4 and 5, and then we have 1, 2 and 3. Now over here, this 4 that was originally over here, that came to this place. Now we can rotate it like 3 times, 4 times, as many times as we want. Like we can only rotate it up until 5 times because there are only 5 elements. Now basically in any rotated array, we need to find that what is the minimum value that is present in it. So if we try to understand this with an example, over here we are given some array where the original version of array was 1, 2, 3, 4, 5 that got rotated 3 times, and we were given this as the input. Now if we see the minimum value in this case is 1, so we need to return 1 as the answer. We are also given one key important detail that we have to find, that we must write an algorithm that runs in big O of log n time. So that is the key part. First, let's see that what is going to be the brute force approach to solve this problem. Well, the brute force approach that comes to our mind is that why don't we start iterating over the given array. We have a variable called min or answer or whatever you want to call it, and then we start iterating over all the subsequent elements one at a time, and whenever we find a lower value, basically we update that in the min variable. So eventually when we start iterating, when we would have completed iteration, we would find the value 1 to be the lowest value that we can find inside this array, and that we are going to return as the answer. This solution leads us to the correct answer. There are no issues with this one. But why this brute force solution does not work in your interview or anywhere else is because this solution actually happens in big O of n time, because we are iterating over all the n elements. And we were explicitly told that we need to solve this problem in big O of log n time. So that's why this brute force solution won't work. Now, whenever we see log n solution, immediate thing that comes to our mind is that we are going to use binary search, right? And that is true that we are going to use binary search in this case. But before we do that, let's make some logic clear. Well, the key part of the logic we have is that if we compare the left and right element for any given array, if the array is completely sorted, which is the case in over here, that the entire array has been completely sorted, there are no mismatching pairs, right? So because this array is completely sorted, if we compare the leftmost element and rightmost element, or any element with its left element, basically we would find that the value at the left element is always less than whatever value at the right element we have. Like if we compare these three variables, and if we compare the right variable to be over here, basically again in this case the right is 3 and left is 1, so we can conclude that this whole portion is sorted. If we have the right variable located at this position, basically we have the value of left to be 1 and right to be 5. Again, left is less than 1, so we can conclude that this whole portion is actually sorted. So the lowest value that we can achieve in this whole portion between this left and right is going to be whatever value that is located at the leftmost position. Now whenever we compare the left value and right value and we determine that left is actually greater than right, if we find that left is actually greater than right, we can determine that the minimum value exists somewhere between left and right. We don't know that at what position minimum value exists, but the thing is we need to achieve to the direction where we can actually find left is less than right. Because remember, over here currently the value of left is 3 and value of right is 2. So in this case left is actually greater than 2. Whenever we have to find the minimum value, we will have to move in a direction where we will reach to a conclusion where left is less than right. And in order to achieve that, what we are going to do is we are going to compare the value of the left to the middle pointer that exists, and depending on the value of the middle pointer, we would determine that the minimum value, if does it exist on the left side of the middle pointer or on the right side of the middle pointer, and depending on that we will update our value of left pointer or right pointer. So let me show you with a broader example what I'm trying to say. So I have drawn a big example over here, and first let's assign our initial values of left and right. So we have the values of left and right set up for us. Now we know that we need to reach to a position where left is less than right. If that is the case, then we will have some interesting results, right? But currently if we see, the value of left is 2 and value of right is 1, so left is actually greater than 1. So now we will have to move in some direction. So now what we are going to do is we are going to find the mid value, and also remember we are going to have an answer variable that is going to store the lowest value we have been able to find so far. So currently the value of left is 2, value of right is 1, right? So we are not going to do anything in the answer yet. Now we are going to find the middle pointer. So the current middle pointer is going to be at position number 4. Why? Because left position is 0, right position is 8. So 0 plus 8 is equal to 8 divided by 2. That gives us the middle value, and middle value in this case is going to be the 4, right? So the value that is located at the 4th position is 6. Now we need to compare the values between left and mid. Left and mid, if we compare, left is 2 and mid is 6, so 2 is less than 6. Now remember, whenever we identify that the left value is less than whatever the value we compared, we can dictate that every value in between is actually greater than the value of the left, which means that no value amongst these values can be the answer or can be the minimum value, because remember, we already know that on the right hand side the value is actually less than left, and because of that we will have to update our migration on the right side. And also remember, whenever we compare the value of left value with the mid value, whatever the lower value is, we are going to store it. So currently the lowest value we have been able to find is 2, so we are going to store 2 as the answer, right? Now we are going to switch our left pointer to go on the right side of the mid. So now let me clean this up a bit. So now this is going to be our new left pointer, and this is going to be our new right pointer. Again, we are going to compare the value of left and right. So left is actually greater than right, right? So now we will have to find the mid pointer. Mid pointer in this case is going to be left plus right divided by 2. So the current value of left is 5, right is 8. So 13 divided by 2. If we put it floor value, we will get the value of 6. So 6 is going to be the middle pointer in this case. So now we have the 6 to be the middle pointer. Now we are going to compare left with the middle pointer, and now in this case left is actually less than middle pointer, which means that answer cannot lie between left and middle pointer, and again we will have to update the value of the left pointer. Also for this leftmost value we will compare that whether we need to update the answer or not. So answer currently we had was 2 and this is 7, so we don't need to update the answer, and we are good up until this point. Okay, now again we determine that this value is not the answer. Now our left pointer comes at this position, our right pointer comes at this position. Again we are going to compare the values of left and right. So currently left is actually less than right, and that is the ideal scenario, that we found that left is actually less than right, which means that now left is at the correct position to be the lowest position that it can be before it iterates or it takes over right. And now because of this one, we are going to update, we are going to see that whether we need to update our answer or not. So current answer we had was 2, and because left was less than right, we are going to compare the left value with this answer value, and the left value is actually 0, so we are going to update the answer to be 0. And in this case, this is the correct answer that we are able to find, and we are going to return that. Let's try to understand the same thing with another example. So in this case, left is over here, right is over here. Currently left is actually greater than right, so because of that we will have to find the middle value. So middle value is going to be this one. So now if we see, currently the left is actually greater than middle value as well, which means we cannot determine that the left and middle portion is actually completely sorted. We can only determine that the middle and right portion is completely sorted. So in this case, we are actually going to update the value of the right pointer, and we are going to determine that these are all the values that are not part of the answer. So we can just simply ignore them, and we will not do anything for these values. So now currently our right pointer comes over here. Now because of that, we are again going to repeat the same process, and we will try to find the middle value. Middle value in this case is going to be 8, right? So we are going to compare left with the middle value. So left with the middle value, if we compare, left is actually less than the middle value. If that is the case, we can determine that no value over here is the minimum value. So we can simply ignore that, and now our left value becomes this one, our right value becomes this one. And now if we compare, left is actually less than right. Left is less than right. That is the ideal scenario that we were looking for, which means that now left is at the correct position where the value is actually minimum, and in the answer we are going to denote the value to be 0, and that is going to be the answer we are going to return. Now if we see time complexity, in this case the time complexity is actually going to be big O of log n, because remember, during any single iteration we actually removed the half of the candidates that we were trying to search for, and that is why we are actually using binary search in this program to solve this problem, and that is the logic we are going to use. And now let's move on to the coding. So first of all, we are going to initialize 3 variables, left, right, and answer. Now we are going to test for an edge case that if the nums array only has one element, basically we can return that as the answer. Okay, if that is not the case, we are going to run our while loop, that while left is less than or equal to right. First, we are going to check that if the current left and right position makes the array completely sorted or not. And that can only happen if the value at number of left is actually less than whatever the value of nums at right we have. And if that is the case, we are going to see that whether we need to update our answer or not. If that is not the case, we will have to calculate the middle pointer. So first, we are going to initialize a value called mid, and we are going to calculate the middle pointer. After calculating the mid pointer, we are again going to check that whether we need to update our answer or not. Now we are going to see that which way on the mid pointer do we need to take the jump. So if we find out that the current value of left is actually less than or equal to mid value, then we will have to update the value of left pointer to the right side of the mid. And if that is not the case, which means we will have to update our right pointer. Basically, that's all we have to do for our binary search operation. After this loop ends, we can simply return whatever we have stored in the answer. And now let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code is actually pretty fast compared to a lot of other solutions. And I would be actually posting the solution in the comments so you can check it out from there. Today we are going to do search in a rotated sorted array, and if we see some of the companies where I want to get a job who have already asked this question, there are companies like Amazon, Microsoft, Facebook, LinkedIn, Bloomberg, Apple, TikTok, ByteDance, Google, Goldman Sachs, Uber, and eBay. So that's why I'm paying my utmost attention. I hope you also enjoy the video. This is a LeetCode medium problem and also a very well-liked problem on LeetCode. Basically, we are trying to search an element inside a rotated sorted array. Now, if you notice, this is very similar to one of the previous videos we solved recently, and you can check it out that over here. Now, we are basically given an array called nums, and we are also given a target value, and we need to check that whether this target value exists inside this nums array or not. If it does, we need to return the index of that target value. Now, the special part about this question is that the nums array we are given is actually a sorted array that has been rotated certain times. So it sounds confusing at first that what does a rotated sorted array means. So you can either read this definition that has been provided over here, but let me make it a little bit clear for you. Basically, A rotated sorted array is that initially an array is a fully sorted array, which is the case over here. You can see that all the elements are sorted and they are all in ascending order. And the thing is, whenever we rotate one time, basically we take the rightmost element, we put it on the leftmost side, and then we flip all the elements one side or one position to the right. And that is how we rotate and rotate a sorted array. So if we consider this to be the original array, suppose we rotate it one time, we will get a result that looks like this, where this 5 that was originally on the rightmost position came on the leftmost position, and all the other subsequent value we jumped it one step on the right side. If we rotate it 2 times, again the 4 and 5 would come on the left side and all the values would be shifted 2 times on the right side. If we rotate 3 times, basically all the values would be rotated 3 times, and we would get an array that looks like this. So the idea is we are given a form of a rotated sorted array. The thing is, we don't know that how many times it has been rotated or whatnot. We are also given some target element, and we need to see that whether this target element exists inside this array or not. So suppose this is the array we are given as the input, and we are given target is equal to 3. If that is the case, then in this case 3 exists inside this array and its index value is 0. So we need to return 0 as the answer. And this is what is being asked for this problem. So now let's see that what are going to be a couple of different approaches to solve this problem. The first approach we have is a brute force approach. In the brute force approach, what you can do is, suppose this is the array we are given and we are given the target value to be 0. Well, if we see what we simply do is we start iterating over this array one by one, and every single time we iterate until we find the value that exists. If the target value exists inside this array, whatever its index position is, which is 3 in this case, we return that as the answer. And if we somehow reach to the end of this array and we do not find this target value, we simply return that okay, the target does not exist, right? The thing is, this solution is not the most optimal solution. Why? Because the time complexity for this solution is going to be big O of n. Meanwhile, if we read the problem statement, we are explicitly told that we need to complete this in big O of log n time complexity, and this big O of n is just not good enough. Okay, before we come up with the optimal solution, first let's understand a couple of concepts regarding the sorted arrays, right? For the sorted arrays, if we compare any left element with any right element, if we at any point identify that left is actually less than right, and we know that this given array is a sorted array, right? And this left is actually less than right. So if that is the case, all the elements between this left and right will be sorted in ascending order. That is one of the properties of a sorted array. We already know that. Now, the tricky part we have is that the array we are given is actually rotated. So the thing is, we will have to take care of this rotated part as well, and we don't know that how many times it has been rotated. So suppose we are given an array like this. This has been rotated few times, right? Now, whenever we compare the left element with the right element initially, we can clearly see in this case that left is actually 3 and right is actually 2. Which means left is actually greater than right. And remember, we already know that when left is less than right, we already know that all the elements in between, they are actually sorted. And if we are trying to find some target value that falls between this left value and this right value, we can immediately find that target value. Suppose we are given the target value to be 3. We know that left value is 0 and right value is 5. So because of that, this target value has to be somewhere between this 0 and 5, because it can only exist between 0 and 5 because this portion is sorted. 3 cannot be outside of the scope. The thing is, we cannot say that for certain in this case, because over here currently if we see left is actually greater than right, which means we can determine one thing, that this whole portion is not sorted. But the thing is, we already know that a chunk of this portion is sorted, which is this, that 3, 4, 5, this is sorted in ascending order. Again, same way, this 0, 1, 2, that is also sorted in ascending order. Why? Because this was a rotated array, right? So the thing is, what now we are going to do is, we are trying to find some target value, right? So our aim is that suppose we are given the target value to be 4, right? Now we are trying to find the value 4. The thing is, for this rotated array, the idea we are going to use is that when we determine that left is actually greater than right, which means that this whole portion is not sorted, right? That is the key part. This whole portion is not sorted, but some chunk of this portion has to be sorted, and that we can determine by defining some middle value. So in this case, suppose we put down a middle value. So suppose we have a middle value that is 0, right? Now with this 0, what we are going to do is we are actually going to compare this left with this middle value. If we compare this left with this middle value, left value is equal to 3 and middle value is equal to 0. So if that is the case, left is actually greater than middle value. So since that is the case, we won't be able to do much over here. And basically what we will do is, now again we are going to compare this middle value with this right value. So currently middle value is actually 0. The right value is actually 2. So middle value is actually less than right, which means because this was the rotated array, we can determine that all the values between this middle value and this right value is actually completely sorted. This is the important property that we have to define, that this whole portion is completely sorted. Because of that, now we will see, okay, our target value is actually 4. The current middle value is 0, current right value is equal to 2, which means 4 does not fall between 0 and 2. Because it does not fall between 0 and 2, we can concretely say that 4 cannot be part of this particular chain. So immediately we can ignore all of these cases, and now what we'll do is we will shift our right pointer to one step before mid. Why? Because we were certainly able to say that this sorted property of this rotated sorted array help us determine that 4 is not part of this one. All the elements between these portions were between 0 and 2. Now we are going to move our right pointer over here. So let me clean this up a bit. So now currently our left pointer is here, right pointer is here, right? Now if we see, left is equal to 3, right is equal to 5. If that is the case, left is actually less than right, and this is what the golden thing we wanted. Now we can clearly determine that this whole portion 3 4 5, that is completely sorted. Because this is completely sorted, all we will have to do is just use binary search in order to find the target value. So what we are going to do is we are going to compare the middle value. So middle value in this case is 4. 4 is actually exactly the target value we are looking for. So we will return the index position of 4, which is 1 in this case, as the answer, and the answer over here is going to be the one that we are going to return. Now after explaining this whole thing, let me quickly go over one of the examples to see that how we will solve optimal solution using binary search. Okay, so now as mentioned, we are actually going to do the binary search operation on this rotated sorted array, right? And the target we are trying to find is the value number 0. Now we are going to use our 2 pointers. So first pointer we have is left, that is located at this position number 3, and right pointer is located this position number 2. In this case, currently left is actually greater than right, which is not what we want. So now we will have to determine that which portion of the array is sorted, and based on that where this target value could lie. So we are going to compare with the middle value. So in this case, the middle value is going to be 7, right? So now we have this value number 7 that is located as the middle value. Okay, now for this middle value, we are going to compare it with left and right value. So currently, if we see, left is actually less than middle value, and this is what we wanted. The moment we identify left is actually less than middle value, we can clearly determine that this whole portion is completely sorted. Okay, now we will compare the target value we are looking for with the values of left and mid. So if we see, the target value is actually outside the scope of this left and mid, which means that target value cannot exist between these places. Immediately we can determine that. So we will ignore all of these cases, and now we will have to update our left pointer to go on the right side of the middle pointer. So we will do that. So now we will have our new left value located at this position, and the new right value located at this position. Now we are again trying to find the value 0. Okay, now immediately over here we can see that left by itself is actually 0. So that makes our life much more easier, and we can simply return the index value of this left to be 5 as the answer. And in this case, we are going to return answer as the 5, and basically all we are doing is we are actually using the middle value to determine that which portion of the array is sorted. Depending on that, and based on the target value, we decide that which way we will have to make the jump, and then we get our desired answer. If we see time complexity, in this case the time complexity is actually going to be big O of log n only. Why? Because remember, in a single iteration we were able to get rid of all of these elements immediately, which means every single iteration we are doing like half, we are getting rid of half of the elements. So that is why the time complexity is log n, and that is what we wanted. If we see space complexity, in this case the space complexity is actually going to be constant space, because we are not using any additional data structure. So first of all, we are going to define a couple of variables left and right. Okay, now we are going to initialize our while loop, that while left is less than or equal to right. And inside our loop, first of all, we are going to calculate the mid pointer. Now we are going to check for the condition that if the given value of mid, if that is equal to target, if that is the case, we can simply return the index at mid. Okay, if that is not the case, now we will have to first of all define that which portion of the mid pointer is actually completely sorted. So first let's put the condition that if the given value of left, if that is less than or equal to whatever the value of mid is, if that is the case, we can define that the values between left and mid is completely sorted, right? So now all we will have to do is we'll have to see that where target lies. Does it lies between left and mid value, or it lies somewhere else? So first we are going to see that what if the target lies outside of left and mid value. If target lies outside, basically we will have to update our left pointer to go mid plus 1, and we will continue with our journey. If that is not the case, which means target lies between left and mid, and if that is the case, we will have to update our right pointer to come between left and mid. So we will do right equal to mid minus 1. Okay, now we take care of the scenario that the numbers of left is not less than or equal to mid, which means that the values between mid and right is actually sorted. And if that is the case, again we are going to repeat the same process. First we are going to check that whether the target value is outside the scope of mid value and right pointer. So if the value is outside of the scope, which means we will have to update our right pointer to search on the other portion of the array. So right is going to become mid minus 1. And if that is not the case, which means that the values lies between mid and right value. If that is the case, we will update our left pointer to search between mid and right. So left would become mid plus 1. And basically this loop should take care of the scenario, and we would be able to find our answer. And just for the sake of putting something outside so we don't get a compilation error, we are going to return -1, but our answer would have been returned by this. Now let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs pretty efficiently compared to a lot of other solutions. And I would be posting this solution in the comments, so you can check it out from there. Thank you. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do 2sum2 lead code problem where input array is sorted. And if you see some of the companies where I want to get a job who have already asked this question, there are companies like Amazon, Apple, Uber, Google, Facebook, Bloomberg, Microsoft, and Goldman Sachs. So that's why I'm paying my utmost attention. I hope you also enjoy the video. This is a LeetCode medium problem and also a very well-liked problem. This 2sum2 problem is actually very similar to the 2sum problem which we originally solved over here. So you can check it out, that solution, if you want. Now let's understand this problem statement. So basically we are given a one index array, and this is only given one index just to add some additional complexity, nothing more than that. And we are also given an array of numbers. Now we are told that all the numbers, they are already sorted in non-decreasing or ascending order. Now we need to find two such numbers that they add up to a specific target, and we are also given this target value as the input for our method as well. Now we need to provide the index values for those two numbers as the answer. So let's try to understand this with a couple of examples. So if we take this example 1 and 2 over here, I have drawn it much bigger over here. So first of all, we are given a nums array like this, and if you notice that the indexing is actually starts from 1 rather than starting from 0. We are also given some target values. So in this case the target value is 9. So now we need to find any two values that sums up to 9. So we can clearly see that 2 plus 7 equals to 9, and in this case we need to return the index value of this 2 and 7. So the answer in this case is going to be 1 and 2 as the answer. If we take second example, over here we are given the target value to be 6. So clearly we can see that 6 is going to be the sum of actually 2 plus 4. Now remember, we can also do over here like 3 plus 3, but the thing is we cannot repeat the same character again. So in this case the answer has to be 2 plus 4, that equals to 6, and we need to return the index value. So index values in this case is going to be 1 and 3, and this is going to be the answer. So after understanding the problem statement, let's see that what are going to be the different approaches to solve this problem. So the first approach that comes to our mind is a brute force approach. In the brute force approach, what we can do is we can simply take every single possible two pair that we can make and try to see that whether we can come up with the target value for those two pairs. If we do get the target value, we simply return their index numbers. So in this case, we are given the target to be 11. Now we can make different pairs that looks like this. That first of all, we'll take the first number and then we will make all the possible pairs. We don't find any sum that comes up to 11. So we can ignore this one. Now we'll start with the second value and keep on repeating the same process. So the moment we do that, when we do the sum of this 5 plus 6, we get 5 plus 6 to be 11, and this is the answer. So in this case, we can return their index values. So in the index values in this case is going to be 2 and 3, and that would be the answer we can return. Now this brute force solution leads up to the correct answer in terms of the index values that we are looking for. But the thing is, this is not the most efficient way to do it, because we have to deal with lot of different sub arrays or sub pairs. So if we see time complexity for this brute force approach, it is actually big of n square, because for every single value we have to compare it with all the other remaining values, and that is pretty disastrous. So let's see that what is going to be the better approach. Okay, so the next approach that comes to our mind is a binary search. Why binary search? Because remember, we were originally told that this input array we are given, that is already a sorted array, which means all the values that they are sorted in ascending order. So we can actually use binary search to our advantage in order to find the target value pair. The approach I'm suggesting is that first of all we take any value. Okay, so the current value in this case is 2, right? So if 2 is supposed to be part of this answer, let's imagine that 2 is part of this answer, then 2 can only be part of the answer if the value 11 minus 2 equals to 9. If this 9 is somehow present inside this given input array, we can clearly determine that 2 and 9 can be part of the answer that leads up to the target value 11. So all we need to do is once we identify the value number 2, we come up with the remaining value that is needed to generate the answer, that is 9, and then we can simply do a binary search in this case to see that whether 9 exists or not. We can find this immediately in log n time because this array is already sorted. So at any given moment, all we have to do is just calculate the middle value and see on which side of this middle value does this 9 falls, and eventually that would lead up to the correct answer. So first of all, if we see for this value number 2, 9 does not exist, right? So because 9 does not exist, we can ignore the case for this value number 2, and we can define that 2 is not part of solution that leads up to the target value 11. Now again we are going to repeat the same process. Now the next value we have is 5. So now if the value is 5, all we have to do is to see that what is going to be the remaining value, and remaining value in this case is going to be 11 minus 5. So 11 minus 5 is equal to 6. So now we only have to check that whether this 6 exists inside the remaining array or not, and that we can do using the binary search in log n time. So now what we will do is we'll try to find the middle value. Let's say that middle value in this case is 12. So 12 is greater than 6. So because 12 is greater than 6, we only have to compare between these three values. So again the middle value is 8. Again 8 is still greater than 6. So now we only have one value on the left of the 8 and right of the 5, so which is already 6. So immediately we can find that value, and because we find both 5 and 6 to be existing, so 5 plus 6 equals to 11, we can simply return their index values to be 2 and 3. So 2 and 3 is going to be the answer in this case. If we see, binary search actually works pretty better than our brute force approach. Why? Because if we try to calculate the time complexity in this case, the time complexity is actually going to be big O of n log n. Why n log n? Because in the worst case we might have to iterate over every single character in order to find the target value, and for us to find the remaining value we have to do log n work. So again, if we see this solution is much better compared to our brute force approach, which had the time complexity of big O of n square. Now the question is this the most optimal way to solve this problem? And the answer is no. There is still one more solution that can give us the answer in big O of n time. Okay, so the optimal solution I am proposing is actually using two pointers. So suppose this is the array input array we are given, and we are given the target value to be 13, right? Now we already know that 6 plus 7 is going to be the answer. But let's quickly see the approach I'm suggesting. Basically, we are going to have two pointers, left and right. Now remember, all the values that are on the right side of this left pointer are actually greater than this value of left, right? And same way, all the values that are on the left side of this right pointer is actually less than whatever the value at right pointer we had. So the idea is, originally we are going to do the sum of this left pointer and right pointer. We are going to compare that sum to this target value. Now if the sum is actually greater than target value, which means we need to lower the sum. How can we lower the sum? We can only lower the sum if we move this right pointer on the left direction, because remember, all the values that are on the right that are on the left of this right pointer, they are actually less than this right pointer. So if we reduce the values, automatically sum is supposed to go down, and that would lead us near the target value, right? Again, same way, if we identify that sum somehow is actually less than the target value, if sum is less than the target value, which means we will have to increase the value of the sum. How can we increase the value of the sum? By increasing the value of the left pointer, because all the values on the left pointer are actually greater, and right pointer will remain constant in that case. And if we keep on repeating the same process until we come up to the sum that equals to target value, eventually we would get the two pointers located at the correct position that would lead us to the correct answer. How? Let me quickly show it to you. And by the way, let me also mark the indexes in this case as well. So now we have our left pointer and we have our right pointer, and we have the variable sum, right? Currently left is equal to 2 and right is equal to 42. If we see sum of these two, sum is actually going to be 44. 44 is definitely greater than 13. So because 44 is greater than 13, we will have to somehow reduce the values. So what we are going to do is we are going to update the right pointer to move 1 point to the left side, right? So now our new right pointer is going to be this one. So now our right pointer value is 21. So 21 plus 2 is still going to be 23. Now 23 is again greater than 13. So because of that, we are going to shift our right pointer again. So now right pointer is at 12. 12 plus 2 is 14. 14 is still greater than 13. So again, we are going to switch our right pointer. So now right pointer is at position number 10. So now the right pointer value is 10. So now 10 plus 2 is equal to 12. So 12 is not greater than 13, is actually less than 13. So now we will have to update our left pointer. So if we update our left pointer is going to become value number 5, right? So now this value is 5. 5 plus 10 is again 15. So 15 is again greater than this value number 13, right? So now again we are going to switch our right pointer to go 1 point to the left. So now the right pointer value is actually 7. So if we do 7 plus 5, 7 plus 5 actually gives us the answer to be 12, right? So now this 12 is still less than the value number 13. So because this is less than the value number 13, again we are going to update the value pointer of the left pointer. So now left pointer is at position number 6, right pointer is at position number 7. 6 plus 7 is equal to 13, which is exactly equal to whatever the target value we had, and that is the correct solution. So now basically the positions of left and right pointer, we simply need to return that as the answer. So the answer in this case is going to be 3 and 4. And this is the correct way to solve this problem. Now, what is the benefit of this approach? Well, if we see, we are actually computing everything in just single iteration. We are not doing multiple repetitive work. So if we see time complexity, in this case, the time complexity is actually going to be big O of n, which is a much better improvement compared to our brute force approach and also our binary search approach. If we see space complexity, in this case, the space complexity is actually going to be constant because we are not using any additional space apart from storing a couple of variables, which is also a good sign. Now let's move on to the coding. So first of all, we are going to initialize the two variable left and right. Now we are going to run our while loop, that while left is less than right. Now inside the loop, first of all, we are going to check that whether the combination of left and right, if that is greater than the target value. So if that is the case, we will have to reduce the sum, which means we will have to reduce the value of the right pointer. So right is going to become right minus 1. Else if we are going to check that whether the sum is actually less than the target value. If that is the case, we are going to update our left pointer to go one step to the right. That is not the case, which means we are actually at the correct position. So we can simply return the index values. But remember, we are presented with one index array, so we are going to add one value to the left and right, and this was just the additional small complexity they added to the problem. Otherwise it would have been too simple. And basically in this loop we are taking care of everything, so we should have gotten the answer. If somehow we get out of the loop without returning the answer, we can simply return null, that we were not able to find the answer, and that should do the trick. Let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code, and our code runs decently efficiently compared to a lot of other solutions in terms of time complexity. In terms of space complexity, it's actually pretty efficient because we are not using any additional variable to store the sum. And that's it. I would be posting this solution in the comments so you can check it out from there. Thank you. Today we are going to do three-sum lead code problem, and it is a very interesting problem. If we see some of the companies where I want to get a job who have already asked this question, there are companies like Amazon, Microsoft, Apple, Facebook, Uber, Bloomberg, Google, Tesla, ByteDance, and LinkedIn. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode medium problem and also a very well-liked problem on LeetCode. Basically, we are given an integer array called nums and we need to return the triplets. Now we need to return the triplets such that the sum of all of those triplets is actually equal to 0. And we are also given the definition that the elements has to be unique. So I, j and k is supposed to be the triplets, and they should not be the same. They should be different values. We are also told that the answer set must not contain any duplicate triplets. So this is an additional set of complexity that we will have to take care of. Now let's try to understand this problem with a couple of examples that are provided over here, and I have actually broadened these examples. So let's try to understand them. So suppose this is the input array nums we are given. We need to find the triplets such that the sum of each of all the triplets is equal to 0. So if we see that in this example, we can actually find the sum of these three values to be 0. So first of all, we are going to add these three entries into our answer, that -1, 0 and 1. This triplet equals to 0, so we can add that to our answer list. A second triplet we can find is the value -1, again -1, and value +2, because -1 plus -1 plus +2 is also equal to 0. So again we can add it to our answer set, that 2, -1 and -1 as the answer. And now apart from that, we cannot find any more triplets, so this is the only answer we are going to return. One critical thing to understand over here is that this -1 is actually using 2 times in 2 different answers. That is perfectly fine, but we cannot have an answer where we already have the value like -1, 0 and -1, and again we have the value -1, 0 and +1. This should not be the answer. So this is one of the conditions that is given. Second condition is that all the values of I, j and k has to be unique, so they are located at unique positions, because we cannot use the same value again and again. We cannot do something like 0 plus 0 plus 0 equal to 0 and return that as the answer of the triplet, because in this case we only have 1 0, not 3 zeros. So just keep all of these things in mind. If we take a look at the second example, over here we actually do not have any pair that equals to 0, right? So in this case we are only going to return an empty array as the answer, and basically this is what the problem is asking us to solve. Now there can be two potential solutions for this three-sum problem that we are trying to deal with. First solution is actually a two-sum problem solution. That is also another LeetCode problem where we use hashing to generate the solution for this two-sum problem. Second solution is two-sum 2 problem where we actually use 2 pointers to come up with that solution. And in this case we are going to see that how using hashing we can solve this three-sum problem, or how using 2 pointers we can solve this three-sum problem, because both of this concept can be useful. We can choose either one of them. Now I'm going to show you the theoretical knowledge of both the problems, but I'm only going to show you coding for this two-sum 2 problem. Let me know in the comments if you want to see the code for this two-sum problem as well, and I can show it to you. Okay, so first let's see that what is going to be the optimal solution using the solution we used in the two-sum problem. Now, if you want to know more about two-sum problem, you can check out my video over here, and that is going to give you much more clarity. Okay, now let's get back to our question. So if we suppose this is the original input that we are given, and we are trying to find a set of triplets that sum up to 0, right? Which means we are trying to find 3 different values where I plus j plus k is equal to 0. Okay, that is the whole idea. The technique we are going to use is that, okay, suppose this is the first value, right? Suppose if we consider I is equal to -5. Once that is done, what we will have to do is we will have to try to find that if j plus k is equal to +5, if that exists inside this remaining array, if that is the case, then we would actually have a triplet called I plus j plus k that sums up to 0, because I is equal to -5, j plus k is equal to +5. And now we simply need to see that inside the remaining array, do we have a pair j plus k that is equal to +5? And that was actually the original question for this two-sum problem. So that is how everything is linked internally. The idea is, okay, that we can find it easily using a hash map or a hash set, and then we would be able to get this answer. The problem that would come in this case is that because we are trying to avoid duplicates, and what would happen with this approach is that, okay, suppose if we consider I is equal to -5, right, we would actually have an answer where the values of -5, 0 and +5 exist as one of the answer, and we are able to generate this. Okay, so now we are able to say that, okay, this -5 we have already taken care of and we found the correct answer. But if we look somewhere inside the remaining array, we would also find another -5. So when we try to repeat the same logic, basically even for this -5, we will also have the I is equal to -5, and we will try to find j plus k is equal to +5. Then again we would have another answer that also looks like -5, 0 and 5. And remember, these is going to be the duplicate value that we are trying to avoid. So in order to make our lives easier, what we can simply do is, if we take this input array and if we sort this input array, and because when we sort this input array, we are going to have the same looking values right next to each other. So we can only have a condition that the moment we find out that two adjacent values, they are same. If that is the case, that if we find the two adjacent values to be the same, then we are simply going to ignore that case and move on to the next value. Okay, so now after this whole explanation, let me clean this up a bit and create the sorted array. So now we have our sorted array, right? Now we will try to see that what could be the potential I, j and k values. Now based on the I value, we will also have to determine that what should be the j plus k value, and based on the jth value, we will also have to determine that what should be the kth value, right? That is how we are going to do the things. So first let's try to see that if I is equal to -5. If I is equal to -5, we will have to find j plus k is equal to +5. If we have to find j plus k is equal to +5, we will try to start iterating over this remaining array. Again, we are going to create a hash map or a hash set over here. So let's create a hash set first. Okay, now we are going to start iterating over all the remaining values. Okay, so suppose this value is -5, so we'll try to consider j to be -5. If j is equal to be -5, then k has to be +10. And now we are trying to see that, okay, we'll see that if this k is equal to 10 exists, if that is the case, we will return that. If it does not exist, we are going to add that value to our hash map. Okay, so because k is equal to 10 does not exist, we will have to add all the values to our hash map. And remember, there is a property of a hash set where it does not exist duplicate values, so we will only have unique values inside over here. So since j is equal to -5 didn't work, we'll try to see that whether j is equal to -3 works or not. So if j is equal to -3, then in that case we will need the kth value to be +8. +8 also does not exist, and we can look that up immediately because of this hash set, right? Now we will try to find another value. Okay, so if that didn't work, we will try to see that whether j is equal to 0 works or not. Okay, so if j is supposed to be 0, then the value of k has to be +5. Okay, that we can look up immediately, and we would be able to find that k is equal to +5 already exists inside our hash map. So immediately we found that we are actually going to have an answer list where we are going to populate the values of I, j and k we found. Okay, so we are going to add the values -5, 0 and +5 immediately. Now we are going to repeat the same process for all the remaining values, right? So, and for every single value, we will also have to create the new hash set and new I, j and k values. So we will empty this one. Okay, now the new I value is actually -5. The thing is, this is a trap because we already had a value -5 that we already iterated over. So we will not have to use this one, and that is how we are going to avoid duplicates. Now suppose if next I value is -3. Okay, so if I value is -3, then j plus k has to be +3. Okay, so if j plus k has to be +3, let's see that what could be the potential remaining j plus k values over here. Okay, so over here currently jth value is 0. So if jth value is 0, then kth value has to be +3. Okay, so we'll try to see that inside the remaining array whether +3 exists or not. +3 does not exist, but that is going to help us fulfill our hash. So we are going to add all the entries to our hash map, and we couldn't find k is equal to 3. So now we are going to try the new value of j is equal to 0. So again, because this 0 we already consider for j, we should not be considering this 0, so we can just simply jump over. Okay, so now next value is j is equal to 1. If j is equal to 1, we will try to see that whether k is equal to 2 exists or not. And k is equal to 2 already exists, that we can clearly see over here. So because it exists, we are actually going to have j and k values properly set up, and we are also going to add one more triplet to our answer, that is -3, 1 and 2. Okay, now we can ignore this one. Okay, now current ith value is 0. Okay, if ith value is 0, then j plus k has to be 0. Okay, So now we'll try to find j plus k to be 0. Now inside the current method, okay, now this next value of j, potential value of j, this is the 0th value. So we'll try to add this value, and by the way, I forgot to clear the hash, but it would be cleared. Okay, now if j is equal to 0, then k also has to be 0. Okay, so currently k is equal to 0 does not exist inside the remaining array. So because it does not exist, we will try to jump on to the next value of j. If j is equal to 1, can work or not. So if we try to put j is equal to 1, it is definitely not going to work, and we won't be able to find a pair j plus k is equal to 0. So I is equal to 0 is also not going to work. Because I is equal to 0 not going to work, and we have already taken care of this 0, so which means we don't have to see for this 0. Now we will try to see that whether I is equal to work or not. But the question is, do we really want to check whether I is equal to work, 1 is going to work or not? Because inside the remaining array, all the values are actually going to be positive values. So because these values are going to be positive values, j plus k is always going to increase the value of whatever the sum of I, j and k is going to be, because this I is positive. So immediately we can stop our search, and whatever the answer we have found, we can actually return that as the answer. And that is the whole approach. Now, and if we see time complexity, in this case the time complexity is actually going to be big O of n log n, that is to sort the array, plus big O of n square. Why? Because for any single ith value, we will have to find j and kth value, which means for every single one of them, we will have to iterate over the entire list of all the arrays. So that takes like big O of n square, and that is the best we can do. If we see space complexity is also going to be big O of n, because for this sorting operation, it takes big O of n time, and plus we are also creating this hash, so that also takes big O of n space. Okay, now we will try to see that what is going to be the optimal solution using the 2-sum-2 problem. Now, if you want to learn more about this problem, you can check it out my video over here, and this is a very good explanation for that. Now we are going to use the same example as the input, and as mentioned for the reasons explained before, basically we are going to use the sorted array in this case as well. So from this original input, we are actually going to create a sorted array first, so that is going to help us avoid duplicates. Now the again idea is that currently we are going to consider the one value to be I. Okay, so suppose we are going to consider I is equal to -5. If that is the case, j and k value could be potentially possible, where j plus k is equal to +5, right? And inside this remaining array, we will have to find the +5 value. So what we are going to do is we are going to initialize couple of variables. So first is going to be left pointer, and second is going to be right pointer. Now every time we are going to do left plus right. If left plus right is equal to 5, then basically we are good, our life is set, and we can simply add it to our j plus k values. If that is not the case, if we somehow find that left plus right is actually greater than 5, if that is the case, then somehow we will have to reduce the sum of this left plus right. How can we reduce the sum of left plus right? By shifting this right pointer on the left hand side. Why? Because all the values on the left of this right pointer are actually less than whatever this right value we had. And if somehow we identify that, okay, this left plus right is actually less than the answer 5, if that is the case, we are going to update our left pointer to go one step on the right side. So then we would be able to increase the sum that we are trying to achieve, and that is how we would be able to generate the correct j and k values. So let's try to see the approach in action. So suppose currently the ith value is equal to -5. Okay, I is equal to -5, j plus k is equal to +5 we are trying to find. Okay, so once we have the j plus k value we are trying to find, we are going to initialize two variables, left and right. Okay, so currently our left pointer and right pointer, we are going to be concerned with that, and we are also going to be concerned with left plus right sum, and that is referring to whatever the value we are trying to find. Okay, so currently the target value is 5. Okay, now the current left position is -5, current right position is +5. So left plus right is equal to 0. 0 is actually less than -5. So because 0 is less than -5, we will have to update the value of our left pointer to go one step on the right. So now the current left pointer is -3. -3 plus 5. So if we do -3 plus 5, the value we get is 2. 2 is still less than 5. So because 2 is less than 5, again we are going to update our left pointer. So now the left pointer is at 0th position right over here. And currently the sum we are going to get is that, okay, this is 0, this is 5. So 0 plus 5 is equal to 5. So currently left plus right is equal to 5. 5 is exactly what we are looking for based on this remainder value we have created. Okay, so now this left pointer can be assigned to this j value and right pointer can be assigned to this k value, and we can actually populate our answer. So inside our answer we are going to have the first entry called -5, 0 and +5 as one of the answer. Okay, now we are done with taking care of this -5. So now we'll have to take care of this another value. But again, same thing, this value is also -5, same as the previous value. So again we are going to ignore this case as well, and now currently our I is going to be -3. Okay, so now if we put our I to be -3, our j plus k sum has to be +3 in this case. Okay, so j plus k has to be +3. Again, if j plus k has to be +3, we will also have to update our left and right pointer. So currently left pointer is also going to be at the position 0, right is going to be position number 5. Okay, and we will also have to update this value as well, that this has to be 3. Okay, now currently 0 plus 5 is actually 5. 5 is actually greater than 3. So because 5 is greater than 3, we will have to reduce the value of our right pointer. So currently our right pointer is going to come over here. So now the right pointer value is actually 2. Okay, so if we do 0 plus 2, 0 plus 2 is actually going to be 3. So 3, sorry. So now if we do 0 plus 2, 0 plus 2 is actually going to be 2. 2 is now less than whatever the value of 3 is. Because of that, we will have to update our left pointer to go on the right side. Now the moment we do that, okay, this value is also 0, same as the previous value. So because of that, because we have already calculated this 0, we are actually going to ignore this 0 as the left pointer, and our left pointer is going to come over here. Okay, so now the value of our left pointer is actually 1. So 1 plus 2. So 1 plus 2 is actually 3, and 3 is what we are looking for, that we already find the answer. So we are also going to populate the values of left and right over here, and inside the answer we are going to have one more entry called -3, +1 and +2. Okay, now okay, now we have taken care of all the cases. Now again, this value I is equal to 0. If I is equal to 0, we will not be able to generate the answer, and now in this case I is going to be 1, so that is going to be the positive value. So because of that, we are actually going to break out of it, and simply whatever the answer we have found, we are able to return that as the answer using this 2-pointer solution. And even for, if we see the time and space complexity, in this case the time complexity is also going to be big O of n square plus big O of n log n. Why? Because we will have to do the sorting operation. If we see space complexity, the space complexity is also going to be big O of n. That is going to depend on the implementation for the sorting we are using. So that is how we are able to generate the solution. If you see, in this case we are actually not using any additional hash set, so that is a plus benefit in my opinion. And if you show both the approaches in any interviewer would be like more than happy with you. So first of all, we are going to sort the given input nums, and we are also going to create a new variable called result to store the list of lists that is needed over here. Now we are going to run a for loop across the given input nums. Notice inside the for loop, we are only running it up until the point where the value of nums of I is actually less than 0. And the moment it gets greater than 0, there is no point in continuing with the loop. So we just simply ignore that. Now inside the loop, we are actually going to call our toSum2 function, but for that we actually have a couple of conditions that we are going to take care of. So first condition is that if the given value of I is equal to 0 or the starting position, then we do it, or we check that whether the two adjacent values of I and I minus 1 are the same or not. If they are not same, then only we call our toSum2 function, otherwise we ignore that particular entry. Inside the method, we are going to call the toSum2 method, where we are going to pass in the value of the given input integer nums, the current ith position, and the result variable. And basically that's it. Once this for loop ends, basically with the help of this toSum2 method, our result should have been populated, so we can simply return the result. Now it's time to create the new toSum2 method. First of all, we are going to initialize two pointers called left and right. Now we are going to have our while loop, that while left is less than right, we are going to do some interesting things. First of all, we are going to have a variable called sum that is going to calculate the current total sum. Now we are going to check that if the given sum, if that is less than 0, if that is the case, we will have to increase the value of the left pointer. Else if we are going to check that if the given sum is greater than 0, if that is the case, then we will have to reduce the value of our right pointer. And if both are not the cases, which means our current sum is exactly 0, so first of all we are going to add a new entry to our result variable that we have created. After adding the values to the result, we will again have to update our left pointer until the point that whether the two adjacent values of left pointer they are same or not. Basically that's it. This should have taken care of all the scenarios, and this should be working. Now let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code, and our code runs decently efficiently. Hello friends, so today we are going to do an awesome interview question that has been asked in companies like Facebook, Microsoft, Amazon, Apple, LinkedIn, Google, and bunch of more. So without any delay, let's get started. So the LeetCode problem we are going to do today is called merge sorted array, and you can see that this is a very well like LeetCode problem and also a LeetCode easy problem. Now we are simply given two values of two arrays called nums1 and nums2, and we are being told that these are sorted in non-decreasing or increasing order, which means we already have two sorted array called nums1 and nums2. And now from the name we can judge that we want to create an array that contains values from all the values that are currently present in nums1 plus all the values that are currently present in nums2, and this array also needs to be sorted. That is the whole ask of this entire problem, nothing much. So first let's try to understand this with an example. Suppose we are given nums1 array that looks like 1, 3 and 5, okay, and we are given nums2 array that looks like 2, 4 and 6. So obviously we need to create a sorted array that is going to be combination of these two arrays, and we just need to make sure that this is also sorted. So answer is going to be 1, 2, 3, 4, 5, 6. This is going to be the sorted array that is combination of these two. But for this problem, just to make it like a little bit spicy, a little bit tweaky, they gave us like few weird combination. So what they have told us is that we do not need to create this whole new or brand new array. What we need to do is we need to combine these two values, but we need to put all of these values in just nums1 array. Now the first question comes to our mind is that, hey, this nums1 only contains 3 elements. How can we put 6 elements inside this nums1 array? If we have to do that, we will have to basically just expand the array and create a new array and do all sorts of migrate operations. But the thing is, what they have actually done is that in this kind of problem, instead of giving us the input like this 1, 2, 3, 1, 3, 5, they are also given us 3 zeros and the trailing end of 1 or nums1 array, and nums2 array is going to contain values like this. On top of it, they are also providing us 2 extra values. So first value is called m and second value is called n, and both these m and n represents is the number of values that are currently present inside this nums1 array. Now by looking at nums1 array, we can see that there are actually 6 values present, but for our case we only need these 3 values. These 3 are just simple placeholders that are currently present inside our array. They actually don't serve any purpose. So for this nums1 array, this value number n would be value number 3, and for this nums2 array, this value number n would be value number 2. This would say that nums1, this would also be 3. So this would say that nums1 array contains 3 elements. This would say that nums2 array contains 3 elements, and if we see the total size of this nums1, it is able to store 6 values, which means this stored array would actually be stored in this nums1 instead of creating a separate array like this. And that's it. I know understanding this problem is actually more complicated than solving this problem. So let's try to see how we can solve this. And yes, we can exactly solve the way you are thinking, the way we would logically do, but we are just going to use pointers in this case to solve this problem. And we are also going to do a couple of things here and there in like different order for the ease of simplicity for our problem. So what we are going to do is, let's assume with the same one, let's say that we are given this nums1 array, and this contains three elements, that is 1, 3 and 5. And the rest elements are zeros. Okay, so it contains let's say 3 zeros. Okay, and we are given this nums2 array, and this contains 3 elements, and these 3 elements are 2, 4 and 6. Okay, and we all know what the answer is going to be. But what we need to do is, at this particular position, the value needs to be the highest value that is currently present amongst both of these arrays, and the highest value can only be present at the end of this location or at the end of this location, because we are told that these are sorted values. And because these are sorted values, so these two are the maximum values present amongst each array. So the value that goes in the last element would be the maximum value amongst these two values. And then all we need to do is whichever value we put over here, we need to take care. So let's assume that we decide that we need to put value number 6 in this case. Okay, so let's update value number 6 over here. And we can say that, okay, because we are putting 6 over here, now this 6 is under no consideration. So now we need to check for the second largest value. We need to check the second value in this array and the very last value in this array. Whichever is greater, we are going to put that. So we are going to put value number 5 here and get rid of 5. And same way, if we keep on repeating the same process, we can simply fill out our array and we can put all the values in nums1. Now the question would come to you that, hey, why are we starting from the back and why are we not starting from the beginning? And the only reason we are starting from the back is because we don't have to do a lot of overwrite operations, because we are being told that these three values are already 0. They are not going to be part of our conclusion, and we can simply update the values rather than thinking about changing the values and then storing the temporary value. Because imagine if we have to make changes over here, imagine that instead in this case, let's assume that this first value is value number 2 and this value is value number 1, and now we are trying to find the smallest value. In this case, we will have to put 1 over here, and then we will have to store this 2 somewhere else, and then we will have to repeat the same operation for these two values and so on and so forth. So in order to make sure that we don't fall into the scenario of making updates, we are simply doing that. And now let's see that what is going to be the actual way. I just explain you the method. The only thing we are going to do is we are going to have 3 pointers, and the first pointer is going to be the last value that is currently present for nums1. So for this, our example 1 3 5 and then 0 0 and 0. Okay, so our first pointer is going to live at this point and we can just name it as I. Now for this second pointer, that is going to be our value of m and n. Okay, so let's say that these are the values we have. So this is where the m pointer is going to live, and this is where the n pointer is going to live, and this would be the same value that we can get from the values m and n. And now for the ith location, we need to check that whichever value is greater compared to m and n, until these values reaches to the very first element. So this is going to be our loop condition. We first check, okay, so currently n is greater. Because n is greater, we are going to move value number 6 in this place, and we are going to migrate this pointer number n to come over here. Once again and we are also going to migrate value number I. So now I is currently present on this pointer. Once again, we are going to repeat the same same process. Now 5 is greater. So we are going to update the value of pointer m. We are going to add value number 5 over here, and we are going to again repeat the same process. So now this is our m and this is our n once again, and we also update the ith pointer to come at the one location on the side, on the left side. And if we keep on repeating the same process, eventually we would have our n1 that looks like 1 2 3 4 5 and 6, and this is going to be the answer. This is a very simple problem, so that's why the answer is also very simple. If we see time and space complexity, time complexity is going to be big O of n, where n is the number of total values that are present in both n1 and n2 items. If we see space complexity, well, space complexity is going to be big O of 1, because apart from storing couple of pointers, we are not using any additional values. To solve this problem, the very first thing we are doing is initializing 3 pointers. Then we are running our while loop, that while pointer 2 does not reach to the very first index of the nums1 array, we are going to keep repeating the same process. So first we are going to check that whichever value is greater is going to be placed on the ith location, and whichever value that we picked out, we are going to reduce that pointer. At the same time, in either case, we are always going to decrease the pointer of ith location, and eventually we would have all the values sorted in the nums1 array. And this is the code. So let's try to run the code. Okay, seems like the solution is working. Let's submit this code. and our code runs 100% faster than all the other solutions, which is pretty good and pretty awesome. So I would be posting the solution in our GitHub repository, and the link is in the description, so you can check it out from there. Thank you. Today we are going to do container with most water LeetCode problem. And if we see some of the companies where I want to get a job who already asked this question, there are companies like Amazon, Apple, Google, Microsoft, Facebook, Goldman Sachs, ByteDance, Bloomberg, TikTok, Uber, and Tesla. So that's why I'm paying my utmost attention. I hope you also enjoy the video. This is a LeetCode medium problem and also very well liked problem on LeetCode. And like any LeetCode problem, we are given some input and we are expected to get some results from this particular input. But before we start understanding this problem, first let's see this concept that I'm trying to explain. Okay, so suppose we are given a container that looks like this, and we are trying to see that how much water can we fill in this container. Well, the logic is actually quite simple. We can only fill water up until this point inside this given container. Anything more, if we try to add water over here, that water would simply spill out. We won't be able to fill our water above this line. So that is a given fact, right? That is a very simple explanation. Now, if I ask you that how much water is present in this container, so then in that case, the answer is simple. There can only be water up until this point, nothing more than that. So in this case, for this particular container, rather than considering this container to be a container, if we consider this to be a rectangle, things becomes easy for us, because we know that the surface area of rectangle is the amount of water we can store in this particular container, and we know the formula to calculate the area inside any given rectangle. Suppose this is the height of the container and this is the width of the container. If we are given these two values, basically if we do h times w, height crosses height multiplied by width, we will get the amount of area, and that would equivalent that how much water we can hold in any given container. Now let's try to understand another scenario. Suppose we are given a container that looks like this, or we are given a container that looks like this. In these two cases, how much water can we store? Well, the answer is again simple. We can only fill water up until this point, till the lower edge on any given container, not more than that. So now in this case, we are actually given two different heights for each sides of the given container, right? So suppose this side is h1 and this side is h2, and same goes over here. This one is h1 and this one is h2. If that is the case, if we try to calculate the area in this case, the area equation for the water is gonna change. Why? Because we are not going to use h1 over here, because this is the higher side. We are actually going to use h2, which is the lower side. So in this case, the area is going to be h2 times width for this particular container. But for this particular container, the equation is actually going to be h1 times width, because this h1 is actually smaller in this case. So these are the two concepts that you will have to understand. And now let's go back to the problem. Okay, so now in the problem, we are actually given an array called heights of length n. And now if we try to plot this array of height on a graph, we can consider that based on the x-axis, we can actually create a container. And then we need to find that what is the container we can create that contains the most amount of water. And then we need to return the amount of water that the maximum container can store. Now, I know that the wording may sound confusing, so it would be better by understanding with this example. Suppose we are given an array heights like this. So if we try to plot this array heights on a graph, we can actually get a graph that looks like this. Now in this graph, you can see that there is a difference between lines, and based on these line differences, we can actually create some sort of containers between any two vertices. And the amount of water we can fill will depend on the lower side of the height rather than higher side of the height. So in this case, we can actually create a container that looks like this. So if we try to consider this index number 1 and index number 4, the container we can create is going to look like this, where this is the amount of water we can fill, nothing more than that. Now remember, as mentioned earlier, that for every single time, if we want to calculate that what is the amount of water we can find, we need to calculate the area of the presumed rectangle, and for that we need the height, which we already have based on these values, which we can derive from the array. and we need the value of the width. So width we can achieve by calculating the difference between any two places on the x-axis, and these values we can determine depending on the index values of the given input array. So it makes our lives easier. So in this case, if we try to see that some of the containers that we can make a container that looks like this amongst these two values, and then we can calculate its water. So I'm just showing you for an example. So in this case, the minimum height is actually 5. So height is going to be 5, and the width in this case is actually going to be 2. So 5 times 2, we can say that, okay, there is 10 units of water we can put in this container if this was to be the container. The thing is, we are trying to find the maximum maximum water we can make amongst any given container. So in this case, the answer is actually going to be this container, where the current height is 7 among 7 and 8. So we are going to choose 7 as the height. Okay, so h is equal to 7. So okay, it's going to be 7 times the distance. So distance in this case, okay, this value is 2 and this value is 9. So distance is also 7. So in this case, 49 is the maximum unit of water we can contain, and that is going to be stored between this container. Basically, I hope that this makes understanding this problem easier. And after understanding the problem, now let's focus on different solutions that we can achieve. The first approach we have is the brute force approach, and suppose this is the input we are given. If we try to plot it on a graph, we can actually create a graph that looks like this. Now the idea is, we are actually going to check every single container that we can possibly make, and depending on that, we will try to see that what container contains the most amount of water. So basically, we are going to have two variable. First variable is called area to calculate the water at any given container, and second is going to be the max variable that is going to be update its value whenever we find a better area or maximum water we can contain, right? So first we will start with this first index, and we will try to see that, okay, what is the container we can make with between the index 1 and 2. We can make a container that looks like this. What is the container we can make between 1 and 3? We can make a container that looks like this, and say so on and so forth. We will keep on repeating our graph. After being done with this value number 1, we will ignore that, and we will start focusing from value number 2. So from value number 2, we can make container that looks like this, and then again a container that looks like this, and blah blah, so on and so forth. And eventually we would find an answer in this case between this value number 2 and 7 indexes, that if we make this container, that is going to hold maximum amount of water. And in this case, the answer is going to be, okay, so for this area, height is going to be 4 because that is the smaller amongst these two, and the width is actually going to be 5 because 2 minus 7 is 5. So maximum area is going to be 20, and 20 is the answer we are going to return. So this solution would work as expected, but if we see the issue with this solution, the issue is actually time complexity. Why time complexity? Because for every single value, we are comparing it with all the other values to see what is the container we can create, and we are not doing things efficiently. So basically, the time complexity in this case is big O of n square, which is very bad, and we will have to do something better. So let's see that what is the better approach we can get. So for the optimal solution, we are actually going to use two pointers to our advantage, and we will try to see that what is the optimal container we can make. So we are going to have a pointer left located at the first position, and we are going to have a pointer right located at the last position. The idea is both pointers are going to come towards each other until they meet or cross each other. Now every single position, we will try to see that depending on the values of left and right, what is the container we can make. And then we will try to calculate its area, and after calculating the area, we are going to compare the heights between left and right, and whichever has greater height, we are going to keep that height, and then we are going to update the remaining counter. So left counter will go on the right side, or right counter will come on the left side. So let's see the solution in action, and it will make more sense. So basically, initially first, if we see currently the height at left is 3 and height at right is 2. Okay, so if we want to calculate the area, we are going to calculate the smaller amount. Okay, so currently the smaller height is actually 2, and if we see the width in this case is going to be 7. Okay, so current area we are able to calculate is 14. We are also going to have a variable called max area. So currently the max area we have been able to find is 14. Okay, so far so good. Now we will try to compare the heights between left and right. Okay, so currently left height is actually greater, so it is in our interest to move right counter one step to the left rather than moving the left counter. Okay, so in this case right counter is going to come over here. Now again we are going to repeat the same process. So now currently the height at right counter is 6 and left counter is 3. Okay, so now if we will have to calculate the area again. So we are going to choose the smaller value amongst the height. So currently this is going to be 3 as the smaller height and width is going to be 6. Okay, so currently the area we can get is 18. 18 is greater than 14, so we are going to update the maximum area, maximum water we can contain to 18. Now we are going to compare the height between left and right. Now in this case the height at right is actually greater than left, so we are going to update our left pointer to go one step to the right. Now this left pointer is located over here. Currently the height is 2. Again we are going to calculate the area. So this height is actually going to become 2 and the width is actually going to become 5. So 2 times 5 is actually 10. So because 10 is less than 18, we are not going to update the maximum value we have been able to find. Again we are going to calculate the heights between left and right. So again right height is greater, so we will update the left pointer to go on one step on the right side. Now currently the height over here is 7 and currently the other height is 6, so we are going to choose the smaller height. So the height we are going to choose is going to be 6. 6 times the width is going to decrease. Okay, so currently the width value we have is going to be, okay, this is okay, this is left pointer, so 3 minus 1 4. Okay, so 6 times 4, so this area becomes 24. 24 is actually greater than 18, so because 24 is actually greater than 18, we are going to update the maximum area we are being able to calculate. Okay, so this is 24. Now again we are going to compare the heights between the left pointer and right pointer. So currently right pointer is actually less, so now we will have to update the value of the right pointer. So currently this becomes our right pointer. Now this value is 3, this value of left pointer is 7. So again the height is actually going to be 3 and the width is going to be 3 as well. So this is going to be 3 times 3, so this is 9. We don't need to update the max value. Again if we compare the heights, the right is actually smaller, so again we will update the value of the right counter. So now this time the right counter is reaching at this value number 1. So if we calculate this container, the area is actually going to be 2. So 2 times 1, so 2 times 1 is only 2, so we don't need to do anything. Again we will update the right counter. So currently the value of right counter is 4 and the left counter is 7. Okay, so we are going to have a container that looks like this. So 4 times 7, 4 times 1 is going to be 4 as well. So then we, in this case we don't need to update the max value, and if we try to update the left or right variable again, that they would cross each other. So because they would cross each other, now we can get out of our loop. So whatever the maximum result we have found so far, that is going to be the solution we need to return. So in this case the answer is actually going to be 24, as that this is the maximum units of water we can contain between basically this container, this water container, and that is the answer we need to return. If you see the beautiful thing about this solution, this whole solution gets completed in a single iteration between these two pointers. And if we see time complexity, in this case the time complexity is actually going to be big of n only, which is much better improvement compared to our brute force approach, which had the time complexity of big of n square, which was really bad. So we can avoid that. If we see space complexity, the space complexity is also really good, because apart from using couple of pointers, we are not using any additional space. So space complexity is actually constant space, which is wonderful. And this is a very good approach and a very good way to learn two pointer problem. And I hope you understood it. Now let's move on to the coding. First of all, we are going to initialize couple of variables. So first variable is going to be max, and that we are going to initialize it to 0. Then we are going to initialize two pointers, left and right, and left is going to have the value of 0 and right is going to have the value of whatever the length of heights array is. So we run our while loop, that while left is less than right. Now first of all we will have to calculate the width. So width is going to be right minus left. So now we have the width and we already have the height from this heights array. We will calculate the area. So this equation should give us the area. We are selecting the lesser height amongst right height and left height. And now we will see that whether we need to update the max value as well. And now we will have to update our left or right pointer. So we will check that, okay, if the current height of left is less than or equal to the right height, we will update the left counter. If that is not the case, we will update the right pointer to go one step on the left side. And in the end, we can simply return the max variable that we have calculated. And that should be it. Let's try to run this code. Okay, seems like our solution is working as expected, and our solution runs pretty efficiently compared to a lot of other solutions, and I would be posting this in the comments so you can check it out from there. Thank you. We are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do verifying an alien dictionary problem, and this problem has been really interesting problem, and it could be a prefix to a lot of other kind of problems that I would be posting in the future. If we see the number of companies that have asked this question, it's not too many companies, but the thing is the companies that do, they are one of my dream companies, so that's why I'm paying my utmost attention to it. We can see that Facebook, Uber, LinkedIn, Amazon, Apple, eBay, Bloomberg, ByteDance, they have all asked this question, so I'm not gonna skip it. So we are given an alien language and we are told that they are using all the English lowercase letters. Now we are given some words in that alien language, and we are also given the order of alphabets that those particular alien language follows, and we need to see that whether those words that we are originally given are they sorted lexicographically graphically or not. Lexicographically means essentially how we are going to store them in a dictionary. Suppose we are talking about the plain English that starts with A, B, C, D and ends at Z. So if we are given two words, something like bat and cat, so question is, are they lexicographically sorted? Yes. Why? Because B comes before C, so that's why if we want to put this in a dictionary, we would have stored bat before storing cat. So this is lexicographically sorted. Let's take another example. Suppose we are taking an example of bat, cat, dog, elephant. Are all of these words sorted lexicographically? Well, we just need to check that what is the order. So in order to check the order, first we only need to compare the first element. So B comes before C, so we are good over here. Now C comes before D, so we are also good over here, and D comes before this E, so we are also good over here. So we check all the words and we check that they are sorted in lexicographically. We can return true in this case as well. Well, suppose we are given another example. Suppose we are given bat and Batman. Well, in this case, if we check the first letters, they both are same. Even if we check the second letters, they both are same. The third letters, they both are same. But the thing is, now over here we find an empty list where there are no elements, and over here we still have some values, which means we can say that this word 1 is actually prefix of word 2, because this bat is actually common, and then we have some additional elements, which means that word 1 is actually prefix of word 2. And in this case, even if we want to put this in a dictionary, bat will be first one to be in the dictionary and Batman would come later down in the dictionary, because this is actually this is how language works, this is how dictionaries work. So in this case we will also return true. But thing is, if the reverse was given, if we were given something like Batman and we were given bat, we wouldn't have returned true in this case. Why? Because this particular element we check bat, this is good. But the thing is, over here we have M, and over here we would have an empty string. So that's why at this particular location the words are not sorted correctly. So this is one scenario where we would return false. What could be more scenarios where we need to return false? Well, of course, if the words are given something like suppose we are given the words like ESPN and DSPN. Well, in this case, if we analyze the first element, we can clearly see that D should come before E. But the thing is, in this the words are put in the reverse order, so over here we would return false. If we take another example, suppose we are given another two words like Batwoman and Batman. Well, in this scenario, first we will compare the first two letters. B is common, A is common, T is common, which means up until this point we cannot determine, like they seem to be in order, right? But the thing is, over here we find this W, and over here we find this M. Essentially in English language, W comes later than M. But the thing is, over here we had this W come in first before this M. which means in this case we cannot return true because we find a mismatching pair, so we can return false. Okay, so now we have exhausted all the possibilities where we can return false. We can return false if the words are same, like if one word is prefix of another word, but thing is the smaller word comes later in our sequence than the first word, we can return false in this scenario. If we find at any point that there exist mismatching pairs at the beginning, we can return false. Or at any point somewhere in the middle, if we find a mismatching pair between two words that are adjacent to each other, we can also return false. Now these are the scenarios where we need to return false. And if that is not the case, if all the words are sorted lexicographically, we can return true. And this was true for plain English. The thing is, even the same thing applies to the alien dictionary as well, that in the alien dictionary the order of words we are given, and we only need to see that whether the words that are given, do they follow this particular order or not. So if we take an example, over here we are given two words hello and LeetCode. So if we see, we only need to compare the H and L because those both words are not same, which means we can compare them. And over here we see their order. So H comes before L, which means that these two words, they are in correct lexicographically sorted order. If we take the second example, over here we are given the word word, and over here we are given the word world. Now W, W, they are both same. O, O, they are also both same. R, R, they are also both same. Now what is the first differing character? The first differing character over here we have is D, and the first differing character we have over here is L. Now we check in this particular sequence that where is D located. So D is located over here and L is actually located over here, which means L comes before D. But thing is, over here that is not the case. Over here we get D come before L. So that's why in this scenario, since the moment we find the first differing word, we immediately return false. We don't even have to worry about checking out this row word. So this is how this problem is to be understood. And let's see that what would be the approach to solve this problem. Okay, so suppose we are given an example like this, and these are the number of words that we are given that we need to compare. Now the first approach we can do is that in this particular order, the most important thing is to find the position of words, that where the words are stored. And the best thing we can do is we can create an additional data structure, something like a hash map. And in the hash map, as part of the key, we are going to store whatever the letter is. And in the value portion of the hash map, we are going to state that what is the position of that particular letter inside this given order list. Now what we are going to do is we are going to iterate over this order, and we are going to fill up this hash set first. Now first of all, so if we start filling it up, we will see something like this, that this W is at 0th position. This second element C is on first position. This the next element A is on second position, and B is on third position, and D is on fourth position, and so on and so forth. Now since we have this available to us, all we need to do is we need to iterate over all the words. What we are going to do is first we are going to check whatever the adjacent words are. In the adjacent words, first we are going to check that what is the first letter. Are the first letter same or different? If they are different, then we need to check their position from this hash set. So what we are going to do is over here, the first two letters we are given are W and C. So we check that this W, what is the position of W? The position of W is 0. And what is the position of C? The position of C is 1. So 0 should come before 1. That is okay. Which means that this will is actually in correct position by the reference of this Chris. So we can ignore this case. We can say that okay, will is at correct position because W is less than the value of C. But thing is, we cannot return true immediately because there are still words that we haven't checked. So again, we are going to check with Chris with this bat word. So first we'll check that okay, what is the first letter over here? So first letter over here is C. What is the first letter over here? The first letter is B. So they are not same, they are different, which means we need to check their position. So the position for C is at value number 1, and position for B is at value number 3. which means 1 is less than 3, so that is also good, which means now we can say that this Chris is in correct position. Now we will check this bat with this Batman. Okay, so first we will check for this B and B, so they both are same, which means we can't compare. Again we are going to check this A with this A, again they are same, we can't do anything. This T with this T, again they are same, we can't do anything. Now over here we have reached the end of our request, but over here we still have some words that we need to compare to. So we can define that this first word is actually a prefix of the second word. Since this is a prefix, which means that this is in correct position in terms of lexicographically sorted manner goes. So we can ignore this case as well. We can say that okay, this bat is also at correct position, and now we need to check this Batman with this Batwoman. So again we repeat the same process. We check the first element, so B is at correct position. Now again we check the second position, this A, they both are same, so there is no point in comparing them. Again we check this T, they both are also same, so there is no point in comparing them. Now comes the interesting part. Now we are at this position M. So over here the word is M, over here the word is W, which means that M and W, they are both the first differing word, the first letter amongst these two words, they are not the same. So which means we are going to check their position in this hash map again. So we know that this position of W is actually 0, and this position M, so I haven't mentioned it over here, but it falls somewhere over here, which means that this value would be somewhere at least over 10 to 15 letters, somewhere around that. But the thing is, we know the position of W is at 0, and this position is actually much greater than whatever the position of 0 is. So let's say it's 13, something like that. So we can declare that this M is not in correct place compared to this W, because this W is 0, which means that this Batwoman should have been in this place rather than this Batman. So because we have found this, we can clearly say that there is a mismatch between the adjacent words where the first differing letter is different. So in this case we can simply return false. And if suppose we were given an example like this, over here we would have compared this bat and they were same, so we wouldn't have done anything. And now we would be comparing this W with this M, so we would say that okay, W is at 0th position, M is at 13th position, so 0 is less than 13, so this is also good. And now we have reached the end of our loop. So because there are no other words to compare to, we can say that okay, now we have reached the end word, which means that over here we can return true. So if this was the sequence given, we would have returned true, but that was not the case, and so over here we would have to return false. This is the most basic approach that we can take, and this is the most optimal approach as well. If we calculate the time and space complexity, for time complexity, essentially first of all we are iterating over this entire order, so we are doing n work, and then we are iterating over all the words, which means again that is also we can consider as n work. So time complexity would be big O of n, where n is actually the number of words that are given. And if we calculate the space complexity, that would also be big O of n, because we will have to create an additional data structure where we are storing all the letters and their corresponding positions. And this is a very effective solution. Now the thing is, this was an easy problem, and of course we can clearly see that this was an easy problem. But the thing is, most of the companies, they don't ask this problem only, they ask this problem in tandem with another verify alien dictionary problem that requires graph theory knowledge. So I would be making video on that soon, so you can check it out from there, that how can you keep both the questions in tandem, because most of the top level IT companies, they are only going to ask you question first, and then they are going to ask some follow-up questions that would be more difficult than the original question. So first of all, we are going to create a new hash map, and we are going to name it order map. Now we need to iterate over the given input order, and we will be filling out the position for every single character in our order map hash map that we have just created. Okay, After this loop runs, our order map hash map would be filled, and now we will have to iterate over all the words, and inside every single word we will have to compare it with its adjacent word, character by character. So notice over here I'm choosing length -1 because if at any point we reach to the last word, we don't need to compare that. And since we are comparing two adjacent words, we don't want to go out of bounds, so that's why we will check one word less in our for loop. And now I'll create another for loop, and that is to iterate over every single character between two adjacent words. Okay, so first of all we are going to check that if at any point the current j we have, if that is greater than or equal to whatever word the adjacent word's length we have. If that is the case, which means that we have found a prefix where the next value is actually lesser than the previous value. So if we take an example, this would be the scenario if we are given Batman and the word bat. So in this case, eventually we would reach to this m, this particular m value, where the length of the current j would be greater than length of whatever the next value we are at, and if that is the scenario, we will return false. Okay, if that's not the case, we need to compare letter by letter. So first of all, we are going to see that whether the current word we are at if that is same as next word or not. Okay, if that is the case, and if both the words are not same, we will have to compare their positions. So first I'm going to create two parameters. So one is for current letter, and I'm going to fetch the value from the hash map we have created. And for the next word, we will also get the position. And now we simply need to compare that if the next letter, if that is less than the current letter, if that is the case, which means we have found a mismatch and we can return false immediately. And if that is not the case, which means that we have found a matching pair and we can break out of the current word. And after this loop ends, and if we are at the last word, and if we are able to successfully get out of the loop, we can simply return true. And let's try to run the code. Oh, we need to return false. I is less than order.length. Silly spelling mistake. Okay, seems like our solution is working. Let's try to submit the code. Okay, our solution works pretty efficiently, and I would be posting this code in the comments. You can check it out from there. The video we are going to do today is next permutation, and if we see some of the popular companies who have asked this question, there are companies like Facebook, Amazon, Google, Apple, Microsoft, Bloomberg, ByteDance, Uber, Goldman Sachs, DoorDash, TikTok, and Snapchat. So that's why I am paying my utmost attention to make this video. I hope you also find this entertaining. So this is a LeetCode medium problem and also a very well-liked problem on LeetCode. If we just want to understand the problem statement is only consist of one line, that we are given an integer array called nums and we need to find the next permutation for this nums array. Now the question comes which is very obvious, that what does this next permutation is being defined as? Well, one thing to find out is that you can actually try to read this whole definition and try to understand that what does it mean, or you can check out the example I'm trying to show you. Suppose we are given integer array that is like the value 1 2 3, right? So this currently there are 3 separate values. The thing is, let's try to consider and let's try to create like a lexicographical value out of these 3. So we can create a value that is like 123. Now if we want to create like a sorted ascending thing using these 3 elements, like obviously the next sorted element is going to be like 132. Why? Because okay, this value is 123. Using these 3 characters, what is the next value we can make that is in the ascending order? We can make value 132. Now if we want to make the next ascending value, the value we would be able to make is going to be 213. The next value is going to be 231. The next value is going to be 312. Value after that is going to be 321. And after that we won't be able to make any values. Now if you look closely amongst these values, all the values are sorted in ascending order. For every single value we are only picking the value that is going to be in its right place. So for 123 we are not going to put like 213 after 123 because this value is going to be smaller than this one. So that's why we are putting this 132 first. Same way this 231 is also at the correct place compared to this 213 and 312. So that is the main logic behind it. So suppose in the question, if we are given the value that is like 123, then in that case the next permutation has to be 132. But the thing is, we don't need to return 132 as the answer. We need to return answer as like 1 3 and 2. So I think this explanation makes a little bit of sense. Let's try to see some examples to try to understand that what does this problem is actually asking us to find. So in this case, okay, currently we are given the nums array with the values 1 5 and 6. So again, lexicographically, we will be able to make value 1, 5 and 6, right? So logically, what should be the next value in line? So next value has to be 165 because any value after that would be would definitely be greater than this one. So this is going to be the next permutation. Again, same way if we are given the value 651. Now this is a tricky case. Why? Because if we try to do like permutation of this 651, so originally the whole permutation is going to look like this. So this is going to be the whole permutation. So if the initial value is like 156, these are going to be the subsequent values. So this value 651 is representing this value 651 over here. Now if we see, there is actually no next permutation in this case. So if that is the case, basically we will have to return the smallest possible value, and the smallest possible value in this case is going to be 156. So basically we are going to return 156 as the answer in this case. Again, if we take another number, okay, so this is like 4 characters long. So in this 4 character long number, the next permutation is going to be. So I know this is a very complicated question to understand, but the thing is, once you get a grasp of how the permutations are being made, you can simply know that what is the answer going to be. So let's see that what are going to be different approaches to solve this problem. Okay, so the first approach we are going to try is going to be the brute force approach. Suppose this is the input we are given. So in the brute force approach, what we are going to do is, depending on the input, first of all, we will try to make the smallest value possible. So smallest value possible in this case is going to be values 1, 2, 3 and 4. Okay. Now after making the smallest value possible, we are going to try to explore every single values we can make inside the ascending sorted array. So the values we are going to get is, so just based on the few values, we were able to make like these permutations, and eventually we came to the value that exactly matches this value, and basically the next permutation after this is going to be the answer we need to return. So in this case we are going to return this as the answer 2143. The question is, okay, this approach gave us the correct answer, but the thing is this the right way to do it? And answer is definitely no. Why? Because even for a small example of 4 characters, we ended up exploring a lot of possibilities. Like if you try to calculate the time complexity in this case, the time complexity is going to be disastrous. It's going to be big O of n factorial. That is like the worst imaginable time complexity. So we have to find a way to do something better. So before we come up with the optimal solution, we are going to take these 4 cases. We are going to see that what is going to be the next permutation for every single one of them. And depending on the answer, I would be able to show you that what is the pattern that we have been able to establish. And using that pattern, we would be able to create our optimal solution. So first, let's start with this most initial case. In this case, all the values are actually ascending order, increasing order, which means that this is currently the smallest possible value we can make out of the values 1, 2, 3, 4, 5. Now the next permutation in this case is going to be where this 5 shifts on this left side and this 4 shifts on the right side. So basically the answer we are going to get is, this is going to be the next permutation for this value. Notice that currently we had value 45 and we flip it to 54. We kept these values the same way they were because they were not needed to be changed right now. If we take this example, this is the exact opposite of this one. Why? Because this is the maximum possible value we can make. In this case, if we want to see the next permutation, basically there is no next permutation, which means we will have to go back to the very first value. So this is going to be the answer. Using these two answers, we are not able to establish much of a pattern over here. But the thing is, now let's try to see some middle cases. So in this case, if we see, we are given value like 25431. So lexicographically, we have been able to make a value like 25,431. Now in this case, for the next permutation, we can either like try to see that, okay, what is going to be the value, but I'm showing you a different logic here. And the logic I'm trying to establish is that typically we always follow from the left hand side to the right hand side. Until the point we see continuous increasing elements. Again, I am talking about how to find next permutation, and for that we will have to observe the current case that we have been given. So over here so far 1, 3, 4, 5, they are all currently in increasing order, which means that they are at the correct locations. The thing is, the moment we reach to this value number 2 is actually smaller than 5, which means that the increasing order that we have been building up so far is no longer true. So because this increasing order is no longer true, we will have to do something with this value number 2. Now we need to put it in some place where we are going to put it. The logic I'm suggesting is that now we have this value number 2. We know that we will have to put it somewhere over here. Now where we are going to put it, we are trying to find the next permutation, which means the immediate next value that is greater than this value that we can make. So logically what we are going to do is, we are going to scan all of these values. We are going to see that, okay, what is the minimum value from this 2 that we have. So currently there is only one value that is less than 2, and that is this value number 1. Now for this value number 1, we are not going to do anything with this value number 1, but the thing is, the very next value that is before value number 1 has to be the most immediate greater value that is compared to this 2 amongst the remaining portion. Again, let me clean this up a bit and explain you again, because this is the most important topic. We check amongst these portions that, okay, what is the first minimum value we can find out that is less than this value number 2. So that is value number 1. What that means is, we already know that all of these values, they are ascending in increasing order, which means that the very next value has to be the value that is greater than 2 but less than all the other elements before that. Again, if you don't understand, just rewind it and see it again, what I'm trying to establish. So basically we found the value that is immediately greater than 2 but less than this remaining values. So what we are going to do is, we are going to swap these two values. If we swap these two values, the answer we are going to get is, and this is the answer we are going to get. The thing is, you must be saying that, hey, this is not the correct next permutation. I know this is not the correct next permutation, but what this is that we actually found the first element that needs to be on the right place in order to generate the next permutation, and for all the remaining values we simply need to reverse them in the other way around. So if we reverse them, we will get a value that is 3, 1, 2, 4, 5, and this is going to be the next permutation answer for this original input that we were given. So basically we can just ignore this case right now, and thing is, this is going to be the very next permutation. Now again, let's go back on the logic that how we were able to generate this value. Well, definitely we notice that all of these values 5, 4, 3 to 5, 4, 3 and 1, they have already been at the correct place, which means we have exhausted all the possibilities for these values where we can make some adjustments and create like a greater value, but that still remains smaller than the next value. That means we will have to do something with this element. So we will have to replace this element with some other element, and the only way to replace that is to find the value that is immediately greater than this 2. Because remember, apart from 2, if we try to add 4 over here, then that won't work. Why? Because there is still going to be a permutation that we missed, and that is the answer. Let's try to do the same logic over here again. So in this case, if we try to see, currently this 3, 4 and 5, they are increasing order, right? But we find this value number 2. Now 2 is immediately decreasing value compared to this remaining 3 values. Sorry, compared to its previous value, which means we will have to find some way to replace this 2 and make the changes amongst these values to generate the next permutation. How we are going to do it is that, okay, we will have to find a value that is greater than 2, but there is still exists some value less than it. The question is, all these values, they are all greater than 2. So we are trying to find the immediate greater of 2. So which means we will have to swap the values, and you guessed it correctly, between this 2 and 3. And that is exactly what we are going to do. So if we swap that, we are going to get an answer that looks like this. Now in this case, again, this is not the correct, but the thing is, these two portions, they became at the correct position, and for the remaining part we will have to just reverse that. So if we reverse that, the answer we will get is, it would be the immediate next permutation for this answer. So logic we are applying is that basically we scan through the any given number. So in this case, suppose this is the number we are given. What we are going to do is we are going to jump through all the values till we find a value where the current value is actually less than its previous value. So in this case, that value we can find is 4, which means we will have to replace 4. So these 3 places, they are already in the correct place. We don't have to do anything with them. Now for this 4, what we are going to do is we are going to see that what is the immediate greater value of the 4. So one way to do it is to find like the lesser value than 4. So lesser value than 4 is 2. So one value before that is going to be the immediate greater value compared to 4, that is 5. So we will get a value that looks like this. And after that, all the values, so currently now these 4 elements are in the correct place. All the other values we will have to do a reverse. This is the answer we need to return. In my personal opinion, this is a very hard question because without major hints, you won't be able to solve it in an actual interview if you haven't seen it. But the thing is, we are planning for a FAANG. So basically we will have to be vigilant, and we have to make sure that we are able to crack these kind of questions. Let's calculate the time and space complexity in this case. The time complexity is actually going to be big O of n, because we only have to iterate over the given array like couple of times. This is space complexity. Apart from using couple of variables, we won't have to use any extra space. So we can also complete this in like in place in constant space complexity. To implement the next permutation method, we are actually going to initialize couple of helper methods. So first helper method we are going to create is going to be a swap method, where if we are given any 2 elements and we are given the given input array, we would be able to basically swap their values. So depending on the index values, we would be able to make that adjustment. Now the second helper method we are going to create is going to be the reverse method. Now for this reverse method, we are going to again give the given array as the input, and we are also going to give the ith value as like the starting index from where we need to start doing the reverse operation. We are also going to create a jth value as sort of like an end value, and that is going to be the length of given array. Now all we have to do is just run a while loop, that while I is less than j, basically we are just going to call the swap method, and for the swap method we are going to provide the values of nums j and I, and after that we are going to increase the value of I, and we are going to decrease the value of j. And this basically concludes our 2 methods that we have been trying to create. Now let's go on the main method. So from the main method, first of all, we are going to we will have to run a loop from the reverse end to find the first value where the increasing order does not match. So we are going to initialize a variable called I, and we are going to assign it to the value of nums.length minus 2. Why we are doing it nums.length minus 2? Because we do not want to be in the out of bounds, because we will always be comparing 2 I values at the same time. Now let's initialize our while loop, that while I is greater than or equal to 0, and the number of current I plus 1 is actually less than or equal to the nums of I. So we are comparing two adjacent values each time. While this is true, first of all, we are going to decrease the value of I. So the moment this loop ends, basically we would be at the correct place where the ith value is actually not the correct value and needs to be swapped. So then we are going to check that, okay, if the given value of I, if that is greater than or equal to 0, if that is the case, which means we will have to do our swap operation, and we haven't found like the greatest value possible. So if that is the case, we are going to initialize a j variable and we are going to assign it to like nums.length minus 1 again. Okay, again we are going to run a while loop. That while we will have to find that whether the jth value, if that is less than or equal to I. If that is the case, we will keep on decreasing the value of j. So eventually we would be at a point where we are at the immediate value of j that is greater than I. This is the case, basically we are going to do like our swap operation, and we are going to swap the values of I and j. After swapping the operation, we will have to do the reverse operation for the remaining values. So we are going to do we are going to call the reverse method, and we are going to provide the value of the given array, and we are also going to do I plus 1, because from I plus 1 we will have to reverse all the characters. And basically that's it. This should be able to provide us the next permutation. Let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs pretty fast compared to a lot of other solutions, and that's why this is like a really good solution, but it's a really tough solution to achieve. I would be posting this in the comments so you can check it out from there. Thank you. For this one, the LeetCode problem number 26, if we see some of the popular companies who have asked this question, there are companies like Apple, Facebook, Amazon, Microsoft, Google, Bloomberg, LinkedIn, and Intel. They have all asked this question. So that is why this is a really important question. And let's just quickly go through that what is the problem statement, and then we would try to make the solution. Now in this case, if you want, you can again read this whole thing. I'm just going to explain it to you quickly. The problem we are given is that we are given a sorted array. That is cool. Always love when the array is sorted, makes things life so much easier. Now in this case, we are told that it could be possible that sorted array can have duplicated entries. So the moment we identify duplicated entries, we don't care about all the duplicated entries, but the thing we care about is that in the initial portion of the array, the all the distinct values has to be present. All the other values, we can mark them as anything like x or underscore or hash or whatever you want. We don't care about those values. So in this case, we are given an input array with 7 characters. But if we see the number of distinct characters we have, we only have 0 as a distinct character. Then we have 1, 2 and 3. So 0, 1, 2 and 3. These are the only distinct characters we have. Now for these 3 characters, we don't care anything. So we are not going to mark them. Basically, they were duplicate entries and we are not concerned. But in this case, we are concerned with the distinct characters. And the moment we find the distinct characters, we need to put them at the beginning and then return whatever the solution we have been able to find. So what is the brute force way to do this problem? Again, brute force way is pretty simple. We just take one value and we will try to see that, okay, how many duplicates there is one, and then we add that, then keep on repeating the same process, and then if this is a duplicated entry, again we move on to the next value. So this approach is guaranteed to give you the answer in big O of n square solution. So brute force is always not a good way to go. The next way to go is that we can actually try to do something smarter here. And what we are going to do is, obviously, this is a 2-pointer solution, so of course we are going to use 2 pointers. But since we are using here 2 pointers, we are also going to find a way to store the index value. So we are going to have an index value and we are going to initialize it with starting position 1. Now this first value is guaranteed to be a distinct value because we are told that there is at least one value in the array, and that value has to be part of the original distinct value. So we are going to directly put it over here, and that is why we put the index pointer at value number 1. Now index pointer is just a way for us to iterate over. And also these two pointers, what we are going to do is, initially they are both going to be located at the same place, but the end pointer is going to move few steps ahead till it finds a distinct value. That is what it is going to do. So in this case, currently, starting and ending pointer, so this value is same as this one, so we need to skip this part. So we are not going to care about this value, we are going to move to the next value. Now our starting and ending values both are located at this position. This is a distinct value. The moment we find a distinct value, since we find the first distinct value for this index position number 1, we are going to add it over here. So we add value over here. The moment we add the value to our array and we find like a new distinct value, we are going to do index plus plus. So now our index value is going to be 2, and the next distinct character we find, we are going to add it to position number 2, which we find immediately we find it, because this is a new one, because the end pointer went there and it didn't find any duplicate values. So again 2 comes over here and our index value gets updated to value number 3. Now we currently the scenario is that our starting and ending values both are at the same position. So currently the starting pointer is located over here, ending pointer is located over here. Now this ending pointer is going to go one step further. So currently ending pointer is at value number 2. Again, this value number 2 is the same as the previous value. Since it is the same value, starting pointer is going to remain here. Ending pointer was here. It didn't find anything. So now ending pointer will go to the next value. Next value is a distinct value. Again, distinct value, starting and ending pointer becomes at the same position. Index value becomes 4 and the value we added to our input. So we added value number 3 to our answer. Now again at position number 3, ending pointer go to the next. This is already 3. Now ending pointer tries to go to the next. Array ended, so we can't do anything about it, and this we can return it as the answer. We don't care about these values because that is none of our concern. But you see, even in this case, rather than coming on one side, starting and ending pointers were working in tandem to go from one step to the other step to find the answer. This was an easy problem, and in this case I intentionally chose this problem because we are at the same, apart from using two pointer solution, at the same time we are also using sliding window technique, because we are creating a window between starting and ending pointer, and the moment we find some solution, reasonable solution, we shift our window depending on the conditions. And this is a beautiful way to solve this problem, and that is why I decided to keep this solution at the last.
So let's see the coding solution for remove duplicates from sorted array problem. Basically, as mentioned, we are going to initialize a variable called insert index, and this is going to mark at value number 1 because we already have the first value stored inside our given input array, because that is unique for sure. Then we start our for loop from the first position, not from the 0th position, because we already took care of the first value. And then all we need to do is we need to keep on incrementing this value number I until we find the duplicate entries. And if the entries are not duplicate, which means we found the distinct value, then at that time we are going to add that position of nums of I to our insert index, and which is located initially it would be 1, and at the same time we would increase its value, and then we would keep on repeating this process till we reach to the end of the loop. And basically in the end we simply need to return the insert index value, and this is going to be the whole solution. This is going to give us that how many number of distinct elements are present inside the given array. And let's try to run this code. Okay, seems like our solution is working. Let's submit this code, and our code runs 100%, nearly 100% faster than all the other solution, which is pretty good. If you want, I'm going to post the solution of this code in the comments of this video. Also at the same time, you can check out my GitHub where I have solution for every single video I have done so far, and there are a lot of LeetCode problems, so this could be a good resource. I'm going to post this link in the description as well. Thank you.
Hello friends, I am a cloud solutions architect at Microsoft and I like making LeetCode videos. So today we are going to solve another very popular LeetCode video, which is find first and last position of elements in a sorted array. And if we see some of the popular companies where this question has been asked, there are companies like Facebook, Amazon, Microsoft, Bloomberg, Google, LinkedIn, Apple, Uber, Instacart, Twitter and TikTok. So that's why I'm paying my utmost attention making this video. I hope you also find it informative. So this is a LeetCode medium problem and also very well-liked problem on LeetCode. Basically, we are given an integer array that is sorted in non-decreasing or ascending order, and we are also given a target value. Now, in this sorted array, we need to find out that what is the starting and ending position for this particular target value. If the target value is not present, we need to return -1 as the answer. We are also told one more condition, that this has to be running in big O of log n time, which is like a logarithmic time. So definitely this is the big clue that we need to solve this using binary search tree. So over here, I have actually taken these two examples and enlarged them over here. So this is the input array we are given. We can clearly see that all the elements inside the input array are sorted in ascending order. We are also given the target value to be 8. Now in this case, we need to return the first and last position of 8 that is present inside this given input array. And we can clearly see that the first occurrence of 8 is here, where if we see the index value is 3, so that is going to be part of the answer, and the last position of value number 8 is at index number 4, that is also going to be part of the answer. And in this case, we need to return the first and last positions of this target value number 8 that is present inside this given array, which is going to be 3 and 4, and this is going to be the answer we need to return. Same way, if we are, suppose we are given the same input array and this time we are given the target value to be 6. Now 6 is not present inside this entire given array. So because 6 is not present, we are actually going to return -1 as the answer, and this is what we need to return in this case. So basically this is what the problem is asking us to do, and as the name suggests, that find first and last position of elements in a sorted array. So basically that is what we need to find. Now let's see that what are going to be the different approaches to solve this problem. The first approach that comes to our mind is a brute force approach. So in the brute force approach, suppose this is the input we are given and we are told that the target value we are trying to find, okay, let's not put 5, let's put 1. Okay, so suppose we have the target value 1 we need to find. Now in this case, we can clearly see that 1 starts at position number 1 and ends at position number 3, and in this case the answer is going to be 1 3. So because this is a brute force, we are going to apply the most simple logic, and most simple logic is we will start iterating from the beginning until the point where we reach the target value. So over here this is not the target value, so we skip to the next element. Now this is a target value that we are expecting. So because this is the target value, we are going to note its index position as the answer. So okay, this is the first value we find as the answer. Now we will keep on iterating to the next element until either we reach to the end of this array, because it could be possible that all the other values are the target value, or we reach to some value that is not 1. Definitely. So in this case, okay, we reach over here, this is also 1 and this is also 1. The moment we reach to this value, okay, this value is not 1. So because this value is not 1, which means that one value before that has to be the last occurrence of 1. So in this case, okay, index value for this is 4, so 4 minus 1 we will have to do 3. So in this case 3 is going to be the last occurrence of 1, and this is the answer we need to return. Like somehow we keep on iterating and we don't find the target value, so in that case we need to return -1 and the solution would also give us the correct answer. But the problem with this solution is going to be that if we see time complexity, the time complexity is actually going to be big O of n, and we are explicitly told that we need to solve this problem in logarithmic time in big O of log n. So that is not being satisfied in the brute force approach, so we'll have to find a better way. Now the question comes that how we are going to use binary search and how we are going to apply that here. We know using the binary search, it becomes pretty easy for us that we actually have a starting value, we actually have an ending value, we try to find a middle value. Now depending on the middle value, we either remove all the elements on the right side or we remove all the elements on the left side, and we update our starting and ending position, keep on repeating this process until we find the middle value. Now in this case, the logic is not quite simple as just finding the target value. Why? Because it could be possible that there are multiple target values, and what we are trying to find is to try to find the first occurrence and also try to find the last occurrence. If we just apply the simple binary search tree over here, things won't work. Why? Let me quickly show it to you. So suppose in this case, okay, starting position is 0, right? So starting position is 0, ending position is currently 5. So ending position is 5. We set up 2 pointers. Now we try to find the mid value. So mid value in this case is going to be 0 plus 5 divided by 2. So 5 divided by 2, if we take the floor value, we get the value as 2. So 2 is the middle value, which is this in this case, right? Now if you see, for this array, the target we were searching for is 1, and immediately we find the target to be 2, but that doesn't give us any meaningful value, because this middle value is already a target, but it is of no use of us because this is neither the starting value neither the ending value. So you must be thinking, okay, there is one simple logic we can apply over here, and that simple logic is that the moment we find the middle value, we start on traversing on one direction, and eventually we would be able to find a place where the value by itself is going to be like the first occurrence. So in this case, what happens? Okay, this is the middle value we found. Now we will start iterating on the left side. So on the left side, we will find, okay, again this value is 1, so still we don't know whether this is the first occurrence or not. So again we are going to take one step on the left hand side, and again this is value 0. So the moment we find a different value than 1, we can clearly determine that the previous value was the first occurrence. So in this case, okay, we can mark this answer as 1. So that is like the first occurrence, and same we are going to repeat the same process from this middle value to the right hand side to find the last occurrence. So if we search right hand side, okay, this is also 1, so we don't know that this is the last occurrence or not. But the next we check, okay, this value is not 1, so definitely this was the last occurrence. So last occurrence in this case is going to be 3, so we mark 3 as the answer as well, and we get the answer, bingo. So this solution would work, and you would argue that, hey, in average case this works in like big O of log n time, right? But the thing is, we are not concerned with the average case. Why? Because say for an example, you take a scenario where we are given an input array that looks like this, and all the values are actually the target value. So suppose target value we are trying to find is 7, and all the values are 7. So what would happen in this case? Like we would have this starting value, we would have this ending value, eventually we found a mid value. The mid value in this case is going to be 7. So now we keep on iterating on the left, again on the left, and we reach to the first position, and this is still 7. So we would identify that, hey, this 7 is actually the beginning point. Okay, so 0 has to be part of the answer. Again we keep on repeating on the right side and keep on doing the same process until we reach to the last element, which is still 7, which is still the target value. This is 5. Okay, so this is the answer we need to return. But if you see time complexity, in this case the time complexity would become big O of n. Why? Because we keep on iterating to the next element, and that is not what we want. We want a strict big O of log n time, logarithmic time. So what is the logic we are going to apply over here? So the logic we are going to apply is that definitely we are going to use the binary search, right? That's a given fact, but we will have to make some tweaks. Okay, now I'm going to show you a rough blueprint of the solution we are going to apply. So suppose this is the array we are given. Now what are the things we know? We know that this array is going to be sorted in ascending order, which means everything on the left hand side is guaranteed to be less than everything on the right hand side. I mean less than or equal to. We are also given some target element. So now we are going to first apply the binary search to find target element somewhere. So the logic we are going to use is that, okay, depending on the starting and ending value, we would be able to find some middle value. Now we will try to see that whether this middle value, if that is less than this target value, if that is the case, which means that the target lies somewhere over here. If that is not the case, and if we find, okay, that whether this middle value is actually greater than target value, if that is the case, then the target lies somewhere over here. If both are not cases, which means that the middle value by itself is equal to the target value. So that is great. But the thing is, our job doesn't end over here. We are actually trying to find the first occurrence of this target value and the last occurrence of this target value. So first we are going to be focusing on the finding the first occurrence of the target target value. How we are going to do is that, okay, that if suppose for example this middle value, if that is equal to the target value, right? But the thing is we are not sure whether it's the first occurrence or not. We can only define that this is the first occurrence if the value before this is not the target value, or this somehow we keep on doing like binary search, and we find that, okay, the middle value that we were searching for was by itself the first value inside the array, and that was the target value. Either of these two conditions are true, then only we can say that that is the first occurrence. So what we are going to do is, okay, suppose say for simplicity we find, okay, this first value to be target value. Okay, so now we will try to see one value before that. We again find and now we are, because we find this middle value to be target value and we are trying to find the first occurrence, we are guaranteed one thing, that the first occurrence has to be in between these values and not over here. So we can simply ignore these cases and we can update our end value to come over here and then repeat the same process. So now what we are going to do is we are going to bring our end value over here, again try to find the minimum value, the medium value, and depending on the value of the medium value we will be able to find that what is like the first occurrence. Same logic applying, we would be able to find the last value, and for the last value logic we are going to use is that if the middle value is equal to target value, then if that is at the position where the next value of that, if that is not the target value, then we can say that this was the last occurrence of the target value and we put it in the answer, or we somehow find the target value to be the last element by itself. In either of these two cases this goes in the answer as the last occurrence. So let's try to understand this with an example, and then it would make more things more clear. So again we are continuing with the same example we are given. Now let's mark starting and ending value. Currently the starting value is equal to 0, the ending value in this case is 5. So if we try to find the middle value, the middle value is going to be 5 divided by 2. We are going to take the floor value, so which is going to be 2. So this is currently the middle pointer we have. Now if we compare the middle point, lucky in this case middle point by itself is the target value. So now because this is the target value, we are trying to find the first occurrence. So because we are trying to find the first occurrence, we will try to see one value before this target value. So one value before this target value is also 1, which means that amongst these places there exists the first occurrence of this target value 1. So because of that, now we are going to update our end pointer. So now our end pointer position becomes midpoint whatever we find -1. So now this becomes the new end pointer. Okay, so currently the end pointer position is 1. So if we do like 0 plus 1 divided by 2, we got 0.5. So basically mid pointer is going to be 0 because we are taking the floor value. So now this is the mid pointer. If we compare this mid pointer with the target value, this mid pointer is actually less than target value. So because this is less than target value, we will have to update our start pointer. So now start pointer, we are actually going to update one position to the right, and we are going to keep on repeating the loop until the point where we find like either the start value crosses end or either end value crosses start. So currently both are at the same position, that is acceptable. So currently the starting pointer is also 1, ending pointer is also 1. In this case middle pointer is going to be 1 definitely, and because this is going to be 1, okay, this value is actually the target value. Now we compare this with its previous value. The previous value is not target value. So because this previous value is not target value, we can say one thing for sure, and that is that this is the first occurrence of this target value. So first occurrence of the target value, we are going to mark the index number. So index in this case is going to be 1, and that we are going to store. Okay, now we are done half the work. Now we are trying to find the last occurrence. Now for the last occurrence, again we are going to repeat the same logic and we are going to do everything from the beginning. So let me clean this up a bit. Now we are trying to find the last occurrence. Now for the last occurrence, okay, we find the middle value. Middle value is equal to target value. We compare the next element to the middle value. This is also target value, which means that the last occurrence exists somewhere over here. So which means we will have to update our starting pointer. So when we update our starting pointer, we get the new values as, and also we can ignore all of these cases. So now, okay, this is our values. So in this case, if we try to find, okay, we find the middle value to be 3 is actually greater than our target value. So because of that, we will again have to shift our end pointer on the left hand side. So if we shift our end pointer on the left hand side, our end pointer is going to end up over here. So currently starting and ending value both are located at position number 3. So obviously middle value is also going to be located at position number 3. So now this is the middle pointer. Okay, this is exactly the target value. So that solves one part of the problem. And now we will try to compare its very next element, and that value is not the target value, which means that this is the last occurrence of 1. So the value is 3, so 3 we are going to mark as the answer. So now we find, okay, f is equal to 1 and l is equal to 3. So we find both the values, and that is what we need to return as the answer. And this is the whole logic we are going to apply over here. If you see the time and space complexity, in this case the time complexity is actually going to be big O of log n, and it's pretty self-explanatory that in every single equation we are eliminating half of the values on one side to find the correct occurrence position. So this is a very good example of using binary search to solve the problem in a little bit different manner. Like the thing is, definitely underlying concept is a binary search, and everyone knows that, but still this is doing things a little bit differently. And I would be jumping to the code now. Okay, so before we actually start implementing the search range method, first we'll have to define that we actually need to find like the first and last position of any given element, right? So we are actually going to create a helper method for that. And for this particular helper method, I have named it as find bound. And this helper method is actually going to return the integer value of whatever the bound we need to find. Like now the thing is, over here we need to find the first and last positions. So rather than having two separate methods, we are only going to have one method where as an input we are taking the nums array, we are also taking in the target, and we are also taking in a boolean character that is first. So this character would define that whether we are trying to search like the first occurrence of any particular target element or the last occurrence. So that's settled now. Now we are going to create some helper variables. So first we are going to create two pointers, start and end, and we are going to assign their values as 0. And we are also going to create a while loop, that while start is actually less than or equal to end. Now inside the loop, first of all, we are going to calculate the mid pointer. Now with this method, there could be two possibilities. It could be possible that we are trying to find like the first occurrence. So which means in that case, the value for this is first would be true. So first we will calculate for that scenario, and then we will make the calculations for the second scenario. So what could be the condition that we actually find the correct value? And the condition is that if the mid value, if that is equal to the starting value, so if that is the case, or we found out that the nums of mid minus 1 is not equal to target, if that is the case, we can also define this to be true and simply return the mid pointer as the first occurrence of the value. If that is not the case, basically we will have to shift our search. So every single time we are going to update our end pointer to go one position left of mid, so mid minus 1. Now that takes care of the scenario where we are trying to find the first element, right? Now for the last element, we will also have to do some calculations. So in order to find the last value, basically the condition is that if either the middle value is equal to the end character or end pointer, or the nums of mid plus 1 is not equal to target. Either of these conditions are true, we can simply return the mid. If that is not the case, this else condition is trying to find for the last case. So in that scenario, we are actually going to update the value of our start pointer. Now we have taken care of most of the things. Now we need to also make changes depending on the position of mid value. So if that is not equal to target, so if that is the case, basically we are again going to make some changes. So first we are going to have the condition that else if the nums of mid, if that is greater than target, which means that we need to update the end pointer. If that is not the case, we are simply going to update the start pointer. And somehow we get out of the loop and we don't have the answer yet, we can simply return -1. Now from our main method, we are actually going to call the helper method that we have created, and we need to find like the first and last bound. So first we are going to create the first element, and we are, for that we are going to call this find bound method. We are also going to keep a condition that if say for example we get the answer as -1, we can simply return -1 as the answer. And if somehow we do not get -1 in the return, which means that first element exists, so last element also has to exist. So we are also going to create another parameter called last to find the last occurrence. And again, we are going to call the same method, but this time we are going to keep this parameter as false. And that way it would be able to calculate the last value. And simply we need to return the new array and add these two entries of the first and last. I think that should have taken care of all the scenarios. Let's try to run this code. So over here, I actually forgot to enter one critical condition, that if the given mid value, if that is equal to the target value. So if nums of mid that is target, then only we need to proceed over here. Okay, now it makes sense. Let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And seems like our solution is working as expected. Our runtime is actually beats 100% because it's the runtime is 0 millisecond. And even in terms of space complexity, our calculation is pretty efficient. Hello friends, we are still not employed by FAANG company, so let's not stop lead coding till we get there. We are going to do trapping rainwater problem today. And if you want to see that what are the list of companies that have asked this question, that comes later in the video, so you can directly check it from there. Let's understand the problem statement. We are given an array called n, where all the integers are non-negative, and any single integer represents actually the height at that particular position inside the array. We are given that the width at any two positions is actually 1, so we can consider that. And we need to see that how much water can we trap when it rains. We know that it's going to rain a decent amount, so we all the cells that could trap water would trap water. And our aim is to see that what is the maximum unit of water we are going to store. So let's try to understand this with an example. Over here we are given an elevation graph, and all of those values are represented as bars inside the given graph. And we notice that because there are some height differences, due to the height difference there exists an empty space inside this given input. And because that empty space exists, rainwater can actually fall in and be stored on those particular positions. So if we see over here, like this first position is actually 0, but and suppose the rain falls, can any water be stored over here? Well, it cannot be stored, because in order for water to be stored, we need a vessel like this or like this or something like this, where at least water can be stored. Like over here, if we see, water can be stored for all of these positions, because all these three edges were covered with some sort of solid material. Same goes over here. Like over here, we can only fill water up until this point, because on the left side the edge is only up until this point, not more than that. Like though on the right side the edge is actually higher, but if we try to fill in more water, or if rain falls and more water falls on top of it, all the water is gonna spill out, and no amount of water is gonna be stored. So that is one key important part, is to understand that how water is stored. And second is that we need to iterate over this given input height, and at every single position we are going to basically calculate that how much water can be stored due to this height difference. So if we see in this example, at this first position no water can be stored. So like there is no water pointed with over here. Like this is a bar by itself, and in this particular bar, this is the boundary, that is a solid surface that cannot store any water, and we cannot store any water on top of this one, because all the water that gets stored on top of this one will also spill out, because on the left side the boundary is actually non-existent. Now if we look at this third position over here, actually because of there exists a height difference between these two positions, we have a scenario something that looks like this, where water, when the rain falls, on the left side we have a bar of height 1, which is represented over here, and on the right side we have a bar of height 2, which means that we are creating some sort of value over here, where on the left, at this particular position on the left side, the bar is actually of one size, so this is of one size, and this is bar of two size, so this is actually two size, which means that exists an empty vacuum where water can fall in and water can be stored. So this becomes our point, and we can check that over here we can store 1 unit of water. Now the question comes that why can we only store 1 unit of water? Why cannot we store more than 1 unit of water? The formula is actually quite simple. Like at this particular position, we see that on the left side there exists some height, on the right side there exists some height. So suppose this one is left height, this one is right height. There are two heights that exist at any moment, and this by itself can have some height, as mentioned in this input, that there can be some height that can be located at this position. And suppose this position is actually the height we are currently at, so we just name it as height. Okay, now how can we determine that in this scenario? In this scenario, if we see does all these values, so left height is actually 1, okay, right height is actually 2, and the height we are currently at, which is this position, is actually 0. And over here we were able to store only 1 unit of water. So why we were only able to store 1 unit of water? Basically we were following this condition that first of all we need to check that what are the bar height difference between on the at any given position on the left hand side and at the right hand side, and we need to take the minimum out of both of them, because over here, though on this right hand side the bar is actually of height 2 units, because on the left hand side the bar is only of at a height 1 unit, we cannot store water more than this height because the water is gonna spill out. Now that is one condition. Now second condition is, in this case we got lucky that over here there is no height at all, so that's why we were able to store 1 unit of water over here. So basically we can say that at any given moment the amount of water we can store in 1 unit is actually following this formula, that the minimum of whatever the right height is, whatever the left height is, so whatever the lower value of both of these minus the height we are currently at. And if this is greater than 0, then only we can say that we can store some water at any given position. Like let's say for an example that why at this first position we were not able to fill out any water. And if we see both the values, so on the left at this particular position, I'm referring that on the left side the left height we had was actually 0, the height at current position was also 0, and the right height was actually 1. So if we apply this formula, we can clearly see that on the amount of water we can try to fill in this space is actually going to be minimum of these two. So minimum of left height and right height is actually 0 minus the height we are currently at. So current height is also 0, which means that we cannot store any water, or we can store 0 units of water at this particular position, or at this first position, because there exists height difference. And same formula can be applied for all these places to calculate that what is the amount of water we can store. Like if we see over here, the bar height is actually 2. Now for this particular position, if we want to check that what is the amount of water can be stored, we know that over here we can store 1 unit of water. And why we are storing 1 unit of water is because if we see the left height over here, that is 2. Now on the right side, the right height, there is no right height over here. There is no right height over here which is greater than this one. Like this, there is some right height over here, but that is less than this height. So there is no point in us to treat it as valley up until this point. But over here we know that the height is actually greater than whatever height we currently had over here. So this right height is actually 3. So we are going to check, so we are going to apply the same formula. So we are going to check the minimum out of 1 and 3, one minimum out of 2 and 3. So this is left height, this is right height, and we are going to minus whatever the height we are currently at. So current height is actually 1. And if we apply this formula, we get 2 minus 1, so we get 1, which means that over here we can store 1 unit of water. Now let's try to understand this one with another example, and I'm spending a lot of time in this one because this is the actual crux of the entire example. So over here, if we want to calculate that how much amount of water we can store, we are again going to repeat the same process. So what is the left maximum height we can find for this particular unit? Like the left maximum height we can find is actually 2 units. So we can say the left height is 2, the right height is this one, so right height is 3, and minus whatever the height currently we have at this position. So this position we don't have any height, so which is 0. So if we apply the same formula, we can get 2 minus 0. So we can say that over here we can actually store 2 units of water, and which is what is presented over here. Like that's how we can store 1 unit of water over here, and that's how we can store 1 unit of water over here. So at any given position for any particular element, we are only going to need 2 things, because height we are already given. So we remember that in this equation we are actually comparing 3 items: the right maximum height, left maximum height, and height we are currently at. So height we already know, and our aim is to find that how can we find this right maximum height at any given element, left maximum height at any given element, and then it would be piece of cake to for us to identify that how much water can be stored at any particular position. So we can have a brute force approach where at every single position we iterate over the entire left array and entire right array, and we find that what is the maximum left height we can find at any given position. We can also find what is the maximum right height we can find at any given position, and we already know that what is the height we are currently at. And once we have both of this information, we would calculate our result, and we would try to calculate our output. The thing is, this scenario is pretty darn bad, like at any single position. So even over here we will have to iterate over the entire left array and entire right array in order for us to calculate these two values. And yeah, this is brute force. So brute force is tend to be dumb, like we are not doing anything clever over here. So that's why we would end up with the time complexity of big O of n square, because at any single position we are going to iterate over the entire array to find these two values, left height and right height. Now can we do something better over here, and how can we find a better approach? So for the given input example, we can actually do something clever. What we can do is, whatever the input we are given, we can actually iterate over it from the left side, and at every single position we can see that for any single element, what is the leftmost value or left max value we can store. Again, we are going to iterate over the given input example on the reverse order, and then we can find that at any single position what is the right max value we can find. And then it becomes pretty simple for us. We can just simply apply this formula on the entire input that were at any single position. So at any single position we only need to find the minimum value of right max and left max minus whatever the height we are currently at, and if this becomes greater than 0, then we will add it to our whatever the output we have, and this would be our answer. So let's iterate over first on the left max side on this given input. So on the first element, the maximum left height can be 0. Over here it can be 1. Again over here it can be 1. Now over here this value is 2. So left max height at this position would actually be 2. This would actually be 1, but thing is we already find a greater value, so again we are going to keep it as 2. Again we are over here this one is 0, so again the left max height we can find is 2. Over here this one is 1, so again this would be 2. Now this is 3, which means that left max height we can find is actually 3. This is 2, so left max height we can find is actually 3. Again 3, again 3, and again 3. So this is how we can fill out this left max table. Same way we are going to fill out the right max table, but we are going to do it in the reverse order. So over here the right max edge is actually 1. and we are going to repeat the same process. Now we have both of these tables filled out, it becomes pretty easy for us to find the solution, and we can actually do it everything. Now this approach would work perfectly fine. The thing is, what is the issue with this approach? Like if we calculate the time and space complexity, the time complexity for this one is actually big O of n, because we are doing everything in just a single loop, and we are running this loop 3 times. Like first we are running this loop, so we are doing n work, again we are running this loop, so we are doing n work again, and then we are running the n work to find the output. But thing is, still time complexity is going to be big O of n, and the space complexity for this one is actually going to be big O of n as well, because we are storing these two additional data structures. So this is much better improvement than our brute force approach, where in the brute force we are doing everything in big O of n square time. So we are gaining significant improvements over here. Now this question has been really popular with a lot of different companies, and if we just look at the number of companies that have asked this question, and if we just see the amount of frequency that they have been asking this question, I wouldn't be daring to skip this problem. Like even if you see up until 2 years, almost all the companies that are like one of the biggest companies in the world, they are continuously asking this problem. Just look at the numbers, like Amazon, Facebook, Goldman Sachs, Bloomberg, Microsoft, Google, Adobe, Uber, Apple, Tesla, Lyft, Expedia, Morgan Stanley, Swiggy, ByteDance, Databricks, Walmart, Flipkart, ServiceNow. These are the companies that pay you in gold bricks. And getting job or getting employed at any of these companies at least for 2 3 4 years is going to change your financial situation drastically. Like it's going to be 180-degree turn, and you only need to clear the technical interviews just once. Like after that you are sitting on top of gold. So if you are also dreaming to changing your life completely, like make sure to focus your utmost attention to this problem, and try to solve it as many times as possible, because it has been asked in so many companies. So that tells you something. Okay, now for the optimal solution, we can actually observe something pretty interesting in this given left max and right max that we have calculated. If we notice in the given input, this is the biggest bar of height that is possible, and we know that at any moment, at any location, if we want to find the height, the equation is this one, that the minimum of whatever the left max and right max we have minus whatever the height at current position we have. This is the equation to find that how much amount of water we can trap at any given unit or any given elevation. Now the thing is, if we notice in these two values, left max and right max, we are actually finding something pretty interesting. And the interesting thing we are finding is that the tallest part that we have, it actually divides the given input in two parts. And it divides how? That if we observe the left max portion, the left max portion is always less than whatever the right max portion is up until this point, number 7. Because notice all of these values, in all of these values the value of left max is actually less than whatever the value of right max is, and over here it's equal to right max because of this particular tallest bar that divides two arrays. And all on the right side, actually the R max is less than left max, and we can see those things over here, that over here these are all the values that are smaller than whatever the left max there is, because for these four values actually this particular, the tallest bar actually becomes the left max element. And using this we can actually use it to our advantage, because remember, at any moment if we want to find that what is the amount of rainwater we can find, we only need to find the minimum value of amongst this left max and right max, which means that this tallest bar can actually be used in our help, and we don't even need to calculate this whole left max and right max array by itself. We can actually use a very beautiful concept that is present inside the given array traversal problems, and that is two-pointer solution over here. In the two-pointer function, we are going to have two variables, left and right, initially located at first and last position, and at every single time we are going to check that whatever current element we have, so whatever height at element left or pointer left and whatever the height at pointer r, we are going to compare these two. So suppose the height at left pointer is actually less than right pointer. What we are going to do is first we'll check that whether the current left pointer we are at, does it contains the left max height, and we are going to initialize the left max variable to 0 at the beginning, and at any point we are going to check that whether we need to update the value of left max. So for left max we are going to check two things. We are only going to check one thing. We are going to check that whether the left max should be the maximum value out of whatever the left max we have stored and whatever the height of left we are at. So this will always make sure that we have the most updated left max value. Once that is done, we only need to use one equation in this scenario, and that equation is left max minus whatever the height we are currently at of pointer L. If this is greater than 0, we can actually add it to our total. So we can just say that total is whatever value we already had for total, plus we can add this whole function to it. And once that is done, we will need to update our left pointer. So on the left side we will move towards the right pointer and we will do left plus plus. And again, suppose at any point we find out a scenario where the height at right is actually, so height at right is actually less than height at left. If that is the case, we are going to repeat the same process. Let me use a different color, but this time we, rather than doing it for left max, we are actually going to do for the right max. So again, we are going to check for right max that what is the maximum amount we can find. So we are going to take maximum of whatever the right max we already have and whatever the current right height we are at. And once that is done, again we are going to use the same equation, but rather than using left max, we are going to use right max minus whatever the height we are currently at for this r pointer, and if this is greater than 0, we are simply going to add that value to our total variable, whatever we calculate for this one. And once that is done, our right variable is actually going to move towards left side, and we are able to achieve this because there exists some bar that actually divides the array in two portions. Because over here up until this bar, always left max is going to be minimum value, and over here always right max is going to be minimum value. And at any single position, whenever we are at any left and right, we always check their heights, which means that suppose we reach this right before, still in the left side we will have to calculate all of these values before we get here. And once we get to a point where left is actually greater than or equal to right, then we can simply break out of the loop, and whatever value we have stored in the total, we can simply return that. This is a very beautiful approach, and notice that we don't even have to use the full equation over here. We are only comparing any one variable at any point in time, a left max and right max, and every single time we are keeping track of whatever the left maximum or right maximum value that we have been able to find. So if we use this approach, if we use two pointer approach, and if we calculate the time and space complexity, basically the time complexity for this one is actually going to be big O of n. So that is same as it is, because in any case we are going to traverse over the entire input array, but the thing is we are only doing it once, we are not doing it more than that. And if we see the space complexity, actually we are only storing couple of additional parameters like right max, left max, and we are storing two pointers, left pointer and right pointer. So we are not doing any additional data structure, or we are not storing anything else, which means that our space complexity is actually going to be big O of one constant time. So this is really amazing solution compared to all the other approaches. This is the most optimal approach. So first of all, we are going to initialize our two variable left and right. Left is going to be 0, right is going to be a height length minus 1. We are also going to initialize a variable total, that is going to be total amount of water that can be stored, and we are going to initialize it to 0. we are also going to have two variables, left max and right max. And left max would be the first element in whatever the height we are given, so height of 0, and right max is going to be the height of last element, so we can say height of right pointer. And now we are going to run our loop. So while left is less than right, first we are going to check for the height difference, and whichever side has the lower height we are going to work on that side. If left pointer has lesser height, we are going to work on the left side. So we are first of all going to see that do we need to update the left max. We are going to check that whether we are at any valley where we can store some value. So we are going to check that if left max minus whatever the height we are currently at on the left pointer, if that is greater than 0, then we know that we are at a valley and we can store some water over here. So we will update the total amount of rainwater that can be harvested to total plus whatever the height difference we have found over here, which means that left max minus whatever the height we have found over here. And once that is done, we need to update our left pointer to move towards the right side. And if that is not the case, which means that we need to repeat the same process but now on the right side. So first we will try to see if we need to update the value of right max. If we don't need, and now again we are going to check that are we at the valley on the right side where we can store some rainwater. If this is greater than 0, then we can update the total rainwater. And once that is done, we will need to update the right pointer to move towards left direction. Okay, I think that is it. Once this while loop ends, the total variable should have all the entire result, and we can simply return that, and this should give the total amount of rainwater we can harvest. Let's try to run this code. Okay, seems we made some small mistakes. Seems like our solution is working. Let's try to submit the code. And you can see that our solution works pretty fast compared to a lot of other solutions. That is because we are using the most optimal approach. I'm also going to post this solution in the comments. Also, I have created the solution where we need to use two separate arrays to store the left max variable and right max variable at any single position. And you can check it out, that solution as well, from the comments. So today we are going to do median of two sorted arrays LeetCode problem. And if you see some of the popular companies who have asked this question, there are companies like Amazon, Apple, Goldman Sachs, Microsoft, Google, Bloomberg, Uber, Facebook, LinkedIn, and ByteDance. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So despite being a hard problem, this is a very well-liked problem on LeetCode. Basically, we are given two sorted arrays, nums1 and nums2, and we are told that they could be of different size. So the size can be respectively m and n, that is given over here. Now we need to return the median of these two sorted arrays. We are also told that the overall runtime complexity should be big O of log of m plus n. The solution I'm going to show you today is actually going to do even better than this big O of log of m plus n. I'm actually going to solve this problem in big O of log of minimum value of either m or n. So before we understand this problem any further, first let's see that what does a median mean. So a median is basically any single position inside any given array where everything on the left hand side and everything on the right hand side is actually of same length. So whatever the amount of element it has on the left side, the same amount of elements it has on the right side. Now there could be two cases. There could be like odd numbers or there could be even numbers, and for each one of them I'm going to show you how to calculate the median. So suppose if we take this first example, in this first example we can clearly see that we are given three elements, and based on the definition of a median, everything on the left and everything on the right has to be same. So if we consider this element number 5, 5 is the position where the left of 5 is there is one element and the right of 5 is also there is one element. So in this case 5 is going to be the median for this given array. Now if we take a look at this one, in this example things are a little bit tricky because this is an even number. So in the even case we actually have two elements in the middle who form the middle portion such that their left portion and right portion becomes of equal size. So in this case, for this particular middle portion, the left value has one element and the right value also has one element. So both of these are part of the median. But the thing is, in the median there cannot be two values. So if such case arises, which is for even numbers, we are actually going to do the average of them. So in this case we are going to do 3 plus 4 divided by 2, which is 7 divided by 2. So we get the answer as 3.5, which is the median for this particular array. If we take this example, again this is simple. This value number 5, again this falls in the middle, so because of that we are going to note 5 as the answer, because there are two elements on the right and two elements on the left. Now again for this case we have the value this 4 and 6 that creates the middle point such that the left values and right values becomes of the same length. So in this case the median is going to be 4 plus 6 divided by 2. So again we get 10 divided by 2. So the answer is 5. And this is the median for this kind of case. Now after understanding what a median is, first let's see these two examples so it makes things more easy. So in the first example, we are given two arrays nums1 and nums2. We can clearly see that they both are sorted array. Like this one only has one element, but still it's sorted, right? And now we need to find the median of these two arrays. So if we find the median of these two arrays, if we combine these two arrays, we will get an array that looks like this, that is sorted, right? Because we need to find the median of two sorted arrays. So this is the combined array. In this case, 2 is going to be the median because that is the middle point where there is one element on the right and one element on the left. Same way for this one, if we try to see, the length of this is actually 2 plus 2, so the total length is 4. Now if we make a combined array, the combined array looks like this, and in this case if we want to find the median of this one, we will actually have to do an average of these two middle portions. So we'll do like 2 plus 3 divided by 2, so we get the answer as 2.5, and this is what we need to return as the answer. So let's see that what are going to be the different approaches to find the median of two sorted arrays. The first solution that comes to our mind is a brute force solution. In the brute force solution, the idea is actually simple. If we just combine these two arrays and create like a combined sorted array, we get an array that looks like this. Now, once we have this combined array, all we have to do is just find the median. So in this case, the median is going to be this value number 5, because on the left hand of the 5, there are going to be exactly 5 elements, and on the right hand of the 5, there are also going to be exactly 5 elements. And this 5 is the answer we need to return. So this solution would give us the correct answer, this brute force solution. But the issue with this solution is that in order to create this combined sorted array, we will actually have to complete this solution in big O of m plus n time. So that is a linear solution, and the thing is that is not what we want. We actually want a logarithmic solution. So let's see that what is going to be the approach for the logarithmic solution. Okay, so before we come up with the optimal solution, first let's try to understand some really important concept. Suppose we are given two arrays that are x and y. We are told that they both are sorted in ascending orders. Now we know that their length is actually respectively 5 and 6 in this case. So the total number of elements we have is actually 11 if we do like 5 plus 6. Okay, so now here we are trying to find the median of two sorted arrays. And the thing is, the median how we are going to find is that, okay, currently we are given these 11 values. So these 11 values, they are combined of these two. Now this 11, we can actually create two partitions. How we are going to create two partitions? So the logic we are going to use is that every single time, whatever the combined sum is, we are actually going to do like plus 1 divided by 2. So in this case, the value we will get is 11 plus 1. So that is 12 divided by 2. So 12 divided by 2, the value we are going to get is 6. So now first partition we will have to do is of 6 elements. And second partition we will have to do is remaining elements. So remaining elements in this case is 11 minus 6. So that this is going to be 5 elements, right? And whichever is going to be the maximum element of this 6. So maximum element of these 6 is going to place somewhere over here in the middle, and that is going to be our median. Now the thing is, how can we define that this maximum value is going to be the median? What are the properties we are going to take for this 6 and 5 value per partition that we are trying to create? And the answer lies right in front of our eyes, that the sorted property has to be maintained. So what does the sorted property has to be maintained means? It means that all of these 6 values that we are trying to create on the partition, they all has to be less than or equal to the values of the 5 on the right hand side. Okay, so that is a very important property for us to understand. I am telling this again, that all those 6 values that we have on the left hand side, they have to be less than or equal to all the values on the right hand side. Why? Because we are trying to find the median of two sorted arrays. If they are not sorted, then it's like a big mess for us, right? So because this is the sorted property is maintained, now what we are going to do is, we don't care about finding these 5 values. All we are going to put our focus is to finding these 6 values. Now these 6 values, they can exist anywhere inside this x and y. It could be possible that we take like 3 values from x and then we take 3 values from y, and that is how we create the 6 values. It could also be possible that we take like 2 values from x and 4 values from y, and that is also how we create these 6 values. No matter whatever the logic we are going to use, we will always have to be certain that all the elements on the left hand side, they have to be less than or equal to all the elements that are on the right hand side. And using this property, we are going to come up with some very interesting results. So the idea we are going to use is that, first of all, we are going to take whatever the lesser value we have in terms of length among both arrays. So currently in this case, the lesser value of length we have is of array x. So currently for this x, the length we have is 5, right? So what we are going to do is, we are actually going to do 5 plus 2. So 5 plus 2, we get value of 2.5. If we take the ceiling value, we get the value to be 2, which means that now we are going to take 2 values from this x. So if we take 2 values from this x, we will get the values x0 and x1, that is on the left side of the portion. Now if we take 2 values from the x, which means total we are trying to find like 6 values, because remember, we are trying to find like the 2 partitions. One partition is 6, second partition is 5, and all the 6 values has to be less than or equal to these 5 values. So because we are trying to find the partition of 6 values, which means we took 2 values from the x, so we are going to take 4 values from y. Now if we create a partition like this, what is going to happen? Well, all the remaining elements, they are going to be on the right side of the partition. So currently the remaining elements we have. So now we have our 2 partitions, right? Now for these partitions, again, we will have to make sure that this property is maintained. So how can we check that? Okay, over here we are 100% certain that this x1 is always going to be less than or equal to whatever the value of this x2 is. Why? Because we are told that this x array is already sorted. Same is true for this y array, that this y3 is always going to be less than or equal to this y4. This property is always going to be there. So there are no issues with that. But where the issue comes? The issue comes to the place where we don't know that whether this x1, if that is less than or equal to this y4. Same way, we don't know that whether this y3, if that is less than or equal to this x2. So in either case, we are going to do the following. First, we are going to take the smaller value. Then we are going to find that what is the partition we are trying to make depending on the starting and ending value. So currently the starting value over here is 0 and the ending value is 4. Okay, so we will, if we do that, we get the value of 2. Now we are going to take 2 values from here. If we take 2 values from here, then we will have to check that what are the remaining partition for y and how many values we are going to take from y. So currently from y, we are going to take 4 values. Now for all of these values, we are going to check that whether this x1 is smaller than this y4, and same way whether this y3 is smaller than this x2. Once the moment we find both of them to be matching, great. If we don't find anyone to be matching, suppose we find out that this x1 is actually greater than this y4. If that is the case, then what needs to be done? Well, the idea is simple. Because this is a greater value and this is a smaller value, which means that this x1 has to go on the right side and this y4 has to come on the left side. Now you will ask that why both of them has to happen simultaneously. Well, if both of them does not happen, how are we going to maintain the number of elements that are needed? Because currently the number of elements that are needed are 6 on this side and 5 on this side. So we have to make sure that we maintain that property. So how can we do that? We can do that by shifting this ending point to come on this side. And rather than keeping like both of these values, we might only keep one value over here and we will try to keep 4 values from here. And same way, if we find that this y3 is greater than x2, again we are going to repeat the same process by shifting the starting point on the right side and repeating the same process. So let me quickly explain the whole process with some examples, and then it is going to make things a lot easier to understand. Okay, so now suppose this is the example of x and y values we are given. I have calculated the total number of elements we have, which is 11 in this case, which means, as explained previously, the left partition that we will have to make, that is combined of x and y elements, that has to be of size 6. Now for this x partition, what we are going to do is, depending on the starting and ending value divided by 2, we are going to calculate that how many elements are needed in the x position, and based on that we would calculate that how many elements are needed in the y from the y side or from the y side of array, based on this formula of like 6 minus whatever the value we achieve from this x position, and then we will try to compare the values. So first of all, okay, currently this value is 0, this value is 4. If we do like 0 plus 4 divided by 2, we get value as 2. So now, which means that inside this x portion, we are going to take 2 elements, which means for this y portion, we will have to take 4 elements from this y. So now, because this is the left portion, we are going to take the leftmost 2 elements inside the left array, which is 0 and 3 in this case. And from this y portion, we will have to take 4 elements, which means we are going to take the first 4 elements over here. Once done that, basically now we have our left partition setup. So now, because we have our left partition setup, we can automatically create our right partition from the remaining values, which are, now we know for sure that this 3 is always going to be less than this 5, because they both belong to x array, and same is true for these two. The thing is, now we are going to do the cross comparison. So currently this 3 is less than 13, which is great, that we don't have to worry about anything. The thing is, for this 12 is actually not less than this 5. 12 is actually greater than 5, which means that because we have some element inside this y array which is greater, we will have to move this one on this side, and we will have to move this value on the left hand side. So now what we are going to do is, because we will have to add more values from the x, we are actually going to shift our starting point. So where we are going to shift our starting point, the idea is that previously we had the values of s plus e equal to 0 plus 4 divided by 2, like, okay, this value. So we had the middle point as 4 divided by 2 is equal to 2. So now, because this is a binary search, we are actually going to do like 2 plus 1 for the starting point. So now our new starting point comes at position number 3. Okay, so now this is the new starting point, this is the new ending point. Now again we are going to use the same logic. So now for this x partition, a few things have changed. So currently our starting position is 3, ending position is 4 divided by 2, which is 7 by 2. So we get the value 3.5, but we use the ceiling value. So now from this x portion, we will have to take 3 elements. So if from the x portion, we will have to take 3 elements, which means even from the y portion, we will have to take 3 elements. So let's do that. So this is how the two partitions are going to fall now this time. Now again we compare. Okay, so this 5 is less than 12, so which is good. Now this 8 is still greater than 6. So again we will have to move one element from this to the right hand side. So again we are going to update the value inside our x pointer to move the s element to the next side. So how we are going to do it? Okay, currently this value is 3, this value is 4. So now again we are going to repeat the same process. So we get the value, okay, 3 plus 4 divided by 2. So we get the value of 7 divided by 2, which is 3. Okay, so now we get the value to be 3 plus 1. So this is going to be the new start point. So currently our start and end point, they both fall on the same position. So this is the start point, this is the end point. Now again for this x partition, let's see that how many elements we are going to need. So we will have value 4 plus 4 divided by 2. So 4 plus 4 divided by 2 is going to be 8 divided by 2. So the value is going to be 4, which means we are going to need 4 values from the x partition. So from the y partition, we are going to need 2 elements. So let's do the math, and now let's create the new partitions. Okay, so these are the two partitions we have. Now let's compare. Okay, so 6 is less than 8, great. 2 is less than 11, great. So now we have created two partitions such that on the left hand side we have 6 elements, on the right hand side we have 5 elements. We were able to calculate that using the total elements we had. The sum we used was total plus 1 divided by 2, so 11 plus 1 divided by 2, so we get 6 elements on the left hand side. Now from these 6 elements, because the total length was odd, so because of this was odd, so what we are going to do is from this left portion we are going to select the maximum value. Now you would say that, hey, do we need to calculate all the values on the left portion to calculate the maximum value? And the answer is no. Why? Because all we have to do is check these two values. Whichever is greater value is going to be the maximum value on the left portion, because all of these values are sorted. So amongst first 4 values, this is the maximum value, and same way amongst these two values, this is the maximum value. So if we compare the maximum value between these two, basically we will get our desired answer, and in this case the answer is going to be 6. And because this was the odd case, this 6 is going to be the median that we are looking for, and this is going to be the correct answer. Now let's take one more example with odd case and see that how things work out over here. Suppose this is the second example we are given. I did some math, so total number of elements we have is 12, which means that if we want to calculate that how many elements we need in the left portion, basically we are going to do like 12 plus 1 divided by 2. So in this case we get the answer to be 6.5, but we choose the ceiling value, we choose the floor value, which is going to be 6. Now for this x portion, we are going to do like starting plus ending divided by 2. So first, currently the starting and ending positions are this one. So we get the value to be now, which means we are going to take 2 elements from the x portion. So if we are going to take 2 elements from the x portion, we are going to take 4 elements from the y portion. So let's do that. These are the two partitions that we have created. Again, let's compare the values. So first, 8 is less than 6. No, that is not true. 8 is actually greater than 6. The moment we find 8 is greater than 6, we will have to move this 8 on the right hand side, and we will have to move this 6 on the left hand side. So let's do that process. So in this case, now what we are going to do is we are actually going to update our end value to come on this side. So again, previously what was the end value? The previous end value was position 4. Now the new end value we are going to create is we are going to find the middle value. So the middle value currently is 0 plus 4, depending. I'm talking about these like starting and ending values. So 0 plus 4 divided by 2. So this is the middle value is 2. So for this ending value, we are actually going to do 2 minus 1. So now let's update our ending position. So our ending position is now going to come at this position number 1. Okay. Now again, we have the updated value of starting and ending values. So now let's try to calculate this x portion and y portion again. So for now, this time this x portion is actually going to be 0 plus 1 divided by 2, which is going to be like 0.5. But again, we are choosing the floor value, so we will get the value to be 0, which means we are going to take 0 values from this x portion. So if we are taking 0 values from this x portion, which means that we will have to take 6 elements from this y portion, which is okay, cool. No, nothing wrong with that. Okay, so now we have these two values. Now let's do our partition. So now we have created our two portions. Now in this case, because from this x portion, we are not going to take any values. We currently have 0 values, right? Now the thing is, previously we have been comparing like this. The thing is, currently in the x portion, we actually have 0 elements. So if we have 0 elements, how we are supposed to compare with this one? The idea we are going to use is that every single time we are going to compare we are going to consider that this like first value is actually negative infinity, and this last value is actually positive infinity. So the minimum and maximum value possible on each one of side. So in any case, we come up to this edge case where we need to find, we don't have any values on one portion, we don't get stuck. So we will try to consider this to be negative infinity value. Now negative infinity value is always going to be less than whatever value we have. So it's always like going to be less than 15, which is great. Now we compare these two values. So 7 is actually greater than 0. So because 7 is greater than 0, now what we will have to do is we will have to move our 7 to go on the right side, and we will have to try to bring one element from this x portion. So let's do that. So now we are again going to update the values of our starting and ending values. Now this time we will have to update the start value to go on the right side. So currently the starting position is 0, the ending position is 1. Okay, so the new start value, we will have to find the middle value. So middle value is going to be 0 plus 1 divided by 2, which is going to be 0. We have already established we are trying to taking the ceiling value. So the new starting value is going to be 1. So let's update that, and now we will try to recalculate the whole thing. Now this the number of x element is going to be 1 plus 1 divided by 2. It is going to be 1. So we are going to take one value from this x position, which means we are going to take 5 values from the y position. So let's compare x and y positions. So now we have our two partition setup. So if we compare the 0 with 7, the 0 is less than or equal to 7. That is correct. If we compare the 6 with 8, 6 is also less than or equal to 8, which means that this is a correct partition amongst left and right values. Now in this case, the combination value is actually even for left and right case. So because this is even value, what we are going to do is we are going to pick the maximum value from this one. So maximum value from this one is going to be 6. And we are going to pick the minimum value from this portion. So minimum value from this portion is going to be 7. Now again, same logic, we are only going to compare these two values to find the maximum value. So in this case, we will get that value to be 6. In order to find the minimum values, we are going to only compare these two values, and in this case, the value we are going to get is 7. So now we are going to do the average of these two. So we will get the value of 6 plus 7 divided by 2, which is 13 by 2. So 6.5, that is the answer, and that is the median we need to return. And that is the whole logic behind using this technique. Every single iteration, we are updating the values of starting and ending point only in the array that has the smaller length. So in this case, both the times x had the smaller length. So we are only working on that, and depending on that, we are generating our answer, and we are able to find successfully the median value. So if we calculate the time complexity in this case, the time complexity is actually going to be big O of log of minimum of m or n, and in this case, whatever the minimum value is, we would be able to find the median easily. See space complexity, in this case the space complexity is also going to be big O of 1 constant space. Why? Because in order to store the portion, we don't have to store this whole things. We are only concerned with 4 elements, like the minimum of x, the minimum of y, maximum of x, and maximum of y. And using these 4 elements, we can do all sorts of magical things. So this is a very good time and space complexity, and this is a very tough question in my opinion. So if you are able to crack this in an interview, all the companies would be like more than happy to have you as the candidate. So first of all, we are going to compare the lengths of nums1 and nums2. The idea is that whichever has the smaller length, we are going to keep it first. So if not, we are just going to call it recursively again with different inputs. Now we are going to initialize two variables called x and y, and we are going to assign the length of respective numbers. Remember, x is the smaller length and y is the greater length. We are also going to assign two variables called start and end. So start position is going to have the value 0, and end position is going to have the value of whatever the value of x is. Now we are going to run our while loop, that while start is less than end. Now first we are going to calculate that what should be the x portion. So we are going to name it as x part. Once we calculate the x portion, it's easy to calculate the y portion. Okay, now we are going to calculate 4 important characters. Those 4 characters are left value of x, right value of x, left value of y, and right value of y. Now each one of them, we are, for every single left portion, we are going to see that if that subsequent like x part or y part, if that value is 0, we will have to put like minus infinity or plus infinity for those values. If not, we will put whatever the subsequent value we can find from this nums array. So let me calculate those 4 values. Now we have our 4 values that we are going to need. Now we are going to compare that if the x left and y left, if they are both less than y right and x right, if that is the case, which means we can simply return we have found the correct portion, and depending on whether the total number of values are odd or even, we can simply return the answer. And if that is not the case, we will have to update our start and end variables. So first let's calculate for the correct case. Now we will have to calculate that whether the sum of these nums1 and nums2, if they are odd or even. So if they are odd value, we will simply pick like the maximum value that we have on the left portion, and if it is like the even value, we will pick the maximum value from the left portion and minimum value from the right portion, average of both of them. And if that is not the case, which means the value is odd, so in that case we can simply return the maximum value. If that is not the case, we will have to check that which one end we will have to update. So first we will see that if the given x left, if that is greater than y right, which means we will have to update our end value to come before mid, or else we will have to update our start value. It's basically it. We should get our answer this way. If we don't get our answer, we can simply return 0 outside the loop, so we don't get a compilation error. Let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs pretty efficiently compared to a lot of other solutions. And I will be posting this solution in the comments so you can check it out from there. Thank you. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do valid anagrams lead code problem, and if we see some of the companies where I want to work at who has already asked this question, there are companies like Amazon, Facebook, Spotify, Bloomberg, Microsoft, Goldman Sachs, Apple, Affirm, Google, Tesla, Snapchat, Yahoo, and Uber. So that's why I am paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode easy problem and also very well liked problem. Basically we are given two strings s and t and we need to return true if they are anagrams of each other. If they are not anagram, then we need to return false. Now first of all we have to understand that what is an anagram. An anagram is basically a word or phrase that is formed by rearranging the letters and putting them in a different position, and typically we use all the original letters exactly once. So if we try to understand it with an example, suppose we are given a word like bat. So this is the original word. If we just rearrange all of these b, a and t in some other format and keep all of them in the same amount of occurrences they are already present, so we can make some words that looks like tab, bta, atb, tba, and so on and so forth. So these are all words, they are actually anagrams of this original word bat. And how we can identify that? We can identify based on if we see the number of occurrences of all the characters, they are in the same number of occurrences even in the anagram letters as well. So if we try to understand it further using couple of examples, over here we are given two examples. So this is the example one. We are given two words that are anagram and t is equal to something like this. So if we want to check that whether these two are anagrams of each other or not, what we can simply do is we can start cancelling out or comparing the letters. So a is present, n is present, again a is present, g is also present, r is also present, a is also present, and m is also present, which means all of the letters that are present in s, they are also present in t in the same amount of occurrences, which means we can return true in this case, saying that there exists an anagram and s and t are anagram of each other. Now in this case, s is equal to rat and t is equal to car. If we try to repeat the same example, okay, r is present in both, a is present in both, but this t is not present in this string, and this c is not present in this string, which means these are not anagrams of each other, and we need to return false in this case. So let's see that what would be the different approaches to solve this problem. So the first approach to solve this problem is actually a brute force way, and in the brute force what we are going to do is we take this string s. This string is comprised of three different characters. So what we do is we make all the possible characters that we can make from this given string s. So we can make characters like a c b, b c a, b a c, c a b, so on and so forth. So we would be able to make bunch of different possible words out of this given string s, and then we compare all of them with this given t, and at any point if we encounter that there exists a word over here which is this bca is also present in this all the different pairs we created, if that is the case we will return true in this case. If it is not present, we will return false. So the solution would work perfectly fine, we will get the desired result. But the thing is, our aim is not to get the desired result, our aim is to get a desired result at a convenient cost, so which is not following for this particular scenario. And if we see the time complexity for the brute force approach, it's actually big of n square. Why n square? Because in order for us to create all of these different pairs, it takes us n square time to do it, and that's why we will have to find a better approach. Better way to solve this problem is that we sort the given string s and given string t, and once we do that we will get a sorted string, and then all we have to do is just compare these two sorted strings, because they should, if they are anagrams of each other, they should be exactly same. If they are not anagram of each other, they would not be same. So in this case, if we sort the string s, we will get a result that looks like a b c d, and if we sort the string t, we will also get the result that looks like a b c d. And both the cases, since both the strings are same, we can conclude that this is an anagram of each other, and we can return true in this case. If they are not same for any reason, we will return false. So this solution would work perfectly fine, and we will also get the desired result. If we see the time complexity in this case, the time complexity is actually going to be big O of n log n. Why n log n? Because first of all, we will have to convert this string to sorted string, and sorting takes n log n time. So that is the general time complexity. Now this is still a better approach than our brute force solution, which had the time complexity of big O of n square, and we are actually doing much better, and this is a vast improvement on this. Now we will have to check that is there any way to solve this problem in actually big O of n, and yes, there is the problem. Let me quickly show you how. Okay, so for the optimal approach, we are actually going to use an additional data structure array, and we are going to initialize an array of size 26 for the 26 characters inside the English language, and we are going to initialize all the values to have the value of 0 as the beginning. You will understand that I haven't drawn 0, but you understand that default value is going to be 0. Now the idea is we will start iterating over the string s and this string t. For any single character we identify in this string s, we are actually going to increase that corresponding value inside this given array. So suppose we encounter over here this s, then whatever the initial value of this s is going to be 0, we are going to initialize and increment its value to 1. Again, if we encounter the value I, again we are going to increment the value for this I as well. Now inside this t, we are actually going to do things in the reverse order, and we are going to reduce the value. So the moment we identify any single value, we are actually going to reduce that value from this array. And because we are using the same array, if they are anagrams of each other, remember they have the property that their number of characters and their occurrences should be same. So if they both are same, basically we at the end of our iteration, all the characters inside this given array should have the value 0. If at any point we encounter any value where the value is actually greater than or less than 0, we can determine that these two are not anagrams of each other. So after the explanation, let's try to run it with an example. So first of all, we identify that okay, this character is actually s, so initially the value of this character s is going to be 0, so we are going to mark it as 1. And over here this character is actually l, so the value of this l is going to, we will have to reduce it. So for the character l, we are going to mark its value as -1. So now okay, now next character is I. So again we will increase the value of I to 1, and over here this value is I again. So now we will reduce the value of I as well, so the value of I will remain 0. Now our next character is L. So for L we are going to increase the value. So over here if we increase the value becomes 0. And over here the next character is S. For S we will have to reduce the value, so if we reduce the value becomes 0. Now next character is E, and over here it's T. So for E we will have the value increased to +1, for T we will have value decreased to -1. Again the next character is N and E. So for N we will have the value increased to +1, and for E we will reduce one value, so this value will become 0. Now the last character is T and N. So for the T we will have to increase the value, so original value of T is actually -1, so we will increase it to 0, and this value of N is actually, we will have to decrease it, so the value of N currently is 1, so we will reduce it to 0. Now if we see over here, all the elements where you can see that there are some entries, they are the ones that are the number of characters that are present in this S and T, and all of their value is 0, and by default all the other characters inside this given array was also 0. So it becomes much easier for us to determine that whether they are anagrams or not of each other. In this case we can return true that yeah, they are anagrams of each other. This is the best approach and most optimal way to solve this problem. If we see the time and space complexity, in this case the time complexity is actually going to be big O of n. Why big O of n? Because we will have to iterate over all the characters in S and T one time, and then we will have to iterate over this given array one time to determine if all the entries are 0 or not, and both takes n time. So actually we are doing something like 2n work, but we can generalize it to be big O of n. In terms of space complexity, well, this you can argue with your customer, with your interviewer, because we are actually using an array of space 26, so it's like big O of 26, which is a constant value, so you can also consider it to be constant as well. Now whenever you will propose this solution inside the interview, your interviewer is definitely going to ask you that rather than this S and T having only English letters which are 26 by a finite number, what if we had a hash code or some other random characters that has millions of value? If that is the case, we will keep track of a hash map, and for hash map every single entry, if we encounter it inside the string S, we will do the increment operation. If we encounter it in string T, we will do the decrement operator, and eventually we would find our answer. So the logic is gonna remain same. This is just the one thing that you will have to understand. Now let's move on to coding. First of all, we are going to check an edge case that if the length of string S and length of string T, if they are not the same, we can return false immediately. If that is not the case, we are going to initialize our array of size 26 and we are going to name it as count. So now we are going to run a for loop across string S and string T, and we are going to increase our counter for any character that is present in string S, and we are going to decrease our counter for any character that is present in string T, and we are going to do both the activities inside the same for loop. For any character that is present inside the string S, we are going to increase its value inside the counter. Character that is present inside the string T, we are going to reduce the value. And after this loop ends, our counter variable should have the correct values. Now we need to iterate over all the elements inside the counter variable, and we need to check that whether is there any value where the counter value of that particular element is not 0. If we encounter any non-zero item, we can return false immediately. And if we break out of this loop, which means we did not find any entries that were non-zero, so we can return true in this case. Let's try to run this code. Okay, seems like our code is working as expected. Let's submit it. And our code is pretty efficient, and I'll be posting this in the comments so you can check it out from there. Thank you. Hello friends, we are still not employed by a FAANG company, so let's not stop LeetCoding till we get there. Today we are going to do top k frequent elements LeetCode problem, and if we see some of the companies where I want to get a job who have already asked this question, there are companies like Facebook, Amazon, Microsoft, Google, Uber, Apple, Bloomberg, Snapchat, Twitter, Tesla, Netflix, ByteDance, LinkedIn, eBay, and TikTok. So that's why I'm paying my utmost attention. I hope you also enjoy the video. This is a LeetCode medium problem and also a very well-liked problem on LeetCode. Basically, we are given an integer array called nums, and we are also given a separate integer called k. Now we need to return the k most frequent occurring elements from this nums array, and we are also told that we can return the answer in any order. So first let's try to understand this problem with this example. I have actually drawn it much bigger over here. So this is the array nums that we are given, and we are given k is equal to 2, which means we need to return top 2 elements that are present inside this given nums array, right? So if we see in this case, well, over here this 1 is actually present 3 times, this 2 is actually present 2 times, this 3 is actually present 1 time. Now if we see, we are given that k is equal to 2, which means we need to return top 2 elements, and clearly we can see that the top 2 elements in this case is this 1 and 2. So we can return the answer to be 1 and 2, or we can also return 2 and 1, because remember we are told that we can return answer in any case, and this is the answer we need to return. So let's try to see that what is going to be the approach to solve this problem. Now let me make one clarification. There are actually 2 different approaches to solve this problem. One approach, or the first approach I'm going to show you in this video, is actually sufficient for your interview. Any interview would be more than satisfied with that approach. But the thing is, the second approach I have is actually the golden key approach for any like top k element problems, right? Any heap problems, you can use the second approach, and I'm actually planning to make a separate video on that, depending on whether you want to learn it or not. So let me know in the comments that whether you want to learn this second approach. If you do, I'll make a separate video. We are actually going to use the combination of a hash map and a heap in order to achieve the top k elements. So I have created a custom example over here, and I have given the value of k is equal to 3. Now remember, whenever we need to define that, we need to return top k elements or top 3 elements in this case. How can we define that? Well, we first of all need to iterate over this given entire array. We need to find that how many times any single character is occurring, and depending on that answer, we will have to iterate over that whatever the list we create, where we have the number of occurrences for each character, and then we can conclude this answer. So one thing is clear, that we need some way to store the information that how many times any particular individual character occurs. For that, we are actually going to use the hash map. In the hash map, as the key, we are going to denote the distinct value of this given array, and as its value, we are going to note the occurrence of that particular character. So first, let me quickly create a hash map for this given input, which contains the distinct values and their occurrences. So based on this given input, this is the hash map we can create. Now we need to select k is equal to 3, which means we need to provide top 3 elements. Now one approach to find the top 3 elements is that all the distinct values we have in this hash map, if we just simply create a sorted array, and in the sorted array we sort the arrays based on the descending values, which means the most occurring value to be first, and then we put down all the remaining values, we can actually generate a sorted array that looks like this. And now for this particular sorted array, we can simply return the top 3 elements. So we can return the answer to be like 4, 3 and 5 easily. And this is the solution that would give us the correct answer. But thing is, you would quickly ask me that why did I mention priority queue over here? Because over here, what I'm doing is I'm taking this hash map and I'm actually just sorting it, and we are able to generate the array. Well, first of all, in order to understand that, first of all, let's understand the time complexity of this approach. The time complexity of this approach is, first we need to iterate over the given entire input. For that, it takes big O of n time to generate this hash map. After generating this hash map, we will have to create this sorted array that takes n log n time to generate that answer, and this n log n is going to be the ultimate time complexity. So the thing is, this you would say, hey, n log n sounds reasonable. The thing is, from n log n, suppose we have like 1 million distinct characters or 1 million characters, and we are given k is equal to 3, which means that we would have done like 1 million times log 1 million work. Meanwhile, the value of k in practice is supposed to be much smaller than whatever the input size is going to be. So the other approach is that if we create a priority queue, and remember, the concept of a priority queue is that inside the priority queue, basically we add the values and we remove the values, just like any queues. But thing is, the values that we are entering, they have some meaning behind them, and depending on their valuation, we actually store the value. So whenever over here, suppose this is the priority queue and I have provided different weight to those elements. If I want to create, or if I want to enter an element that is an higher weight, then I would get rid of only the lower weight elements and add those over here. I would not be repeating everything. So based on that concept, what I'm suggesting is that rather than sorting this array, we get rid of it. Okay, so let me clean this up a bit, and over here from this actual hash map that we have created, we actually create a priority queue, and this priority queue is going to be of whatever the size we are given of the k value. Okay, so k in this case is 3, so we are going to only have 3 values in our priority queue. Now for our priority queue, first of all, we are going to check that, okay, we only enter the values based on the number of occurrences they have, and we only keep the higher number of occurrences. So first we add the value number 1 over here because we don't have anything. Now we add value number 2 over here because we still have room and 2 has 2 occurrences. Then we add value number 3 because 3 has 3 occurrences. And remember, we are using the occurrence to add the value, not the actual distinct value, right? This is the key part. Okay, now we have this value number 4. 4 actually has 4 occurrences, right? And so far, if you remember, this 1 had 1 recurrence, this 2 had 2, and this 3 had 3 occurrences. Now we have a value that is 4 that has actually 4 occurrences, which means it is greater occurrences. So we are able to insert that value inside our priority queue, and in that case, we are actually going to get rid of the smallest value. So smallest value in this case was 1. Now we are not going to add 4 over here, but we are also going to maintain the ascending order in terms of the values that we are being added. So we'll just shift these values. Okay, so 2 will come over here, 3 will come over here, and 4 will come over here. and then we will have those subsequent values. Now after adding this, we still have value number 5 that we need to add. So 5 occurs 3 times. So 5 occurs 3 times. Currently we have 2 occurring 2 times, 3 occurring 3 times, and 4 occurring 4 times. Now 5 occurs 3 times, so 5 is able to enter over here because it occurs more times than this 2, and we can actually put 5 over here because it is also occurring 3 times and this 3 is also occurring 3 times. So we are good up until this point. After that, all we will have to do is just convert this result into an array. So for that particular array, we are actually going to store the results, and remember, we can return result in any manner. So we can return like 5 3 4, or we can also return like 3 4 5, or whatever result we want to return, we can return. And this is going to be the solution. If we see time complexity in this case, the time complexity is actually going to be a bigger improvement than our sorted array approach. Why? Because okay, over here this takes big O of n time to generate this hash map. That process remains same. But now from generating this hash map to this priority queue, it takes n log k times, because we are only maintaining k elements. This is the important part, and this is what your interviewer is going to focus on. So in this case, the time complexity is actually going to be big O of n log k, which is good. And in terms of space complexity, well, you must have guessed it correctly. It's big O of n, because we are using couple of additional data structures. We are using a hash map, and we are also using a priority queue. And this is a very good time and space complexity. And that is basically the ideal approach. Now let's move on to the coding. First of all, we are going to take care of an edge case that if the given k is equal to whatever the length of this nums is, we can simply return nums. That is not the case. We are going to initialize our hash map. Now we are going to iterate over all the elements that are present inside this given nums. So we are going to run a for loop, and after the for loop ends, we are basically going to populate the values inside our count hash map that we have just created. Now we are going to initialize our priority queue, and inside our priority queue, we are going to assign the method of insertion. So we are inserting based on the number of occurrences based on this count hash map. So let's put the condition for that. So now now everything is set up. Now all we have to do is just iterate over all the keys that are present inside this count hash map that we have created. And for every single key, basically we are going to add that value to our heap priority queue. And whenever the priority queue gets full to the size of this key, we are basically going to pop the element. And the element that will get popped is going to be the least occurring element. So we are only keeping higher occurring elements inside our heap. And now we check that if the heap size becomes greater than k, we remove the value from heap. That's it. So now all we have to do is just simply initialize a new array variable called answer, and we are going to populate this answer array. So we will run a for loop for k times, and we will keep on pulling the values from our heap. Then we can simply return the answer, and let's try to run the code. Okay, seems like our solution is working as expected. Let's submit this code, and our code runs pretty efficiently, and I will be posting this solution in the comments so you can check it out from there. Thank you. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do group Anagrams lead code problem, and this problem has been really popular at some of the companies where I want to get a job. There are companies like Amazon, Microsoft, Facebook, Apple, Google, Affirm, Snapchat, Goldman Sachs, Uber, Bloomberg, Netflix, Instacart, ByteDance, and Twitter have already asked this question. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode medium problem, and basically we are given an array of different strings, and we need to group the anagrams together. Now we can return the answer in any order, so which is good for us. And we are also given the definition that what is an anagram. Anagram is a word or a phrase that is formed by rearranging the letters and then it turns out to be a different word. So if we take an example, suppose we are given a word like bat, then we can say that these all are actually anagrams of this original word bat, because the B, A and T, they are all occurring in all of them in the same number of occurrence that it is present in this bat. So now after understanding that what an anagram is, let's try to see some examples to understand that what this question is asking us to do and what is the expected answer we need to return. If we take this first example, essentially we are given s is equal to array of string that looks like this. Now over here I have clearly marked all the groups that can be potentially done in separate colors, so you can clearly look at them. But the thing is, let's try to understand. So first of all, we are given this word eat, eat. If we see the what are the number of occurrences of characters, there are characters e, a and t occurring 1 times each. Now same thing happens for this word teat and for this word ate, which means we can conclude that all of these 3 words are actually anagrams of each other, and we can group them together in one single group. So that we are done with all of these 3 elements. Now next item we see there are 2 words tan and net. Again tan, this all 3 of them are occurring once, these 3 characters for both of these values, so we can also group them together. Now for this bat, we actually don't have any other value that we can consider it as an anagram, so this particular string will be a group of itself, which means in this case we can return an answer that looks like this, and we can return this as an answer. So clearly you would find that this answer, actually the sequencing is done slightly bit different than what is the answer given in this output. And the reason for doing that is that I wanted to show that we can return answer in any order. So that is the important part over here, that is specified in the question, that we can return the answer in any order. So that's why I ordered them differently, but as long as the groups are correct, we are good to go. One better way to solve this problem is actually by using sorting. And how we are going to use the sorting is that we are actually going to create another array for every single entry that is present inside this original S, and for all the elements that are present over here, we are going to actually sort them in alphabetical order. And then all we have to do is just we will have to iterate over this newly created array once, and we only need to find that what are all the similar pairs or all the similar values, and then we can simply return them as answer, and that makes our life much more easier. Let me quickly show you what I'm suggesting. So based on this array, we will actually create a sorted array, and the sorted array is going to look something like this. So now we have created our sorted array, and which we have derived from this original S. Now all we will have to do is we pick up any word or any string, then we just have to compare with all the other strings and find that which strings contains the same value. Whichever string contains the same value, we will take their values from the original string, because we know that they're index values, and then we can group them together. So the idea is, first of all, we'll take this string aet, then we find that okay, this and this, both of them, so the strings located at position 0, 1 and 3, they are all part of this original string that should be in the single group. So we will group them together. So in the answer we will mention eat, t and 8 as one group. Then again we will repeat the same process. So we find this ant and ant, so again we will group the whatever values located at this string at this index 2 and 4, and we find the values 10 and net, and in the end we will return this bat because it's the single one. So this solution would work fine. We will get our desired answer. If we see the time complexity, in this case the time complexity is actually going to be big O of n log n, just to create this original sorted string, multiply by k, and this k is actually the biggest length of the string that we will have to compare, and this would be the final time complexity. So this is much bigger improvement than our brute force approach, which was giving us the big O of n cube time complexity. Now let's see that can we improve any further in this one as well. Okay, before we come to the optimal solution, we will have to ask a very important question, that how do we determine that any 2 words are anagram of each other or not? Suppose we are given 2 words like ABC and CBA. We can clearly see that they are actually anagrams of each other, but how can we explicitly define that they are truly anagrams of each other? Well, we can define that based on the number of character repetition in each one of them, that any character that is present in this ABC, it is also present in the CBA in the exact same number of occurrences that both in both the words. So in other words, A, B and C is present exactly once in this particular word, and it is also exactly once present in this particular word, though the arrangement is different, and that makes them anagram of each other. Now you will ask that why am I dragging so long on this pretty trivial question that we already know the answer to? Well, we are actually going to use it to our advantage, and the good thing for us is that English language only has 26 characters. So because English language has the 26 characters, we are actually going to use it to our advantage. We are actually going to create an array of all the values that are initially located as 0, and that is going to be of size 26. Now any character that we identify in any single string, we are actually going to add it to our array, and we are going to increase the value of that particular character sequence. And then whatever the answer of that array is, we are going to put it in a string, and then we are going to use it as a key for our hash map, and then we are going to do some interesting things. So let me quickly show you that what is the full plan. Suppose over here we are given an array that looks like this, right? Now we have this given word ABC. So what we are going to do is, initially all of these values, they are defined as 0 by default, but now we are given this ABC. So first of all, we take this A, we increase its value to 1. Again we get this B, we increase its value to 1. Again we get this C, we increase its value to 1. Now all the other values, they are 0 so far. So for this particular character, we can actually create a string based on this given array of 26 words. So string would be maximum of size 26, which means it is a defined finite number, which means we can create that. We will get a string that looks like this, 111, and then remaining 23 zeros. Again we are given this word CBA, right? So again what we are going to do, first of all, we identify this character C. So we are going to mark its value as initially this was 0, so we are going to mark it to 1. Again this B, again we will mark it to 1, and again this A, we will mark it to 1. All the other values would be 0. So even for this one, the string that we are going to generate is going to look like this, 111 and 000. Now the idea is that we will create a hash map. Now inside this hash map, as a key part, we are actually going to keep track of whatever the string that we are building. So let's just name this as string builder, that we are building a new string. That would be our key. Now in both the cases, notice that for this ABC and for the CBA, this string value is actually going to be the same, that it would be 111 followed by 23 zeros in both the cases, which means that they both have actually same key value, which means that over here, okay, this is 111 23 times. But in both the cases, as the value, we are actually going to keep track of a list, and inside this list we are going to store original words that were presented as an input for this original array string that we built. So over here, first of all, we will have an entry that looks like ABC, and then we will have an entry that looks like CBA. Now we already have both the values that is part of the same group, or they are, and which is an anagram of each other, would be in the list value, which means that makes our life much more easier. That in the end, all we need to do is just we need to return this whatever value we have stored in the list. Let's do this with one of the example that we have been following so far. So I'm not going to show you the whole ordeal with the array because that is too time consuming. I'm just going to show you that what would happen inside the hash map. So this is our hash map. Now as a key, we are going to have some string value. So first of all, we get this value eat. So suppose for this value number eat, we get the string that looks something like this, right? Whatever the value is. Now this same value is going to look for this t and for this 8, which means that these values eat, then t and 8 would be a part of the same value group inside this hash map for the same key. Again, same thing will happen for this tan and net. So even again for this tan and net, suppose we get some value, that string that looks like this, right? I'm just drawing a bunch of gibberish, but you get the idea. And we will add an entry for tan and net because they both will have the same number of occurrences of characters. And in the end, for bat, we won't have any entry, so we will have a new entry over here, and where we will add the value bat. Now in the end, all we have to do is just iterate over all the values that are present inside this hash map and return it as our answer. And this would be the optimal solution we are going to use. If we see the time and space complexity for this one, the time complexity is actually going to be big O of n times whatever the maximum length of k is. In terms of space complexity, we are actually creating an additional hash map, so that's why that is going to take some additional space. But this is also going to be big O of n times k, where k is the longest length of any given string, and n is the number of string that are present inside the given input. So first of all, we are going to check an edge case, that if the given string is empty, we are going to return an empty array list immediately. Okay, if that is not the case, we are going to initialize our hash map, and we are going to take string as key and list as value. Also, we are going to initialize our array of size 26, and we are going to name it as count. Once that is done, we are going to run a for loop across the given input string. So first of all, we are going to initialize our array with value 0. After doing that, we are going to iterate over this given string s, and we are going to add all the characters inside this given array by adding their value from 0 to 1. After doing that, we are going to initialize a string builder to store the string value that we have retrieved inside this character array. Now we are going to run across the count array, and we are going to add all the values to our string builder. Also at the same time, we are also going to add a hash before all the elements inside this given count array, and that is something per language trick that changes. For Python, you won't have to do it. Once this is done, we are going to assign this new string that we created as a key for our hash map. Now we are going to check that if this entry for this given key already exists inside the hash map. If it does, we are simply going to add whatever the string s that we are iterating over, and if the entry does not exist, we will create one value inside the hash map, and then we will add this value s for this given key. And we are done for this for loop. Now all we will have to do is return all the values from this answer map and return it in the manner that is asked inside this given question. So we will have to return a list of lists. Let's try to run this code. Okay, seems like our solution is working as expected. Let's try to submit this code. And our code works as expected. I will be posting the solution in the comments so you can check it out from there. Now, if we see some of the popular companies who already asked this question, there are companies like Amazon, Apple, Nvidia, Uber, Microsoft, Facebook, Google, Bloomberg, DoorDash, Goldman Sachs, and Snapchat. So that's why I am paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode medium problem and also very well-liked problem on LeetCode. In this problem, basically we are given a 9x9 Sudoku board, and we need to determine that whether this given Sudoku board, if that is valid or not. Now, we are told that only filled cells needs to be validated according to following rules, and we are given 3 rules to determine that whether the board is valid or not. First rule dictates that each row must contain the digits between 1 to 9 without repetition. This is the key phrase, that there should not be any duplication. First rule defines that every single row must have unique characters from 1 to 9. Second row defines that every single column must have unique characters between 1 to 9. The third definition shows that the box of 3 by 3 or the sub boxes in the grid must contains the digit 1 to 9 without repetition. So this is a little bit tricky one, but basically amongst the 9 by 9 box, we can make 9 different 3 by 3 boxes where the values 1 to 9 should be present without any repetition. Now we are told that the Sudoku board in this case is partially filled, and we need to only check the boards based on the filled items, nothing more than that. So it could be possible that we cannot be able to complete the entire Sudoku, but given the filled elements, if they are at least behaving these 3 definitions that are mentioned, where every single row, every single column, and every single box, they all should have 1 to 9 unique elements, then we can determine that this Sudoku board is valid. If it is not the case, then we can determine that this is not valid. So if we take a look at this particular example, this is the example of a valid Sudoku box. And what makes this Sudoku box valid is that every single row, or all amongst all the 9 rows, the filled elements are filled in a manner that there is no repetition between 1 to 9. Now, if we just take one example, say for an example, for this first particular row, if I add one more 5 over here, then it completely makes this Sudoku board invalid, because the elements 5 is repeated 2 times in this particular row. We are not concerned with the empty cells because we can determine that can have any particular value, but if there is a 5 or any duplication present over here, we can determine this to be invalid. But let's just say that 5 is not present over here, so we are good. Same way, if I just put an 8 over here in this middle portion, then this column would be invalid, and that would make this entire Sudoku box invalid. So that is also one more thing that we need to take care of. And the third and little bit more complicated thing is the boxes that we need to be concerned with in this case. So there, as we can see from this image, there are actually 9 boxes present in any given Sudoku board, and we need to determine that 1 to 9 values are remain non-duplicated for all of them. So basically, say for an example, for this particular box, now this box currently only has one value 6, which means this box is valid because there is no duplication. But if I add one more 6 over here, which means then the 6 is repeated 2 times, so that would make it invalidated. So basically we need to take care of rows, we need to take care of columns, and we need to take care of boxes for this particular problem to solve them. Basically, I'm going to show you 3 different solutions, one for the row, one for the column, one for the boxes, and then we will find a way to combine all 3 of them. So say for example, this is the row we are given, right? Now we are only considering one row for now because same solution can be applied to all the remaining 9 rows. So that is a trivial fact. So basically, first we will try to determine, suppose this is the row we are given. What is our objective? Our objective is to make sure that all the filled values over here, they are unique between 1 to 9 and there is no repetition. So the simplest way to do is to create a hash set. So if I create a hash set, currently this hash set is empty. Maximum possible length this can have is going to be 9 because there are only 9 cells in any given row. Okay, now the logic we are going to use is that first we are going to iterate over the row. If the value, there is some value, we will try to first check that whether that value is present in the hash set or not. If it is not present, then we will add that particular value in the hash set and move on to the next element. If the value is already present, which means that there is a duplication we find, and then we can simply return false, that this given Sudoku board is invalid. So let's try to do that. First we are at position number 1. Currently there is nothing in the hash set, so because there is no value, we will add entry 1 over here, and we can determine that this node has been visited, or this cell has been visited for the row perspective, and there is nothing wrong we find. Now this one is a dot. So if there is a dot, or if there are no values, we can simply skip over that because that is none of our concern. We are only concerned with the elements that are already filled. Now the next element is 3. So we will add an entry 3 over here because 3 was already not present. This one is again empty. This one is value number 6. We will add 6 over here, and then same we will add 2 over here. And these 2 cells are not empty. So we have reached to the end of the row, which means we can determine that this particular row is currently valid and there are no issues with that. But say for an example, for this last cell, rather than adding this value, if we had one more value number 3 over here, then what would happen? Once at this position, when we add value number 2 over here, now we are over here. This one is a filled value. Because this is a filled value, we will try to see that whether this value is present in the hash set or not. Since this value is already present, this is a big no-no, and we found a duplicated entry, which means immediately we can call this entire Sudoku board invalid because we find an invalid row. So that is how we are going to determine the rows. Now currently this one only had one row, so we use just one single hash set. Say for an example, we were dealing with 9 different rows. If that was the case, what we would have to do is we would simply have to create 9 different hash sets, and basically for every single hash set we are going to repeat the same process. So this is just repeating the same process for different set of inputs. If the given Sudoku board is, let's say, 16 by 16, we would have had 16 hash sets, but still the core concept would remain same. Now the way we've solved for the box, the same way we can actually solve for the columns. Again, for the columns we are also going to create a hash set. So say for an example, this is the column. We will create the hash set and we will repeat the same logic. So currently this value number 1 is not present. We will add value number 1 over here. This 3 is not present. We will add 3. Same way we will add 6 and we will add 2. And now we are at the end of this column and we didn't find any duplicated entries. So we can say that this particular column is valid, and then we can move on to the next column. And same way for the next column, we would create a new hash set. And if any point in time we find duplicated entries, so say for an example, for the second column, we have 2 values, 1 and 1 over here. First we would add this 1 over here. Then the moment we move on to the next value and we see that, hey, in the hash set 1 is already present, we can say that, okay, this particular column is invalid, and that is why this entire Sudoku board is invalid. So this is also a very simple thing to understand. Same logic we are using, what we use for rows, we are going to use for the columns. The thing is for the box. Now for the box, this is a matrix kind of a structure, okay? And for the matrix kind of a structure, again, our main logic or the thing we need to achieve is going to remain the same, that we need to make sure that there are no duplicated entries for the filled values between 1 to 9. So again, even for the box, we would be able to create a simple matrix or a simple hash set. Now for this even hash set, we are going to apply the same logic and we would keep adding the entries. until we find any duplicate entries, and if we find duplicate entries we will call it invalid. So this is a very simple thing to do, but the tricky part is, okay, now say for an example we need to determine for rows and columns. Okay, currently say for an example we are just ignoring the boxes for now. We are only considering that how to solve this problem for just row and columns, and we need to find that we don't find any duplication between 1 to 9 for every single row and every single column. How we are going to achieve that? We are going to achieve that in the same manner I explained earlier. The only logic we are going to use is that we are going to create 9 hash sets for rows. Okay, so for rows we are going to create 9 hash sets. Every single row we are going to check for the duplicated entries. If we find any duplication, we can return invalid immediately. If we don't find the duplication, we will move on to the next row and we will keep on repeating the same process. The same thing we are going to use for the columns as well, that even for the columns we are going to create 9 hash sets. So again, and we are going to repeat the same process to check that whether there are any duplicated entries or not. And since there are none in this particular case, we can simply in the end return the answer valid. Now remember, we only solve this problem for the rows and columns. Okay, but the thing is we need to take care of the boxes as well. Now for the boxes there is just one tricky part, and that tricky part is that actually for the boxes it is not as simple as just the correlation between row and column. Because for rows we had the particular separate entries for every single rows that we can traverse over them or determine them pretty easily. Even for the columns we have the direct way to identify that whether this is a column or not. But when it comes to the boxes, we need to establish a correlation between the set of different rows and different columns. And how would we be able to achieve that? Okay, so even for the boxes basically we need to create 9 hash sets, but the thing is, how do we define which number goes where? So basically these are going to be all the boxes that we need to create. Okay, and these are the 9 boxes, but the thing is, how do we able to define the 9 boxes? The answer is quite simple. We are actually going to do a division by 3 for any particular row value and any particular column value. So that would be a very clear indicator on what box we need to choose. And let me give you a quick demo. So basically the idea is that, okay, currently this row position is 0, 1 and 2. Okay, now say for an example, if we do like 0 divided by 3, what is the value we are going to get? 0, of course. If we do like 1 divided by 3, what is the value we are going to do? We are actually going to consider the floor value, okay, not the ceiling value. So if we consider the floor value, 1 divided by 3 is going to be like 0.33. So basically in the integer it is going to be 0. So these 3 values are going to represent 0. Same way these 3 values are going to represent 0, which means if we are iterating over any of these cells, we can say that we need to consider box number 0 for that. So that is pretty good. Same way, if we are going over any other these 3 or these 3 values, so okay, this is going to be 1, 1 and 1, because if we divide them by 3, and same way this is going to be 1, 1, 1, if we divide them by 3. Same way this is going to be 2, 2, 2, and same way this is going to be 2, 2, 2. Now say for an example we are at any cell amongst this particular box. Now we need to identify that which particular hash set to select. Now this one is going to be box number 6. So hash set number 6 we need to select. Okay, but how do we define this hash set number 6 is going to be the correct one? And this is where we are going to use this formula, where for any particular cell position we are going to do this formula where we are doing row divided by 3 plus we are doing 3 and plus we are doing column divided by 3. Okay, so this is the formula we are going to use to determine that what is the correct box number. Now suppose for this particular formula, suppose we are at this particular box or this particular cell. Okay, now if we take a look at this particular cell, currently the row is going to be row number 4. Okay, row is 4 and currently the column position is going to be 7. Let's apply this particular formula for this row and column position. If we do that, we are going to do 4 divided by 3 plus 7 divided by 3. Okay, so in this case 4 divided by 3 is going to give us the answer number 1, plus 3 and plus 7 divided by 3 is going to give us the answer 2.
If we do sum of these three values, we are going to get the value of 6, and the 6 is going to determine that the box currently, if we are at this particular position, we need to check it against hash set number 6. This is the only complicated matter for this particular question. If you are able to identify a way to find the correct box, then this is a very simple problem to solve, and which we just did. So this is the whole logic. And basically now we know that how we are going to solve for row plus column plus box. The idea is that for row we are going to use 9 hash sets, for column we are going to use 9 hash sets, and even for boxes we are going to use 9 hash sets. And we already know how to determine what is the correct box we need to look at, and based on that we simply need to check for the duplicated entries. If we find any duplication, we simply get rid of it. If we don't find any duplication, awesome, then we can conclude this given Sudoku to be valid. And this is the whole optimal solution. Now if we see time and space complexity for this one, the time complexity is actually obviously going to be big O of n square. And why n square? Because we are given n to be same for both rows and columns, so that is why this is going to be big O of n square. If we see space complexity, now this one is like a debatable question, because we already know that we are going to use 27 additional hash sets. The thing is, why did we come up with this number 9? Because we are given n is equal to 9 by 9 matrix, so we are given n is equal to 9, so that is why this 9 came in. So basically space complexity is going to be big O of 3n. So in general we can write this to be big O of n. But if we are explicitly told that we are only going to use 9 boxes, then we can also conclude this to be a finite number, and this could also be considered as constant. So if you do this discussion with your interviewer, you are going to look very clear in your concepts regarding time and space complexity. Since this is already pretty long video and the coding is just a bunch of repetition, so I am just going to explain you the code, and then I'm going to paste this in the comments so you can check it out from there. So first of all, we are going to create an array of hash sets. So first we are going to create an array for row, second we are going to create for column, and third we are going to create for the boxes. And the size of this particular array is going to be the size of 9, that is given over here, and we are hard coding this value because we are basically told that this is going to be a 9 cross 9 Sudoku. Now after filling these values, we simply need to initiate the hash set for every single one of them. So we are going to just iterate over all the values, and we are going to initiate the hash set to accept the character as the input. Now we are going to run two loops. First is to iterate over the row, and second one is to iterate over the column. And using the two inner loops, like one inside the other, we would be able to iterate over the given input matrix. Now the moment we are iterating over the given input matrix, first of all we are going to determine that what is the current character at any particular position or any particular cell. Now if the value is dot, or if there is no value, we can simply continue and move on to the next element. But if there is a value, we are simply going to first do these things. First we are going to check that whether for this particular row hash set, is this value already present. If the value is already present, we can simply return false. If that is not present, we are going to add the value to that particular row hash set. Same thing we are going to do for the column, that if the value is present, we are going to return false. If the value is not present, we are going to add that value to that particular subsequent columns hash set. And then we are going to apply our formula where we are going to check for the particular box, and then we are going to check that for that particular box, if the value is present, we are going to return false. If it is not present, we are going to return the subsequent correct value. And basically if we get out of the loop, we are simply going to return true, that we did not find any place where there was invalidity and we could have written false. So now let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs decently fast compared to a lot of other solutions in terms of time complexity, and also it is very convenient in terms of space complexity. So I would be posting this solution in the comments so you can check it out from there.
Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do encode and decode strings lead code problem, and as you can see, this is actually a lead code premium problem. If we see some of the companies who have already asked this question, where I want to get a job, there are companies like Facebook, LinkedIn, Google, Square, Uber, Microsoft and Apple. So all of my favorite companies have asked this question, so that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode medium problem, and basically we are given a list of strings. Now we need to design an algorithm where we are actually encoding this given list of strings into a single string. Then we are told that that single string is supposed to be sent over a network, and then when we get back to the second machine, we need to decode that given string into the original list of strings. So let's try to understand this with an example. So suppose we are given a string s, where we are given bunch of different strings that looks like this. So after this, we will actually create an encoded string. Now this encoded string is combination of all of these four items, and it is just a single string. So let's say that this is the encoded string we have created. Now after creating this encoded string, we need to write a function to decode the string as well. And after we decode the string, we should get a response that exactly looks like this, and this would be the original decoded string we would get. And this is what we need to return. So we need to return the algorithm to encode the string and also an algorithm to decode the string. So let's see that what would be the different approaches we can take. Okay, suppose this is the original string we are given, and we need to encode the string and decode the string. The idea is we are actually going to use an extra character, and where we are going to use an extra character, we would put it where one string ends before other string starts, and we will keep on repeating the same process. And all we have to do is, so that would be the way to encode the string. After encoding the string, when we have to decode, we will just simply take that character, and the moment we reach that particular character, we would know that okay, this is the place where one string ends, so we would create a new string for that, and then we will repeat the same process. So let's see that in action. So first of all, suppose we take this character that looks like this hash, right? I'm just taking any random character. The idea is you can discuss with your interviewer that what kind of character you can take. So suppose I take this hash. Now I do encoding string. So the encoded string is going to be AB. Then the moment I identify that this strings ends over here, I would put a hash, and I would keep a continuous string. Now I realize that okay, this is a new string B, so I would add a value B. Again I would put a hash. Now again this value is C, again I would put a hash, and again at the end I would find this value ABC, and that would be the end of the string. So now I have created an encoded string. Now if I want to decode the string, the decoding would work like this. So first of all, I'm iterating until I find that this is a valid string. So valid string is AB. Now I realize that okay, this is the hash, and hash is the character that I put it as an extra character as an encoding mechanism. So I would remove this hash, and I would treat this as a single string. Now I would again start creating a new string. So again I find this value B. The moment I encounter the string hash, I would treat this B to be a separate string. Again I would encounter this value C, and again I would encounter this value ABC, and this is the way we are going to encode and decode the string, and this solution would work as expected. If we see the time complexity in this case, the time complexity is actually going to be big O of n. Why? Because we will have to iterate over all the characters that are present inside this given string s to first of all encode and then decode. So overall it would be 2n, but we can generically write it to be big O of n. Now if we see the space complexity in this case, the space complexity is actually not that much, because we anyways will have to create an encoded string and decoded string, and all we are doing is just using an extra space to solve this problem. So this is pretty simple to me. Okay, suppose this is the string we are given, and the idea is we are actually going to add 4 bits that are going to store the length of any given substring, and then we are going to keep on repeating the same process, and we are going to create the encoded string. So let me quickly show you what I am suggesting. First of all, we would have an encoded string where first 4 character is actually going to store the information that what is the next length of substring that is coming that we are going to iterate over. So in this case, this is actually length 3. So if we add it in binary, it's represent as 0 1 1. So we are actually going to have 0 0 1 1 to be the length, and then we are going to store these 3 characters as A B C. Okay, now we are done with that. Again now this ends the first substring, so now this is of length 2, so length 2 becomes 0 1 0. Now we are going to do the same thing, and then we are going to store this value AB, and now this is also of length 2, so again we will repeat the same process, and we are going to store the value of x and y, and this is the encoded string. What we have done basically is we have actually created block of 4 bits that keeps the information that okay, in the next subsequent value, these are the 3 characters that you will have to iterate over, and that is how we are going to decode it. So let's see the decoded string in action. In the decoded string, first of all, we are going to iterate over this given encoded string. Now we iterate over these 4 characters and we find that okay, value is actually 3, which means that next 3 characters are the characters of one of the substrings that we will have to separate. So we will iterate over these 3 and put it in a substring, and we will get a substring like a, b, c. Again we will iterate over these 4 characters and we realize that the value is actually 2. So because 2, we will have to iterate over these 2 elements and we would get the value ab. Now again we would iterate over this next 4 bits and we find that value is actually 2 again. So we will iterate over 2 more characters and we will get the value xy, and then we would have a decoded string. So this is also another way to store all the values. Now this solution also works as expected, but I don't think that anyone is able to come up with this in the interview. So I just showed you this approach just for the explanation purposes, but actually I'm going to, in the coding, I'm going to show you the first approach that I solved earlier. So first of all, we are going to do the encode function. So let's take care of some edge cases first. If that is not the case, we are actually going to take a random variable that is not part of this original given string. So we are given the condition that there could be 256 characters inside the ASCII character for this given string I. So what we are going to do is we are going to take the 257th character as the character that is a separator between any 2 strings. So first of all, let's just create a string called a separate, and we are going to assign the character 257 to it. Now we will start building our string. Now we will iterate over this given list of strings. So first of all, we are going to append the value of whatever the string we are iterating over, and the moment this string ends, we are going to add the separate character. Once this loop ends, basically we should have done with encoding our string. Now all we have to do is just delete the last character because that would be an additional room. And once that is done, all we have to do is just simply return this new string builder we have created. So now we are done with encoding our string. Let's decode our string. If this given string s is actually of size whatever the located at 258, which means we are dealing with an empty string list. So in that case, we will simply return a new array list and we should be done. If that is not the case, which means that we have a separated string, so let's just assign a new character. All we have to do is just return an array list where we are going to separate based on this given separate character. And that's it. Let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our solution is actually pretty fast compared to a lot of other solutions. It's not most optimal because I did not choose the approach 2. And let me know if you want to see the code for approach 2 as well. Thank you. Hello friends, we are still not employed by FAANG company, so let's not stop LeetCoding till we get there. Today we are going to do longest consecutive sequence problem, and this problem has been asked in Google, Microsoft, Facebook, Apple, Goldman Sachs, Uber, Twitter, ByteDance. So it's a lot of companies and a lot of huge ID companies that have asked this problem. So I'm going to pay my most attention. I hope you also do it. And I just have one request for all of you guys. Like my YouTube channel, if you see, most of the people, they are not even subscribed, and it takes a lot of time and a lot of effort to make these videos. So I would really appreciate if you can just subscribe. Like basically we are given an unsorted array of integer nums, and we need to return the length of longest consecutive elements inside the sequence. Also, there could be possible that there might be duplicates in our given unsorted array. So we just need to take care of those as well. And let's try to understand this with an example. So the example we are given over here is, and over here, if we find that what is the longest consecutive sequence we can find, the longest consecutive sequence we can make is 1, 2, 3, 4 amongst these values. And we can ignore just this 100 and 200 because there does not exist any consecutive sequence from those values. So over here, since we found 4 elements, we can return the length of this as 4, and this would be our answer. Same way, if we take another example, over here we are given 9 elements, and all 9 elements are actually part of the longest longest consecutive sequence. So in this scenario we are going to return 9. So in the brute force approach, we are not going to do anything clever. We are just going to take the most basic approach that we can and try to find the longest consecutive subsequence. So suppose at any moment we are given an input like this, we are given an empty list. We can say that there exists 0 longest common subsequence elements, and suppose we are given an element like this, suppose this is 100, we can say that there exists exactly one longest common subsequence element in this given input. So that is a given, right? That even if with a single element, we can at least define that there exists one single longest common subsequence element. Now over here in this example, since we know that there are at least more than 0 elements in this given input, and initially we are at this 100th position, which means that we can say that the current longest consecutive subsequence we can find is 1. And now if we want to find a subsequence in the remaining group that consists this 100, how can we do it? Like, we can only do it in one scenario, that in this remaining portion, in this remaining elements, if there exists element 101, if this exists, we can say that 100 is also part of the or could be part of the longest consecutive subsequence. So this would be our basic approach, that at every single position we will try to find that whether the next elements could they be in the remaining input, and if they do, we will update our longest consecutive subsequence, and whatever the maximum value we find, we are going to return it as our answer. So we will also create another variable called current subsequence, and that would take care of what is the current subsequence that we are trying to find. Let's just name this current. Okay, and initially the current subsequence is also at also 1 over here at this 100th position. Now we'll try to see that whether this 101 exists in the remaining portion, and it does not exist, which means we will move forward. So we'll move forward with the element 4. Now for this element 4, we need to see that whether element 5 exists or not. So element 5 also does not exist, so we'll move on with just 200. For 200 we will see whether 201 exists. This also does not exist. For this one, we will try to see that whether 2 exists. So 2 exists in the remaining array. Now because 2 exists, the current subsequence we had was of value 1, we will update it to value 2. Now because this 2 exists, we can not break right now. We'll try to find more values. So we'll again try to see that whether 3 exists, and 3 also exists, which is over here. So again we will update this value to 3. Again, because 3 exists, we will try to see whether 4 exists. 4 also exists, and it is present over here. So we will update the current value of longest consecutive subsequence we have found to 4. Now we will try to see whether 5 exists. Now 5 does not exist, which means that 4 is the longest we have found so far, and then we will try to update the value of longest consecutive subsequence we have found to whatever the current value is, because previous value of this was 1 and now this new value is 4. But we are not done yet. We have only checked up until this 1. So now we will check for this 2. So again for this 2 we will, and by the way, we will re-evaluate this value back to 1, because now we are starting with the new element. So again for this 2, 3 exists, so we will update the value to 2, and 4 also exists, so we will update the value to 3. But we cannot update the longest common subsequence because 4 is greater than 3. And now we again check for this value number 3. So for value number 3, 4 also exists, which means that this value would become 2 for this value number 3, but we won't update, and in the end we are going to return this 4. So this is our brute force approach. Like, this solution works, we get the desired answer. But the thing is, we get the desired answer at a very bad cost. Like, even if we just try to calculate the time complexity, in this case the time complexity would actually be big O of n cube. Why n cube? Because we will need to iterate over every single elements at least once to find the longest common subsequence. So that is n amount of work. Then suppose over here we are initially at this position 100. So we wanted to check that whether 101 exists. So in order to do this check, we will also have to iterate over the entire loop. So then in that case, we will have to do n more work. And at any given moment, suppose over here we identify that for this one, 2 also exists, right? And once we identify that 2 exists, we will again check whether 3 exists. Again we will check whether 4 exists. Again we will check whether 5 exists. So even to do these checks we will have to do n more work. So again we will do n work. So in total we are going to do n times n times n, so n cube work to solve this brute force approach, and this is a very disastrous solution. Now one better approach we can think of is, suppose that with the given input, if we do some sort of modification, can we come up with better solution in faster time complexity? Like, of course we can. So remember that what we are needed over here is that we need to find the longest consecutive subsequence of this given input, and we are going to see with this custom example how can we modify the input and how can we come closer to solution. So suppose in this given example, rather than keeping the input just like this, if we do sort the given input, things become much easier for us. And let's see that what would be the sorted result. Okay, so now we have our sorted result. Now in the sorted result we simply need to find that what is the longest common subsequence that exists, longest consecutive subsequence that exists. And it's pretty simple to find now, because all we need to do is that at any point we know that the definition of common subsequence is that, suppose we are currently at the value I, then I plus 1 would be a common subsequence, then I plus 2 would be a common subsequence, and this is the only condition we have to take care of. And the only other thing we need to worry about is having two duplicate values right next to each other. If at any point we encounter two duplicate values, we simply ignore one of those values and move forward. So in this example, we are only going to do two checks with the sorted input. First check we are going to do is, at first position we are going to check that whether this position is exactly same as whatever the previous position we had. If that is true, we would skip over, because we don't need to do anything with that, because there are two same values. And if that is the case, so which is the case in this scenario, that both values are same, which means we would skip over. So we would go to the next element, and now we are at this next element. Again we are going to check that the value we are currently at and the value before that, if they are same or not. So in this case they are not same. If they are not the same, we are also going to check one more thing, that whether the current value of a of I, so suppose this 0 is actually a of I, and minus whatever the value of a of I minus 1. So a of I minus 1 in this case is minus 1. So if difference between these two values, if it becomes exactly 1, which means we can conclude that these two values are part of the longest common subsequence, and we could update their value. Again like brute force, we are going to use two variables. One variable to keep track of longest common subsequence we have found so far, and second one is to keep track of the current subsequence that we are working on. So let's see that how it would work. And both the values would be set up as 1 initially. Now initially we are at this 0 and 1 pair, and because they are sorted, we know that they are always going to be adjacent to each other. So this is the only condition we need to worry once we identify that the both values are not same. So in this case we can say that the current subsequence we have found is actually size 2. So we can update the value over here, that this is 2. Now again we check with this value. Now this value again it's 0, and it's the same as this one, so we ignore it. We don't need to do anything. Now again we check with this value. So this value is actually 2. Now with this 2, if we put down this equation, so 2 minus 0, this is not equal to 1, which means that this 2 and 0 are not part of the common subsequence. If they are not part of the common subsequence, we check that now we can't update this current anymore. So we check between the current and longest common subsequence we have so far, and the current is actually greater, which means we will update the longest consecutive subsequence to 2 as well. And now current we will put it back to 1, because we will repeat our search again. Now we are at this position 3. So 3 and 2 are not same, and 3 minus 2 is actually 1, which is true, which means we update our current. So current would become 2. Now we are at this 4. Again 4 minus 3 is equal to 1. So again we update our current to 3. Again we are at this 5. So again we need to update our current. So current would be updated to 4, because all of these values 2, 3, 4, 5, they are in a common subsequence. Now we are at the 7, so 7 minus 5, they are not equal to 1, which means we can't update the current, so we will need to reset the value of the current. So before resetting the value of the current, we are also going to check that whether the longest common subsequence needs to update, and this needs to be updated to value 4 because this one was 4 before because of these 4 values. And now we can set this value to 1 again at this position 7, and now we are at this position 200, so 207, they don't have any correlation, so we can't do anything about it. And in the end, at the end of the loop, we are simply going to return whatever the longest common subsequence or current subsequence, whatever the maximum value we have found between these two, and in this case the maximum value we have found is actually 4, so this would be our solution. Now this solution works pretty efficiently, it's pretty neat, and if we see the time complexity, we can complete everything in just one single iteration. So we are only doing n work, but the thing is the time complexity in this case would be go of n log n, because initially remember that from this given input we will actually have to sort the array as well, and sorting takes n log n time. But overall, if we still compare it with whatever the brute force approach we had, brute force was actually big O of n cube. So this was really bad time complexity, and this is much more and much bigger improvement upon our scenario. Now in the optimal solution, we are actually going to try a couple of things. First thing we are going to do is we are going to create an additional data structure called hash set, and in the hash set we are going to enter all the values that we have found from this array. So suppose we create a hash set something like num set. Now in this hash set we are going to add all of these values. Now because we have our hash set ready, what we are going to do is when we are going to iterate over this hash set, and we are only going to start checking for the longest consecutive subsequence from the elements that could be at the start of the longest common subsequence. And what elements can be start of the longest common subsequence? Well, so if we take this example, we can actually see couple of common subsequences or consecutive subsequence. One consecutive subsequence we can find is 99 and 100, which is at these two positions. And second consecutive subsequence we can find is actually 1, 2, 3 and 4. Now in the what we were doing in the brute force is we were checking at every single position that what would be the longest common subsequence we can find. The thing is we can only find the longest common subsequence from the first element of the start of this consecutive subsequence. Same goes over here, that whatever the subsequence we can find at this value number 100, the subsequence that we can find at value number 99 would always be greater than whatever we can find over here, because this by itself is already a subsequence. So we are going to use this logic. Like over here, if we put this 3, 2, 3, 4, we will only find the consecutive subsequence of length 2. But this 2, 3, 4 would be of length 3, and this 1, 2, 3, 4 would actually be of length 4. So we can only find the maximum consecutive subsequence at the start of the any subsequence, not somewhere in the middle. And the only way to check that whether we are at the start of the subsequence or not is by just checking one very simple condition, that at any point we check that whether the exact value before that value, like one value before the value we currently are at, if that exists, which means that we are not at the start of the common subsequence. Let's take it by an example over here, and let's see that what would be our approach. So first of all, we are going to be at this position 100. We are going to check that whether this 100 is a start of any consecutive subsequence or not. So we check that whether in this given num set does the value 99 exist. Now we know that 99 exists. So because 99 exists, 100 cannot be at the start of the common consecutive subsequence. So we are going to ignore this case. We don't have to do anything with this 100. We come up at 99. Now we come up at this 99. We check that whether there exists a value before 99. So 98, does it exist in this num set? 98 does not exist, which means that at 99 we can be at the start of any common consecutive subsequence. So we start a subsequence at 99, and now we will initiate our logic. And in our logic, we are simply going to check that from this 99, how many consecutive numbers we can reach. So we are going to check that, okay, 99 by itself is a common subsequence of length 1, so we know that. Now from this 99 we are going to check that can we reach value number 100. So 100 we can reach, and because we are using a hash set, we can do all the operations in constant time, so we are not adding any strain in our time complexity. Now we can find the value 100, so we can reach 100, which means that the whatever the longest common subsequence that we longest consecutive subsequence we found, we will increase its value to 2. Now again we will try to see that whether we can find 101. Like 101 does not exist, which means we would break out of over here, and the longest common subsequence we have found up until this point is actually of length 2. Again we are going to repeat the same process. So now we are at this position 4. We check that whether 3 exists in this set or not. So 3 exists, which means we ignore this 4. Now again we are at 200, so we check that whether 199 exists. So 199 does not exist, which means 200 can be start of the any consecutive subsequence. So we again check that whether 201 exists, but 201 does not exist in this given example, so we ignore this 200 as well, because the longest consecutive subsequence we find at this value number 200 is always going to be 1, and we already have a value that is greater than 1. Again we check at this position 1 that can 1 be start of any consecutive subsequence. So we check that whether the 1 minus 1, so we check whether 0 exists in this example or not. 0 does not exist, which means 1 can be start. So now we set our current subsequence to value number 1, and now we check that from this value 1 how many other values we can reach to. So first we check that can we reach the value number 2. Yes, we can reach value number 2 because 2 already exists. So we update whatever the current subsequence we can find to 2. Now from this 2 we check can we reach 3. Again we can reach 3, so we will update the current value to 3. Again we check that whether from this 3 can we reach 4, and yes we can reach 4 as well. So again we will update the value of our 4 value of the current subsequence to 4, and from 4 we check whether we can reach 5. So 5 we can't reach, which means we are at least able to reach this 4. So we are able to see that the current the longest current subsequence we have found is 4, and previous value was 2. So we will update this, so this will become 4. And now again we are going to check the same thing for this value number 2, so that for value number 2 does 1 exist and 1 exists, so we will ignore this. Again we check for 3, does 2 exist, 2 also exists, which means we are going to ignore this 3. And now since we have reached the end of this hash set, so we are going to reach whatever we found in the as the longest consecutive subsequence, and this would be our answer. Now if we calculate the time complexity would actually be big O of n in this case, because we are only iterating over the entire input just once through this hash set. So this is a very efficient time complexity. And if we see the space complexity is actually big O of n, because we will have to create this additional numerical set, and we are going to store n memory for that. And let's see the coding. I will be showing the hash set solution in this code, but I'm going to post both the codes in the comments so you can check it out from there. So first of all, we are going to check that whether we are given an empty list or not. If that's not the case, first of all, we are going to create a hash set. We are going to name it num set. Now we'll run a loop across the given input, and we are going to store all the values to our hash set. This is going to do two things. It's going to eliminate all the duplicates values, and it will only add unique entries in the hash set, because hash set has a property that does not allow us it to store duplicate values. Now we are going to create a parameter to store the longest subsequence, and we are going to initialize it with value 1. Now we are going to run a for loop across the given num set. So initially we are going to check that whether we are starting from the middle of any longest consecutive subsequence. If that's the case, we are going to ignore that number. So if this condition is true, we are going to continue and go to next element in the loop. If this is not the case, we are first of all going to mark the number we are at as current number, because this is the beginning of any longest consecutive subsequence. We are also going to create another parameter called current sub that is going to take care of the current maximum consecutive subsequence we can find, and we are going to initialize it to 1. And now we are going to put a condition that while our hash set contains the current number plus 1, while this condition is true, we are going to increase the number, and we are also going to increase our current subsequence. And after this loop ends, we need to check that whether we have found the longest common subsequence or not. So once this loop ends, we should have our answer in the longest sub variable, so we can simply return that. Let's try to run this code. Okay, seems like our solution is working. Let's try to submit the code. And seems like our solution works pretty well, and it is faster than a lot of other solutions. I will also post the sorting algorithm solution as well, so you can check it out from the comments.